Frege's logic. Danielle MacBeth. Contents. Preface 7. 1. 1/8. 1.1 The fundamental idea of Frege's conceptual notation 8. 1.2 Generality and the expression of laws 17. 1.3 Understanding, 2 Strategies 25. 1.4 Our starting point 35. 237. 2.1 Reading Begriffsschrift 37. 2.2 The logical justification for a two-dimensional notation 45. 2.3 Begriffsschrift Latin italic letters 56. 2.4 The diversity of logical relations 70. 374. 3.1 The advance from level to level 75. 3.2 What is a function? 79. 3.3 The expressive role of the concavity with German letter 84. 3.4 The formality of logic 96. 3.5 Mastering the instrument 108. 110. 4.1 The shape of Frege's discovery 110. 4.2 The formula language of arithmetic 119. 4.3 The formula language of pure thought 131. 4.4 The striving for truth 143. 4.5 The science of logic 152. 156. 5.1 Frege's Grundlagendefinition of number 156. 5.2 A further difficulty 166. 5.3 Russell's paradox 172. 5.4 A final reckoning 175. Preface. Although this is a book about Frege's logic, it is not a work of logic in any standard sense. No theorems are proved, and few technical results are discussed. My aim is rather to develop a novel reading of Frege's logical language Begriffsschrift and to defend that reading textually as a reading of Frege's writings. I want to show that Frege's logical language, though it can of course be read as a language of quantificational logic, can also be read very differently, indeed, as a radically different kind of logical language from that we inherit from Peano, Russell, and Wittgenstein. The task is threefold: to provide a logical justification for all aspects of Frege's peculiar notation, to motivate and explain the developments in Frege's views over the course of his intellectual life, and to explicate his most developed, critically reactive conception of his Begriffsschrift, his formula language of pure thought. Frege's logical language, as it is to be read here, is something essentially new. It takes substantial intellectual work to understand it, even on its own terms. Indeed, Frege himself, on our account, came fully to understand the exact nature of his logic only many years after its RST presentation in 1879. As a result of this difficulty, no adequate defense of the reading as the denitive reading of Frege's texts can be provided here, only the ground is laid for a thoroughgoing critique of other readings and for a systematic exploration of the fundamental philosophical significance of the logic here outlined. Certainly there are in the early writings texts that also support this or that quantificational reading. For example, in the 1879 Begriffsschrift Frege seems clearly to think that an adequate specification of everything necessary for a correct inference can be given in terms of truth conditions. His early conception of meaning seems to be essentially that of the quantificational logician. That conception is superseded in the mature logic in response to fundamental problems with the seven. Early view. So it is with various other aspects of Frege's views. Already in 1879 Frege had developed the logical notation he needed for his logicist program. Only much later did he come to a fully adequate understanding of the way that notation functions as a notation of a properly logical language. It is Frege's late, hard-won understanding of his Begriffsschrift logic that is the object and goal of this study. At the heart of Frege's conception of logic is his notion of logical generality. Chapter 1 sets out both the general strategy pursued in understanding it and some of the textual motivation Frege provides for that strategy. In Chapter 2 the nature of Frege's logical language as we read it, the kind of language it is illustrated by analogy with a novel way of reading the formula language of arithmetic, one that is achieved by way of a thoroughgoing transformation of the way that notation is normally read, and an account is developed of what Frege calls genuine hypotheticals, that is, Begriffsschrift generalized conditional judgments expressed using Latin italic letters. Chapter 3 explores the evolution in Frege's thinking between 1879 and 1906 regarding the nature of functions, the expressive role of the concaviti and German letters, and the contents of the laws of logic. These developments in turn prepare the way for the discussion in Chapter 4 of Frege's Sinn/Bedeutung distinction. An answer to the vexed question of how to understand Frege's notion of sin is sketched, and again the formula language of arithmetic provides the model. The last chapter turns to consideration of basic law v, why on our account Frege thought his logicist program required it, why exactly it fails, and why logic, at least Frege's logic as it is understood here, can get along perfectly well without it. The conception of a properly logical language that emerges is, interestingly enough, profoundly Kantian in at least two fundamental respects. First, much as Kant in his transcendental logic takes the minimum unit of cognitive awareness to be items situated within the whole of nature as it is unit under the categories of relation, so Frege, in his fully developed logic as it is understood here, takes the minimum unit of cognitive significance to be the judgment as situated within the whole of a language. Though on his early view the content of a sentence is taken to be given by truth conditions that are in principle intelligible for a sentence taken in isolation, Frege's best wisdom, as encapsulated in his distinction between the Sinn and the Bedeutung of an expression, is that the thoughts expressed by sentences are constitutively related one to another in the language taken as a whole. Fregean thoughts, on our view, are inferentially articulated structures through which truth values, the Bedeutungen of sentences, are designated, where these structures are exed in turn by the rules of the language that govern judgment and inference in that language. Because Frege understands judgments to be advances from thoughts to truth values and thinks that inferences can be made only on the basis of thoughts that are acknowledged to be true, it follows that neither inference nor judgment can be understood independently of the other in Frege's logic. As the point might be put, Frege's developed conception of meaning is neither strictly representationalist nor merely inferentialist, instead, it incorporates in a quite unprecedented way elements of both. Here we hear an echo of a second Kantian theme. Cognition, Kant thinks, constitutively involves both intuition through which an object is given and a concept through which it is thought. Similarly, on Frege's account, judgment and inference, that is, the striving for truth, constitutively involve both an intentional word-world relation of designation to a Bedeutung and an inferentially articulated sense that contains a mode of presentation of that Bedeutung. Of course, the analogy is not exact, there are many deep and important differences between Frege and Kant, and thinking through those differences would certainly illuminate the logic here understood as Frege's. That, however, is a study that can be undertaken only after the logic itself is cleared. Our RST task, the task of this study, is to learn to read Begriffsschrift, and by extension Frege's writings about that logical language, in a new way. I have incurred many debts over the years this work has been in progress. Tom Ricketts and Sanford She wrote very helpful comments to an invited lecture on Begriffsschrift that I gave at a meeting of the American Philosophical Association in December 1997. I hope that here they will end responses to their objections that are more satisfactory than those I was able to formulate at the time. Tom, Michael Creamer, Mark Lance, John McFarlane, and Joan Wiener generously commented on parts of early drafts. Wolfgang Kienzler provided me with helpful comments on various aspects of a more recent draft, and two anonymous readers wrote extensive and very helpful criticisms of the penultimate draft. My most profound intellectual debt is to my teachers John McDowell and Robert Brandom. Almost every aspect of the account developed here bears the mark of their inience. I also owe a special debt of gratitude to Bob for his encouragement and support. The National Endowment for the Humanities generously provided me a fellowship in support of the project through the winter term and summer of 1997, and Haverford College generously extended that leave, with support, through the fall of 1997. I also gratefully acknowledge the encouragement of my colleagues in the philosophy department at Haverford College and the excellent research assistance of James Golick. My thanks, Nally, go to John Hawthorne and to Alexander Hawthorne. Without their patience and good humor, this intellectual adventure could not have been so deeply satisfying. Frege's logic. The RST prerequisite for learning anything is utterly lacking, I mean, the knowledge that we do not know. Grundlagen, 1884. Frege's logic is universally regarded as a notational variant of standard quantificational logic. The question whether it actually is such a logic is never raised, the grounds for doubt never explored. Why, for instance, is Begriffsschrift written in 2 dimensions with all logical signs, save for identity, presented in an array on the left? Why does Frege use both Latin italic and German letters in the expression of generality? Why does he demand that the premises of an inference be acknowledged to be true? Why does he not recognize the existential quantier? Most puzzling of all, why does he think that the notion of sin is a properly logical notion, and that a sentence can express a sense even in the case in which it fails to have a truth value? None of these familiar features of Frege's system of logic would come naturally, even as mistakes, in a quantificational logic. They are not logically motivated and, in many cases, are quite inexplicable. Yet Frege himself seems never to have had even the slightest misgivings about them. Could it be that Frege's logic is something hitherto unknown to us? My aim is to suggest that it is. In Begriffsschrift, instead of writing a multiply embedded conditional such as, say, p proper superset symbol in a linear array, one writes it thus: r q p, thereby achieving, according to Frege, a clear articulation of the sentence by writing the individual clauses, e.g. consequent and antecedents, one beneath the other, and to the left of these, by means of combination of strokes, I exhibit the logical relation which binds the whole together. But even granting that Frege's 2-dimensional notation is especially perspicuous in just this way, it is in another way much less perspicuous than a linear notation of quantificational logic. In any standard nota 1. The truth conditions of a sentence are manifest, a good notation of that logic is, as Quine once put it, designed with no other thought than to facilitate the tracing of truth conditions. 2. Begriffsschrift seems not to have been so designed. For although we can read a Begriffsschrift sentence such as PQR as saying that if not R then if Q then P, that is, as saying the same as R proper superset symbol, we can also read it differently, for instance, as saying that if not R and Q, then P proper superset symbol P. Various different, equally acceptable paths through a sentence written in Frege's 2-dimensional notation are possible, and only relative to this or that path can truth conditions be formulated. 3 truth conditions are easily formulated for any Begriffsschrift sentence, but the sentence does not itself trace truth conditions. One must read it in some one way, choose some one path among the many equally acceptable paths, in order to recover truth conditions from it. Whereas the guiding idea of the linear notation of quantificational logic is that meaning is to be understood directly in terms of truth, the guiding idea of Frege's 2-dimensional notation seems almost to be that the content of a sentence must, for the purposes of judgment and inference, be variously analyzable, that only relative to an analysis can truth conditions be formulated for a sentence. For we know that Frege faced considerable difficulties in ending publishers for his writings, difficulties that were compounded by the practical problems his 2-dimensional script posed for the printer. As he was also made to see, his strange notation furthermore presented a serious obstacle for his readers. 5. Yet he unequivocally rejected Peano's linear notation as logically defective for his purposes. As he concludes the 1896 essay on Mr. Peano's conceptual notation and my own, the Peano notation is unquestionably more convenient for the typesetter, and in many cases takes up less room than mine, but, these advantages seem to me, due to the inferior perspicuity and logical defectiveness, to have been paid for too dearly at any rate for the purposes I want to pursue. Was Frege unaccountably blind to the virtues of Peano's linear notation, or perhaps uncharacteristically stubborn in his adherence to his own notation? Or is it rather the case, as he himself claims, that for his per 2 poses only a two-dimensional notation can combine uninterrupted rigor of demonstration and maximal logical precision, together with perspicuity and brevity? If so, his purposes are not those of the quanticational logician. Two other features of Frege's logical notation provide further grounds for calling the standard reading into doubt. First, it includes a sign, the judgment stroke, to distinguish those judgeable contents that are acknowledged to be true from those that are not. Such a sign is needed in logic, Frege argues, because inferences can be drawn only from premises acknowledged to be true. 6. In presenting an inference, one must utter the premises with assertoric force, for the truth of the premises is essential to the correctness of the inference. If in representing an inference in my conceptual notation one were to leave out the judgment strokes before the premised propositions, something essential would be missing. What is essential to an inference must be counted as part of logic. A judgment stroke is not, however, essential to an inference in a standard quanticational logic. In our logics, the truth of the premises is irrelevant to the correctness of an inference. What matters is only whether the conclusion is true on the assumption that the premises are true. Yet Frege persisted in his error of defending the inclusion of a judgment stroke in his logic even after Wittgenstein had pointed out that the judgment stroke has no place in logic, at least in logic as Wittgenstein understands it. 7. Again we must ask, was Frege unaccountably blind to the point, or is his conception of logic different from the conception we inherit from Russell and Wittgenstein? Frege's use of two different sorts of letters in the expression of generality, German letters with the concavity and Latin italic letters without it, raises the same question. 8. Again there seems to be no logical justification for Frege's conventions, and again Frege persists in his error even after it has been pointed out to him. As he tells Jourdain, he could have used Latin italic letters in all cases, as Russell and Peano do, but to do so, he says, would be at the cost of perspicuity of formulae. In a quanticational logic just the opposite would seem to be true. Using different sorts of letters for free and bound variables would mask the fact that it is just those free variables that are bound if a quantier is attached. Was Frege simply confused? Or is it rather the case that the distinction he aims to mark by using one sort of letter without the concavity and another with it is a different distinction from that between a free and a bound variable? 3. The fact that Frege uses different sorts of letters with and without the concavity suggests that his concavity with German letters should not be read as a variable binding universal quantier. That it should not be so read is further indicated by the fact that Frege nowhere gives even the slightest indication that his universal quantier and his existential quantier are interdeanable. There is no simple sign in Frege's logic for the existential quantier, and it seems never even to occur to him that he could treat the existential quantier as the primitive sign for generality and then deem the universal quantier in terms of it. This is generally treated as a minor omission, for instance, by Dumet and by Neal and Neal 9, but if it is an odd one. Frege more than once remarks that the conditional stroke and the conjunction stroke are interdeanable, and in the late essay Compound Thoughts he spells out in tedious detail 6 possible binary sentence connectives, any one of which could be treated as primitive in logic. Frege clearly seems to think that knowing which choices are governed by a fact of logic and which choices are not so governed is itself a logical matter. Had he thought that there were two logically admissible quantiers usable for the expression of generality, and that the choice of one as primitive was not governed by any fact of logic, he would have said so. Yet he did not. Frege's second great logical innovation, as he thought of it after the development of his notation and the system of logic presented in Begriffsschrift, was the introduction in the early 1890s of the distinction between the Sinn and the Bedeutung of an expression. 10. This distinction, too, is deeply problematic on the assumption that Frege's logic is a quanticational logic. First, it seems not to be a logical distinction at all. Given the quanticational conception of meaning directly in terms of truth, Frege's notion of sin cannot be a logical notion, so, it is often argued, Frege's introduction of the distinction between sense and meaning in the early 1890s is really the discovery of a theory of sense conceived as a theory of the cognitive aspect of language use aimed at supplementing the properly logical, semantic theory presented already in Begriffsschrift. As Evans puts it, Frege's theory of meaning for the fragment of language he was concerned with after 1890 corresponds exactly to the theory that was implicit in the earlier works, the Begriffsschrift and the Grundlagen. The analysis of singular sentences, and the analysis of quantized sentences based upon the analysis of singular sentences. 4.4. Did not alter with the discovery of sense, rather, Frege saw more clearly what kind of analysis he had provided, and saw the need for something more. In later works, Frege was grafting onto this enduring theory his new conception of sense. 11. On this reading, which originates with Dumet, it was not qua logician, but qua philosopher, that Frege pushed his inquiries further. He wanted to give a general account of the workings of language. 12. But this does not seem to be Frege's view. Frege describes the discovery of his distinction between sense and meaning as a properly logical advance, as a thoroughgoing development of my logical views. According to Frege, his mature understanding of Sinn and Bedeutung is essential to an adequate understanding of how his Begriffsschrift notation functions. That Frege should take the introduction of the Sinn/Bedeutung distinction to be a logical advance is puzzling enough on the quantificational reading. That he should conclude in light of that distinction that a sentence can express a thought although it designates no truth value is so utterly incomprehensible that it can seem more reasonable to deny despite the textual evidence that Frege ever thought such a thing. 13. The problem, quite simply, is that because on the quantificational conception of sentential meaning the content of a sentence is given by what is the case if it is true, by its truth conditions, the idea that a sentence might express a thought yet fail to have a truth value is completely, and obviously, incoherent. What a sentence of quantificational logic expresses is given by its truth conditions. If they are satis then the sentence is true, and if they are not satis then the sentence is false. It is, then, manifestly contradictory to claim, as Frege does, that a sentence might be fully contentful, express a thought, yet fail to have either the truth value true or the truth value false. On the quantificational reading, that idea really is, as Evans puts it, the great fault line in Frege's mature philosophy of language. What can it mean on Frege's, or on anyone's, principles, for there to be a perfectly determinate thought which simply has no truth value? 14. Where thoughts, or beliefs, are concerned, surely failing to have the value true just is having the value false. 15. One might, however, equally well reason contrapositively, because, as Frege claims after 1890, a sentence can express a thought despite failing to have a truth value. His conception of meaning is not that of the quantificational logician. Certainly Frege's notation can be read as a notation of quantificational logic, and any one of his mistakes taken alone might be excusable, albeit 5.5. Oddly inexplicable. But Frege makes too many mistakes on the quantificational reading, mistakes that seem to be completely arbitrary and often manifest. Is it really credible that Frege would have made such mistakes, and so many of them? If we think this, perhaps it is only because we can see no alternative. But, it will be objected, Russell did, after all, learn quantificational logic from Frege. Certainly that is what one is told. The historical evidence suggests otherwise. In July 1900 Russell attended the RST World Congress of Philosophy in Paris and was there introduced to Peano, who told him of his new mathematical logic. That meeting, Russell says in his autobiography, was a turning point in my intellectual life. 16. Once back in England Russell quickly mastered Peano's system of logic, and by the end of September he had extended it to a complete logic of relations. Russell was euphoric. My sensations resembled those one has after climbing a mountain in a mist, when, on reaching the summit, the mist suddenly clears, and the country becomes visible for 40 miles in every direction. For years I had been endeavoring to analyze the fundamental notions of mathematics, such as order and cardinal number. Suddenly, in the space of a few weeks, I discovered what appeared to be definitive answers to the problems which had baffled me for years. And in the course of discovering these answers, I was introducing a new mathematical technique, by which regions formerly abandoned to the vaguenesses of philosophers were conquered for the precision of exact formulae. Intellectually, the month of September 1900 was the highest point of my life. 17 Russell may have had a copy of Grundgesetze in the fall of 1900, for, as he writes to Jourdain in 1910, he recalls having got Grundgesetze late in 1900. 18 But, as he goes on, I could not understand Frege's use of Greek, German, and Latin letters, and I put him away for nearly 2 years, by which time I had discovered for myself most of what he had to say, and was therefore able to understand him. Russell did not learn quantificational logic from Frege. But he did learn a logic of relations from Peirce. He knew Peirce's work while he was developing the polyadic predicate calculus, and in particular, he knew that Peirce had developed a complete logic of relations already in 1883 based on Boole's logical algebra. 19 But Peirce's logic of relations is, as Russell notes, difficult and complicated to so great a degree that it is possible to 6. Doubt its utility. 20 What Russell took to be the fundamental insight of Peirce's logic, the insight that distinguished it as a properly modern logic, lay in its drawing a logical distinction between singular terms such as Socrates and general terms such as man, and thereby treating sentences containing them as different in logical form. 21 It was just this, Russell thought, that was the serious advance in real logic since the time of the Greeks. 22 His own extension of the insight to the logic of relations was, as he describes it, a merely technical development. 23 It was Peirce's discovery, not Frege's, that enabled Russell to simplify the logic of relations enormously by making use of Peirce's notation, and thereby to discover what appeared to be definitive answers to the problems which had baffled for years. 24 By the summer of 1901 the intellectual honeymoon was over. Russell had discovered the contradiction in his logic and, try as he might, he could not discover what had gone wrong, the source of the error. It was at that point that Russell seems to have begun to study Frege's writings, thinking, perhaps, that Frege's system of logic in Grundgesetze might hold the key to a solution to the paradox. Peirce had said in his 1895 review of Grundgesetze that the work was marred by an unnecessary subtlety. Perhaps its subtlety was just what was needed to resolve the contradiction. 25 What Russell discovered, of course, was, that Frege's notation could though with difficulty 26 be read as a notation of Russell's own logic, and also that the contradiction was derivable in Frege's system as well. We have been reading Frege's notation as a notation of quantificational logic ever since. The full polyadic predicate calculus was Russell's contribution, an extension of Peirce's logic following Peirce's work on the logic of relations. Only later, after he had developed quantificational logic, did Russell read that logic back into Frege's astonishingly ill-conceived notation. Russell simply assumed that Frege had independently developed essentially the logic that Russell had developed, and in the heady early days of the discovery of quantificational logic that assumption would have been quite natural. We have no such excuse. Is the logic that Frege developed in 1879 and, by his own account, brought to maturity with the introduction of the distinction of sin and Bedeutung in the early 1890s a quantificational logic? The question has not been asked. Yet it must be asked. For the simple fact of the matter is, we do not know. 7. 1. Arithmetic was the starting point of the train of thought which led me to my conceptual notation. Begriffsschrift, 1879. Frege developed his Begriffsschrift, or concept script, as a special purpose instrument to further his logicist program of demonstrating that the truths of arithmetic are derivable by appeal only to the laws of logic and definitions. Arithmetic was the starting point. As is announced in the subtitle of Begriffsschrift, a formula language of pure thought modeled upon the formula language of arithmetic. Arithmetic was also the model for Begriffsschrift. It provided both a general model of how a conceptual notation ought to function and a model for the use of letters in the expression of laws. One Frege's mature conception of a concept is essentially that of an arithmetical function. A concept is a function whose value is always a truth value, and his understanding of the way concepts are derived from judgments is modeled on the way different concepts can be derived from identities, such as 2 4 = 16 in the formula language of arithmetic. Even Frege's mature understanding of his logical language in terms of the notions of Sinn and Bedeutung is essentially an extension of his discovery, in Grundlagen, of the meaning of an arithmetical identity such as 1 + 1 + 1 = 3. The formula language of arithmetic informs Begriffsschrift, Frege's formula language of pure thought, at every level and at every stage in its development. 3. To understand how it does and thereby how we might understand Frege's use of letters, his conception of a concept, his notion of analysis, and his Sinn/Bedeutung distinction, we need to understand his starting point, the science of arithmetic as it posed for him the problem that Begriffsschrift was to solve. That starting point will provide in turn the starting point for the reading to be pursued here. 1.1 The fundamental idea of Frege's conceptual notation. In an essay written in 1896 that compares his own notation to Peano's, Frege says that the fundamental idea of my conceptual notation is to 8. Limit to the bare minimum the number of modes of inference, and set these up as rules of this new language. The point is RST made in Boole's logical calculus and the concept script, written shortly after Begriffsschrift. I sought as far as possible to translate into formulae everything that could also be expressed verbally as a rule of inference, so as not to make use of the same thing in different forms. Because modes of inference must be expressed verbally, I only used a single one by giving as formulae what could otherwise have also been introduced as modes of inference. In order to keep to the bare minimum the modes of inference employed, all rules of inference save for modus ponens, which is required if anything at all is to be inferred for, are to be expressed in Begriffsschrift as formulae. This is the fundamental idea of Frege's notation. It is motivated, we will see, by the project of logicism as Frege conceives it. The primary value of mathematical knowledge, Frege thinks, lies not in what is known but in how it is known, not so much its subject matter as the degree to which it is intellectually perspicuous and affords insight into its logical relations. That is why it is in the nature of mathematics to prefer proof, where proof is possible, and in the nature of mathematics to achieve its full and adequate expression only in what Frege calls a system, that is, a complete and adequate axiomatization. In the Grundgesetze, the subtitle of which is Exposition of the System, Frege outlines what such a system, that is, a complete and adequate axiomatization, involves. It cannot be demanded that everything should be proved, because that is impossible, but we can require that all propositions used without proof be expressly declared as such, so that we can see distinctly what the whole structure rests upon. After that we must try to diminish the number of those primitive laws as far as possible, by proving everything that can be proved. Furthermore, I demand, and in this I go beyond Euclid, that all methods of inference employed be specified in advance, otherwise we cannot be certain of satisfying the RST requirement. To have such a system for arithmetic, one that consists of the fewest possible axioms, definitions of all non-primitive terms, and an exhaustive list of rules of permissible inference, would be to have, though in embryonic form, as in a kernel, the whole content of that science. Because the essence of explanation lies precisely in the fact that a 9 wide, possibly unsurveyable, manifold is governed by one or a few sentences, such an axiomatization is the goal of arithmetic, as of any science. Our only concern is to generate the whole of mathematics from this kernel. But not every science can be founded on logic alone. The empirical sciences, for instance, cannot be so grounded. Nor can geometry, for, as Frege argues, the truths of geometry do not govern thinking concerning all that is but only all that is spatially intuitable, whether actual or product of our fancy. Geometry, like the natural sciences, has its own special axioms, axioms that can be negated without contradiction. It follows that geometry cannot be grounded in logic alone. The truths of arithmetic, by contrast, govern the widest domain of all, for to belongs not only the actual, not only the intuitable, but everything thinkable. Try denying any one of them, and complete confusion ensues. Even to think at all seems no longer possible. The extensive applicability of mathematical doctrines is prima facie grounds for thinking that arithmetic is merely a more highly developed logic. The task of Frege's logicism is to prove that it is by showing, RST, that there is no such thing as a peculiarly arithmetical mode of inference that cannot be reduced to the general inference modes of logic, and second, that the fundamental concepts of arithmetic, its building blocks, are reducible to logic by means of definitions. 5. The aim of Frege's logicism is to develop a system for arithmetic, a complete and adequate axiomatization of the whole content of that science, revealing its ultimate grounding in pure logic. Knowing that is not sufficient, however. We need also to understand the precise nature of the defects the system is to overcome. In particular, we need to see that whereas Russell understands logicism as the project of rendering proofs deductively gap-free by including as axioms all the truths on which those proofs depend, for Frege the defect of existing proofs seems to be not deductive but instead expressive. The goal for Russell and for Frege is the same, rigorous, explicitly gap-free proofs. And both Frege and Russell take Euclid's proofs in the elements to provide a paradigm of the sort of defects they aim in their respective logics to overcome. It is clear that for Russell, the problem is that Euclid's proofs are not strictly deductive, not logically valid, because they require the use of postulates conceived as rules of construction that cannot be formulated as axioms without the resources of the full polyadic predicate. 1010. Kate Calculus. 6. Lacking those resources, Euclid could not include among his axioms, for instance, that given any 2 points there is a line connecting them, or that between any 2 points there is a third. In Euclid's system, the line that connects 2 given points, or the point that lies between 2 other given points, must be constructed according to the rules laid out in the postulates. This treatment of postulates as practical rather than theoretical propositions is explicit already in Kant. Postulates, Kant thinks, contain nothing save the synthesis through which we give ourselves an object and generate its concept. For instance, with a given line, to describe a circle on a plane from a given point. 7. The whole point of Kant's appeal to pure intuition in accounting for our knowledge of the truths of arithmetic and geometry, on this view, is to enable us to avoid rules of existential instantiation by actually constructing the desired instances. We do not derive our new individuals from existential premises but construct them from previously given individuals via Skolem functions. 8. If that is right, then Kant's conception of arithmetic as synthetic a priori rather than analytic is an artifact of his limited logical resources. Russell makes the point in a well-known passage in the Principles of Mathematics. There was, until very lately, a special difficulty in the Principles of Mathematics. It seemed plain that mathematics consists of deductions, and yet the orthodox accounts of deduction were largely or wholly inapplicable to existing mathematics. In this fact lay the strength of the Kantian view, which asserted that mathematical reasoning is not strictly formal, but always uses intuitions, i.e. the a priori knowledge of space and time. Thanks to the progress of symbolic logic, especially as treated by Professor Peano, this part of the Kantian philosophy is now capable of null and irrevocable refutation. Russell takes Euclid's proofs to be deductively invalid on the grounds that Euclid's postulates are rules of construction or practical propositions in Kant's sense. Frege takes a very different view. First, postulates have for him the same logical status as axioms. A postulate is a truth as is an axiom, its only peculiarity being that it asserts the existence of something with certain properties. 4. Frege argues, the truth of a theorem cannot really depend on something we do, when it holds quite independently of us. So the content of our postulate is essentially this, that given any 2 points there is a straight line connecting them. There is no real need to distinguish axioms and postulates. A postulate can be 1111 regarded as a special case of an axiom. Whereas Kant had argued that because the truth of the theorems of geometry does depend on something we do, namely, our constructions of points and lines in pure intuition, these truths cannot hold quite independently of us. Frege argues contrapositively that such truths do hold quite independently of us and so cannot depend on something we do. Euclid's postulates, like his axioms, are objectively valid laws, Frege thinks, albeit laws of a special science. Frege's criticism of Euclid's proofs is not that they are not, and without the resources of the full polyadic predicate calculus cannot be, deductively valid on the grounds that those proofs employ postulates conceived as rules of construction. Frege does not think of postulates as rules of construction. According to him, Euclid's postulates have the status of axioms. Frege's complaint is rather that Euclid, conscientious and rigorous though he is, often makes tacit use of presuppositions which he species neither in his axioms and postulates nor in the premises of the particular theorem. He does not meet the systematic demand that all modes of inference employed in a proof be specified in advance. For example, in the proof of the 19th theorem of the RST Book of the Elements, he tacitly uses the statements, if a line segment is not larger than a second one, the former is equal to or smaller than the latter. If an angle is the same size as a second one, the former is not larger than the latter. If an angle is smaller than a second one, the former is not larger than the latter. These are not laws of logic, they are not laws that govern formally valid inferences. They are, rather, materially valid rules that govern the correct use of the relations larger than, equal to, and smaller than as they apply to angles and line segments. Nevertheless, Frege suggests, they are valid rules of inference, they are used just like those laws themselves. They are used, that is, to legitimate inferences. But if that is right, then Euclid's proofs are not enthymematic, deductively gappy, as Russell thought, they are instead expressively gappy. Euclid should have explicitly stated in advance all the inference rules, whether formal or material, that he employs in his proofs. Because he does not, his 1212 system does not meet the demand that all propositions used without proof be expressly declared as such, so that we can see distinctly what the whole structure rests upon. Euclid's failing, as Frege understands it, does not lie in the poverty of his logical resources but instead in his not fully realizing the ideal of a system. In Logic in Mathematics, Frege's lecture notes for 1914, the same point is made again. Euclid had an inkling of this idea of a system, but he failed to realize it, and, as Frege immediately goes on, it almost seems as if at the present time we were further from this goal than ever. The idea of a system seems almost to have been lost. Here again, the problem is not, Frege thinks, that the proofs that are standardly given by mathematicians are invalid, deductively gappy, but that the rules of inference employed in those proofs are not explicitly stated in advance. Because they are not, standard mathematical proofs employ modes of inference whose source, whether in logic alone or in intuition, is unclear. The point is made again in Grundlagen, the mathematician rests content if every transition to a fresh judgment is self-evidently correct, without inquiring into the nature of this self-evidence, whether it is logical or intuitive. Often, the correctness of such a transition is immediately self-evident to us, without our ever becoming conscious of the subordinate steps condensed within it, whereupon, since it does not obviously conform to any of the recognized types of logical inference, we are prepared to accept its self-evidence as forthwith intuitive, and the conclusion itself as a synthetic truth, and this even when obviously it holds good of much more than merely what can be intuited. On these lines, what is synthetic and based on intuition cannot be sharply separated from what is analytic. Frege's demand that every jump must be barred from our deductions is not set by the thought that existing proofs are invalid. It is set by the fact that the rules of inference that govern proofs are not explicitly stated in advance and so are not self-evidently logical, that is, formally valid rules of inference. The task of logicism, as Frege conceives it, is to not let through anything that was not explicitly presupposed, to exclude with certainty any tacit presupposition in the foundations of mathematics, to exclude with certainty anything derived from other sources of knowledge. 1313. What is needed, according to Frege, is a chain of deductions with no link missing, such that no step in it is taken which does not conform to some one of a small number of principles of inference recognized as purely logical. Given the universal applicability of the truths of arithmetic, it is reasonable to conjecture that there is no such thing as a peculiarly arithmetical mode of inference that cannot be reduced to the general inference modes of logic. The task of Frege's logicism is to this nature to light wherever it cannot be recognized immediately, which is quite frequently the case in the writings of mathematicians. The chief purpose of Frege's Begriffsschrift is in this way to expose each presupposition which tends to creep in unnoticed, so that its source can be investigated. Because proofs in Euclid's geometry and standard mathematical practice employ rules of inference that are not stated in advance, those proofs, although valid, each step licensed by a valid rule of inference, are not perspicuously gap-free. They do not satisfy the demands of a system. Because they do not, it cannot be determined whether the rules of inference that govern the reasoning involved are one and all formal, that is, strictly logical laws, or whether some are instead material rules of inference such as the rule that if an angle is the same size as a second one then the former is not larger than the latter. If logicism is true, there are no distinctively arithmetical modes of reasoning. The RST task of logicism, then, is to show that the modes of inference commonly employed in arithmetic, mathematical induction, for instance, are reducible to strictly logical modes, all modes of inference that appear to be peculiar to arithmetic on the general laws of logic. The laws that govern those modes of inference are to be translated into formulae and derived from strictly logical laws expressed as formulae. Begriffsschrift Parts 2 and 3 begin the project. The theorems that are proven are translations of rules of inference into formulae. They express laws that license inferences. That is why, once they have been proven, the restriction to a single rule of inference be dropped, by converting what was expressed as a judgment in a formula into a rule of inference. Theorem 53 of Begriffsschrift, Fc equals df, for instance, can be converted into the rule that in any judgment you may replace one symbol by another, if you add as a condition the equation b. 1414. Between the two. That theorem, in other words, expresses as a formula the rule that licenses inferences such as this. 5 plus 4 7. 9 7 5 plus 4 equals 9. And the same is true of the other theorems Frege proves in parts 2 and 3 of Begriffsschrift. The generalities proven in parts 2 and 3 of Begriffsschrift express inference licenses translated into formulae. In logic in mathematics the point is made again. Modes of inference are subject to laws, and the task of logicism is to show that the laws that govern inferences in mathematics are one and all derived laws of logic. Are there perhaps modes of inference peculiar to mathematics which, for that very reason, do not belong to logic? Here one may point to the inference by mathematical induction from n to n plus 1. Well, even a mode of inference peculiar to arithmetic must be subject to a law, and this law, if it is not logical in nature, will belong to mathematics, and can be ranked with the theorems or axioms of this science. For instance, mathematical induction rests on the law that can be expressed as follows: if the number 1 has the property phi and if it holds generally for every positive whole number, and that if it has the property phi then n plus 1 has the property phi, then every positive whole number has the property phi. So likewise in other cases one can reduce a mode of inference that is peculiar to mathematics to a general law, if not to a law of logic, then one of mathematics. And from this law one can then draw consequences in accordance with general logical laws. The task of logicism, as Frege understands it, is to discover the laws that govern the inferences in arithmetic so that those laws can be either shown to be derived laws of logic or set up as axioms and derived theorems of the science of arithmetic. In order to demonstrate that arithmetic is derived logic, Frege needs to show that all modes of inference employed in arithmetical proofs are strictly logical and that all basic concepts of arithmetic are definable by appeal only to logical notions. At RST, he says, he tried to formulate his definitions and proofs in natural language. As he soon discovered, how 1515. Ever, despite all the unwieldiness of the expressions, the more complex the relations became, the less precision which my purpose required could be obtained. It was the logical imperfections of our languages that led him to devise his Begriffsschrift or concept script, the formula language of pure thought. What Frege does not say in the earliest discussion of Begriffsschrift is what exactly these logical imperfections are or how his notation is to overcome them. Only after Frege had been made to realize that the aim of his concept script, and thus the script itself, had been radically misunderstood did he characterize the defects of natural language that his Begriffsschrift was to overcome. To one interested in perspicuously gap-free chains of reasoning, natural language has a variety of defects. It is, for instance, often ambiguous, using a single word to signify two different things and even, in some cases, using a single word for what are logically different kinds of things. In natural language the same word may designate a concept and a single object which falls under that concept. It also can be very difficult to state logically complex thoughts in natural language, especially those that require multiple embedded signs of generality in their expression. Natural language uses something and it for the expression of generality, but if we were restricted to something and it, we would only be able to deal with the very simplest cases. These deficiencies are nevertheless not, for Frege, the most critical ones. The greatest defect of natural language for his purposes, the one he comes back to again and again, lies in the vast array of inferential moves it permits. If we try to list all the laws governing the inferences which occur when arguments are constructed in the usual way, we end in an almost unsurveyable multitude which apparently has no precise limits. In language, logical relations are almost always only hinted at, left to guessing, not actually expressed. An argument conducted in natural language may be perfectly valid, each step legitimate by a rule of inference, but as long as it is left open what exactly the legitimating rules are, one cannot tell with any certainty whether the argument is valid. A strictly defined group of modes of inference is simply not present in language, so that on the basis of linguistic form we cannot distinguish between a gapless advance Luckenloser Fortgang and an omission of connecting links. Nor, for the same reason, can one tell of a valid argument conducted in natural language on what its validity depends, whether only on strictly logical forms of inference or also on inference forms that belong to some special science. Showing that the truths of arithmetic are derivable. 1616. On the basis of the laws of logic alone requires XED guidelines, along which the deductions are to run, and in verbal language these are not provided. It is the excessive variety of logical forms that have been developed in our language that is, for Frege, the greatest defect of natural language for his purposes. Much as a few simple elements underlie a wide range of chemical compounds and a few words a multiplicity of sentences, so, Frege thinks, a few primitive modes of inference underlie the vast array of inference forms employed in natural language reasoning. The inferences of natural language have to be resolved into their simple components, split into the logically simple steps of which composed. Only in this way can it be determined whether the fundamental principles on which arithmetic rests are one and all logical. Overcoming the logical defects of natural language for the purposes of Frege's logicism required devising a language within which to express modes of inference more exactly, the laws that govern those modes of inference as formulae so that their source, whether in logic or in intuition, could be investigated. 1.2 Generality and the expression of laws. The purpose of Frege's Begriffsschrift notation is to enable the expression of laws governing inference as formulae in order to show that the laws that govern inferences in arithmetic are derived laws of logic. The goal is a system, a complete and adequate axiomatization of arithmetic. Everything on which an arithmetical proof depends is to be stated in advance, either as an axiom or a definition or as a rule of inference. Standard laws governing arithmetical inferences are to be translated as formulae and proved on the basis of the laws of logic, the formal rules that govern inference. In Begriffsschrift, such laws, both those that govern inferences in arithmetic and those that govern inferences in logic, are expressed as generalized conditionals. Laws, Frege thinks, are discoverable, objective truths that are nonetheless very different from merely factual truths. As Frege himself puts the point in a late manuscript, the distinction between law and particular fact cuts very deep. It is what creates the fundamental difference between the activity of the physicist and of the historian. The former seeks to establish laws, history tries to establish particular facts. In this regard, the laws of logic are no different from the laws of any other science. Logic, like any science, seeks to discover the laws that govern its domain and to 1717. Systematize those laws in an axiomatic system that reveals how some are contained in others. What distinguishes the laws of logic from the laws of other sciences is that they do not, as the laws of the special sciences do, govern merely one domain among others. The laws of logic govern the domain of truth itself. For a time, Frege thought of this difference in terms of the difference between descriptive and prescriptive laws. If we call them laws of thought, or better, laws of judgment, we must not forget we are concerned here with laws which, like the principles of morals or the laws of the state, prescribe how we are to act, and do not, like the laws of nature, deem the actual course of events. But already in 1897, when this passage was written, Frege also thought that we could, with equal justice, think of the laws of geometry and the laws of physics as laws of thought or laws of judgment. Even these laws can be conceived as prescriptions to which our judgments must conform in a different domain if they are to remain in agreement with truth. Laws of the special sciences, of geometry, or of physics, say, describe what is and must be in their respective domains and thereby prescribe how we ought to think about the objects proper to those domains. As Frege came to think, the laws of logic can and should be conceived in just the same way. The word law is used in two senses. When we speak of moral or civil laws, we mean prescriptions, which ought to be obeyed but with which actual occurrences are not always in conformity. Laws of nature are general features of what happens in nature, and occurrences in nature are always in accordance with them. It is rather in this sense that I speak of laws of truth. Here of course it is not a matter of what happens but of what is. From the laws of truth there follow prescriptions about asserting, thinking, judging, inferring. Logic, on Frege's considered view, does not contrast with, say, psychology in virtue of being a normative science whose aim is to discover what ought to be but perhaps is not. Any science that aims to discover laws rather than facts is normative in a sense. Insofar as it discovers laws governing what is, it also sets out prescriptions governing our thoughts, judgments, and inferences regarding what is. The difference between logic and psychology lies rather in the fact that whereas psychology discovers the laws of how we actually do think, logic discovers the laws of judgment itself. In so doing, it prescribes laws that govern the way in which one ought to think if one 1818 is to think at all, laws that hold with the utmost generality for all thinking, whatever its subject matter. Laws, Frege thinks, are fundamentally different from facts. They are not prescriptions, but prescriptions follow from them. Such laws are expressed in Begriffsschrift as generalized conditionals, that is, in sentences that on the standard reading of Frege's notation could equally well be written using the universal quantier and the horseshoe. This reading is called into question by three related and recurring themes in Frege's writings: that the conditional stroke is justied as the primitive sign for a logical relation in Begriffsschrift by its role in the formation of generalized conditionals, that generalized conditionals and only generalized conditionals, with one significant exception, are correctly rendered in natural language using if, then, and that causal laws are expressed in Begriffsschrift as generalized conditionals. All three themes are sounded already in the early essay on the aim of the conceptual notation. If we wish to relate two judgeable contents, 9a and b, to each other, we must consider the following cases: a and b, a and not b, not a and b, not a and not b. Now I understand by a b the negation of the third case. This stipulation may appear very artificial at RST. It is not clear at RST why I single out this third case in particular and express its negation by a special symbol. The reason, however, will be immediately evident from an example. X2 equals 4, x plus 2 equals 4 denies the case that x2 is not equal to 4 while nonetheless x plus 2 is equal to 4. We can translate it: if x plus 2 equals 4, then x2 equals 4. This translation reveals the importance of the relation embedded in our symbol. Indeed, the hypothetical judgment is the form of all laws of nature and of all causal connections in general. To be sure, a rendering by means of if is not appropriate in all cases of linguistic usage, but only if an indeterminate constituent like x here confers generality. 1919. On the whole, were we to replace x by 2, then one would not appropriately translate 2 equals 4 2 plus 2 equals 4 by if 2 plus 2 equals 4, then 2 equals 4. Frege claims, RST, that the meaning assigned to the conditional stroke, although apparently artificial, is justified by its role in generalized conditionals, and indeed that this is immediately evident in the example cited. He furthermore suggests that such a sentence, that is, a generalized conditional, and only such a sentence, is appropriately translated into natural language using if, then. Again, the significance of the point is supposed to be manifest and to require no further explanation. Frege's third point is that the hypothetical judgment, by which Frege clearly seems to mean a judgment such as x2 equals 4 x plus 2 equals 4, as it contrasts with the judgment 2 equals 4 2 plus 2 equals 4, is the form of all laws of nature and of all causal connections in general. What Frege suggests, in sum, is that the conditional stroke is correctly treated as a primitive symbol in logic in virtue of its role, in conjunction with letters lending generality of content, in the expression of laws, a role that is signaled in natural language by the use of if, then. According to Frege, the RST problem for the logician is the perspicuous representation of logical relations by means of written signs. But logics can differ in the logical relations they take to be primitive. In Frege's logic, by contrast with, say, Boole's, it is the relation that is signed by the conditional stroke that is primary. The precisely deemed hypothetical relation between contents of possible judgment has a similar significance for the foundation of my concept script to that which identity of extensions has for Boolean logic. 10. Frege does not think, however, that a mere conditional, that is, something of the form AB 2020, is a genuine hypothetical. As he puts the point, of course this alone doesn't yet give us a genuine hypothetical judgment, that arises only when A and B have in common an infinite component which makes the situation described general. Although not invariably, Frege most often means by a hypothetical judgment a generalized conditional. It is a generalized conditional and not a mere conditional that is, he thinks, what is known in the terminology of logic as a hypothetical judgment. The meaning of the conditional stroke, Frege's primitive sign for a logical relation, is justified by its role in the formation of such genuine hypothetical judgments. The outstanding importance of this judgment has persuaded me to give the sign AB precisely the meaning of the denial of the case not A and B. Frege emphasizes just this point in Grundgesetze by introducing the conditional stroke last, even after the sign for the denied article. In Grundgesetze the conditional stroke is self-consciously introduced in order to enable us to designate the subordination of a concept under a concept, and other important relations. Such relations are expressed in Begriffsschrift using the conditional in conjunction with signs lending generality of content, that is, in what Frege describes as genuine hypotheticals. The point is made one last time in the 1906 to logic. The relation designated by the conditional stroke looks strange at RST sight, and it does so, Frege suggests, because people probably feel the lack of an inner connection between the thoughts, we find it hard to accept that it is only the truth or falsity of the thoughts that is to be taken into account, that their content doesn't come into it at all. As becomes clear in the discussion of generality that follows, the logical importance of this relation lies in the general thoughts that are expressible using it, thoughts that are expressed in natural language using if. Then, thoughts that relate concepts one to another. Frege's conditional stroke, although in itself somewhat unintuitive as a sign for the primitive logical relation, is just id, according to Frege, by its role in the formation of genuine hypotheticals, which express the subordination of one concept to another. The importance of such judgments is signaled, in turn, in the On the Aim passage by the appropriateness of using if. Then in translating such sentences. The 2121 claim is reiterated in other writings both early and late. Although it is appropriate to translate, say, x equals 7 x plus 3 equals 10. As if x plus 3 equals 10, then x equals 7, in the case of the judgment. 2 equals 7. 2 plus 3 equals 10. The rendering if would jar with normal usage. In the 1906 to Logic we read that there is something unnatural about the form of words if 3 is greater than 2, then 3 squared is greater than 2, but in the context of a generalized conditional the construction with if seems most idiomatic. There is one exception. In Begriffsschrift 5 Frege discusses 3 especially interesting sorts of cases in which a conditional sentence is to be affirmed. The RST case is that in which the consequent must be affirmed, as, for example, in the case in which it is the content that 3 times 7 equals 21. The second is that in which the antecedent is to be denied, as, for example, if it is the content that perpetual motion is possible. In both sorts of cases, Frege notes, the content of the other sentence in the conditional is immaterial, and there need be no causal connection between the two sentences. It is the third sort of case that provides the exception to the rule that generalized conditionals and only generalized conditionals are correctly translated using if, then. In this sort of case, we can make the judgment A, B, without knowing whether A and B are to be affirmed or denied. For example, let B stand for the circumstance that the moon is in quadrature, and A the circumstance that it appears as a semicircle. In this case we can translate A, B, with the aid of the conjunction if the moon is in quadrature, it appears as a semicircle. 2222. The reason the translation using if is appropriate in this case, even though the sentence is not general, is that this sentence is an instance of a causal law, which is something general. The causal connection implicit in the word if, however, is not expressed by our symbols, although a judgment of this kind can be made only on the basis of such a connection, for this connection is something general. In the case in which there is a causal connection between antecedent and consequent, the conditional can be affirmed even though the truth values of antecedent and consequent are unknown. In this case the conditional is correctly translated using if, then despite the fact that the causal connection implicit in the word if, which is something general, is not expressed in such a conditional. A second example appears in A Brief Survey of My Logical Doctrines. Frege gives as an example of a conditional in which both antecedent and consequent are sentences the sentence if /211 is greater than 2, then /211, 2 is greater than 2. This sentence, he suggests, does not sound strange, even though the sentence if 3 is greater than 2, then 2 is greater than 2 does sound strange, a little absurd even. The essential difference between the two cases, Frege explains, is that in the case of the sentence if 3 is greater than 2, then 2 is greater than 2, one sees at once which of the four cases holds, namely, that in which both antecedent and consequent are true, whereas in the RST example one does not. 11 In the case of the sentence if /211 is greater than 2, then /211, 2 is greater than 2, one knows that the conditional is true not by virtue of knowing either that the antecedent is False, or that the consequent is true but because it is an instance of the general law that if a number is greater than 2 then its square is greater than 2. One makes the judgment not on the basis of the truth values of the component sentences but on the basis of an inner connection between the thoughts expressed. Because one does, the sentence is appropriately translated using if, then. In On the Aim, Frege claims that the hypothetical judgment is the form of all laws of nature and of all causal connections in general. In Begriffsschrift 5 he suggests that the causal connection implicit in the word if and is something general. In 12 of Begriffsschrift we are told that a Begriffsschrift generalized conditional is how causal connections are expressed. As we have also seen, both generalized conditionals of arithmetic and particular instances of such generalities in cases in which the truth values of antecedent 23 and consequent are not evident are appropriately rendered using if as well. Together these passages indicate that Frege employs the notion of a causal connection not in the narrow sense of a physical cause but in the broad sense of any lawful or internal connection. In this usage one may cite as the cause of something that which constitutes the ground of its truth and thereby a sufficient reason for holding it to be true. A number's being greater than 2, for instance, is a sufficient reason to judge that its square is greater than 2, hence we can say that there is a causal connection, in the broad sense, between something's being greater than 2 and its squares being greater than 2. It is in this sense of cause that the connective if, then of natural language implies a causal connection, and it is this notion of a causal connection as an internal relation among thoughts that is, for Frege, something general. Frege's Begriffsschrift notation seems to have been self-consciously designed to express just such inner relationships. Laws governing modes of arithmetical inference are expressed in Begriffsschrift as generalized conditionals, that is, as genuine hypotheticals. The conditional stroke is justified by its role in the expression of such laws as generalized conditionals, and the outstanding importance of sentences of this logical form is signaled by their being translated in natural language using if, then, a translation that reveals an internal or lawful connection. Indeed, for Frege, generality is the essence of lawfulness. Generality is what the word law indicates. It is by means of indefiniteness that the sense acquires the generality expected of a law. The point is made again in the opening remarks of the late, Unished essay intended as the fourth part of Frege's Logischen Untersuchungen. I published an article in this journal on compound thoughts, in which some space was devoted to hypothetical compound thoughts. It is natural to look for a way of making a transition from these to what in physics, in mathematics, and in logic are called laws. We surely very often express a law in the form of a hypothetical compound sentence composed of one or more antecedents and a consequent. Yet, right at the outset there is an obstacle in our path. The hypothetical compound thoughts I discussed do not count as laws, since they lack the generality that distinguishes laws from particular facts, such as, for instance, those we are accustomed to encounter in history. Laws, Frege seems to think, are inherently general. Only sentences that are logically general in form count as laws. 24. Surprisingly, Frege seems also to think that generality is sufficient for the expression of a law, more exactly, that any Begriffsschrift generalized conditional has the status or character of a law. The point is suggested already in the just quoted passage from in Frege's remark that hypothetical compound thoughts do not count as laws, since they lack the generality that distinguishes laws from particular facts. That Frege thinks that any generalized conditional of Begriffsschrift counts as a law is further indicated by a remark made in a letter to Husserl written in the fall of 1906. In a hypothetical construction we have as a rule improper propositions of such a kind that neither the antecedent by itself nor the consequent by itself expresses a thought, but only the whole propositional complex. In mathematics, such component parts are often letters. The whole proposition thereby acquires the character of a law, namely generality of content. Whereas a mere conditional such as, say, if 3-1, then 3-2-1 does not have the character of a law but is, as one might say, merely truth functional, that is, it is true just if either 3-1 is false or 3-2-1 is true, replacing the two occurrences of the numeral 3 by indicating letters lending generality of content yields, Frege writes, something with the character of a law. Not only are laws expressed in Begriffsschrift as generalized conditionals, but all Begriffsschrift generalized conditionals, it seems, have the status of laws. As we will soon see, the idea is not as silly as it might at RST appear. 1.3 Understanding, 2 strategies. The distinction between a law and a merely accidental regularity is not a distinction of quantificational logic. Whether it is a law that Fs must be G or whether it is merely a contingent matter of fact that all the Fs there are G, the relevant generality is to be expressed as. In effect, quantificational logic treats lawful generalities as if they were contingent generalities, the extra content of a lawful generality that things not only are a certain way but must be that way is not expressed. The RST step in developing the converse strategy to be pursued here is to assimilate merely accidental generalities to laws conceived as necessary truths. We might, for instance, take the sentence fx rightward arrow gx of some imagined logic to express a law, something to the effect that anything that falls under the concept f must also fall under the concept g. The negation of this sentence, then, expresses a possibility, that it is possible for something to fall. 25. Under the concept f without also falling under the concept g. So conceived, the negated sentence does not say that there is in fact a thing that is f and not g, it says only that there could be such an object, that there is no law to the effect that fs must be g. The extra content that is expressed in a negated universally quantified conditional of quantificational logic that not only could there be an f that was not g but also that there actually is such an f is not expressed in our imagined logic. Neither the distinction between a lawful or necessary generality and a contingent one nor that between a mere possibility and an existence claim is a distinction of our imagined logic. The strategy is obviously odd, and a simple example shows why. Suppose that it is true, merely as a matter of fact, that all the apples in a certain bag at a particular time are red. That truth would be expressed in our imagined logic as a law or necessary truth to the effect that any apple in that bag at that time must be red, ax rightward arrow rx. But now one could argue that were a particular Granny Smith apple to have been in the bag at the relevant time, it would have been red. That conclusion, however, is false. Had the Granny Smith apple been in the bag then, what would have been false is not that the Granny Smith apple was green but that all the apples in the bag were red. As this example reminds us, laws, that is, necessary truths, are inferentially stronger than statements of fact, they support counterfactual reasoning. Because they do, the strategy of assimilating merely accidental generalities to such necessary truths would seem to be mistaken in principle. But it is not, and to understand why, we need only recall one of the many anomalous features of Frege's logic when it is read as a quantificational logic, namely, the fact that it includes a judgment stroke on the grounds that inferences can be drawn only from premises acknowledged to be true. If, in Frege's logic as Frege understands it, we can draw no conclusion from something false, one cannot argue from the law ax rightward arrow rx and the falsehood that this Granny Smith apple is in the bag to the conclusion that this Granny Smith apple is red. One has, in this case, only a true conditional, a conditional whose consequent is true if its antecedents are true. We can go on drawing consequences without knowing whether some sentence gamma is true or false. But, the condition if gamma holds is retained throughout. We can only detach it when we have seen that it is fooled. What the generality ax rightward arrow rx of our imagined logic grounds, then, is only the claim that if this Granny Smith apple is in the bag then it is red, and that is true because the antecedent is false. The antecedent can 26 not be detached. As long as Frege's stipulation that conclusions can be drawn only from premises that are acknowledged to be true is adhered to, the fact that a merely contingent generality is expressed in our imagined logic as a law generates no difficulties for counterfactual reasoning. We have proposed to assimilate contingent generalities to lawful generalities and thus also existence claims to statements of possibility. What AX rightward arrow RX says, in our imagined logic, is that as must be R, what its negation says is that it is possible for an not to be R. This cannot be right as a reading of Begriffsschrift generalities, for, as Frege says, the Begriffsschrift expression phi stands for the judgment that the function is a fact whatever we may take as its argument. Begriffsschrift generalities cannot, then, be understood in terms of necessity in the manner just outlined, that is, as general truths about what is and must be the case. We need another way. Suppose that it is true that all Fs are G, whether necessarily, as a matter of law, or merely by accident. Obviously, then, if it is given that the object O is F, one can legitimately infer that O is G. The argument form alpha is G. O is F. Therefore, O is G is valid. Nevertheless, it could be argued, the argument form has a fundamentally different character in the case in which all F is G is a law from the character it has in the case in which all F is G is instead a contingent, accidental truth. Sextus Empiricus takes just this view in Outlines of Scepticism, arguing that, depending on the status of the generality, the inference either is circular or has a redundant premise. His example is the generality everything human is an animal, and we are to assume, RST, that the generality everything human is an animal is true merely by coincidence, in virtue of the fact that, as it happens, each and every human is also an animal. In that case, Sextus claims, the inference everything human is an animal. Socrates is human. Therefore, Socrates is an animal. Is circular because the fact that Socrates is an animal is actually confirmatory of the universal proposition in virtue of the inductive mode. 12 Because in the case of this merely contingent or matter of factual general. 27. Ity, Sextus argues, one cannot establish that everything human is an animal without RST establishing that Socrates, one of the humans, is an animal. The RST premise presupposes already the conclusion, the argument is circular. If, on the other hand, we assume that the generality is lawful, that is, that being an animal follows being human, then at the same time it is said that Socrates is human, it may be concluded that he is an animal, and the proposition everything human is an animal is redundant. 13 In the case in which there is a lawful connection between being human and being an animal, Sextus claims, the argument is valid even without the proposition everything human is an animal. Socrates is human, therefore, Socrates is an animal is not, that is, enthymematic on his view of this case, it is valid just as it stands though not formally valid. Clearly, then, Sextus does not understand the law as it occurs in this case as a kind of necessary truth, for were it such a truth, one could not validly infer that Socrates is an animal solely on the basis of the claim that Socrates is human. What Sextus seems to think instead is that the law serves as a kind of inference license, as a kind of rule, that it functions not as a claim from which one reasons but instead as a principle or rule according to which one reasons. 14 Because what such a principle or rule licenses just is one's concluding that Socrates, say, is an animal given that he is human, it would be inconsistent with its status as such a license were one to require its inclusion among the premises. That is just Sextus's point. One can include the license among one's premises, but one need not, and if one does, one is not transforming an invalid argument into a valid argument. 15 Whether or not Sextus is right to think that in the case in which the generality is merely contingent the argument is inherently circular, his analysis clearly points to two very different conceptions of the logical structure of the argument. On the RST conception, the thought expressed by the sentence everything human is an animal is understood as something from which to reason, it is a fact and as such can supply a premise for an argument. Quite simply, if it is true that everything human is an animal then it is also true that the human Socrates is an animal. In the second case, the thought expressed by that same sentence is understood not as a claim, whether necessary or contingent, but as an inference license, as something according to which one reasons. It is a rule, and as such it justifies one's drawing the conclusion that Socrates is an animal from the premise that Socrates is human. In 28:28. That case, as Sextus argues, the general sentence need not be included among the premises. The argument is perfectly valid though not formally valid without it. Suppose now that despite this intuitive difference between the two sorts of inference, the difference between the two sorts of generalities they involve is to be taken to concern not the contents expressed but instead the sort of justification that is involved in grounding their truth. Clearly there are two options: take the RST case, that of a contingent generality, as one's paradigm, formulate a plausible account for that case, and then treat the second, lawful case the same way, or take the second, lawful case to be paradigmatic, give a plausible account of that case, and then treat the accidental cases similarly. According to the RST strategy, which begins with the case of contingent generalities, the task is to articulate an understanding of a sentence of the form all A is B, where the truth of the sentence is merely a matter of contingent historical fact. What in that case should we say that all A is B means? The most plausible answer is simply this: what is the case if it is true? That is, much as it is natural to understand the sentence Socrates is snub-nosed in terms of its truth conditions, in terms of the circumstance that obtains if it is true, so it is natural to understand a contingent generality such as, say, all Greek philosophers are snub-nosed in terms of its truth conditions. What is the case if it is true, namely, that everything that is a Greek philosopher is also snub-nosed? That, of course, is not true, but it could have been true, and what the generality says on this account is simply what is the case on the assumption that it is true. Extending the account to the case of lawful generalities is straightforward. Because any law entails a corresponding fact, it is the corresponding fact that we express in our language. Suppose, for instance, that it is a law that humans are mortal. It follows that each and every human is mortal. What the relevant sentence of our language says is what is the case if that is true, namely, that everything that falls under the concept human falls also under the concept mortal. The law is thereby reduced to a fact about objects that fall under the relevant concepts. The guiding idea of the strategy that for the purposes of logic a lawful generality can be treated as a generality that is true just in case things are a certain way is grounded in an insight, whether it is accidentally true or whether it is a law that all as are B, the facts remain the same. The second strategy begins with the lawful case, and here the most nat. 29:29. Ural account, following Sextus, is not in terms of the truth conditions of claims but instead in terms of the authority of rules to license judgments on the basis of other judgments. What is wanted is a form of expression that is to be understood not as a statement of a truth but as a statement of an inference license, of something according to which to reason. We could, for instance, introduce the form Fg with the stipulation that it means not that anything that is G is or must be F but instead that being F follows being G, that is, that it is permitted to judge that O is F, for some object O, if it is known to be true that O is G. The sentence so conceived does not say that everything that falls under the concept G falls or must fall also under the concept F, it does not say how things are concerning any objects at all. What it expresses is a rule, an inference license, something according to which to reason. Of course, if it is a valid inference license, one that ought to govern one's reasoning, then it follows that is true, that is, that what this sentence of quantificational logic says is what is so, and contrariwise, if something is found that is G but not also F, then that is enough to show that the inference license is not valid and should not be adopted as a rule according to which to reason. Nevertheless, what the rule says is only something to the effect that certain sorts of judgments are justiciable on the basis of relevant premises. Now we extend the account to the case of accidental generalities. Suppose that it has been established as a matter of contingent empirical fact that all the Gs there are F. Our strategy demands that we express this claim as an inference license to the effect that one is permitted to infer from the acknowledged fact that O is G that it is F. Because inferences from premises whose truth is not explicitly acknowledged are never permissible, treating the claim as an inference license is unproblematic. In counterfactual cases, the best one will be able to do is to infer, for some object O that is not in fact G, that if O is G then it is F. Because the antecedent is false in that case, the conditional is true. This strategy, too, is grounded in an insight. Whether it is accidentally true or instead a law that all A's are B, the inference potential of the sentence is the same. In either case it is permissible, given that one knows that an object O is A, to infer that O is B. According to Sextus, an argument of the form all A is B, O is A, therefore O is B can be conceived in either of two fundamentally different ways depending on whether one conceives the RST premise as a factual claim from which to reason or instead as a rule of inference according to which to reason. As we have also seen, these two conceptions motivate in turn two very different strategies for understanding logical generality on the assumption that no distinction is to be marked in one's logical language between lawful and merely accidental generalities. According to the RST strategy, the meaning of a generalized conditional is understood directly in terms of truth, its meaning is given by what is the case if it is true. According to the second strategy, the meaning of a generalized conditional is understood in terms of the notion of a rule that licenses inferences, in which case the logical problem that would otherwise arise in the case of counterfactual reasoning involving a merely accidental generality is to be blocked by adherence to Frege's stipulation that inferences may be drawn only from premises acknowledged to be true. Both strategies, it has been suggested, are founded on insights, the RST on the insight that whether it is a law or merely accidental that A's are B, the facts remain the same, and the second on the insight that whether it is a law or merely accidentally true that A's are B, it is legitimate to infer, given some object O that is A, that O is B. According to the reading pursued here, it is the second strategy that Frege adopts. On this reading, a Begriffsschrift generality of the form Fg is to be understood in terms of the notion of an inference license, as the expression of a rule according to which to reason rather than as a claim regarding what is, or must be, the case. 3131. On this reading, a generality such as all A is B is to be conceived logically as an inference license, both in the case in which it is merely a contingent or accidental matter of fact that all A's are B and in the case in which there is a properly lawful connection between being A and being B. Just as is the case in a standard quantificational logic, no distinction is to be marked in the language between lawful and accidental generalities. In either case, to say that a generalized conditional in the language is necessary, or apodictic, is only to indicate one's grounds for acknowledging it as true. One acknowledges a rule such as that, say, being red follows being an apple in the relevant basket at the relevant time on the basis of an appeal to facts, that is, to truths which cannot be proved and are not general, since they contain assertions about particular objects, facts such as that this apple is red, and that one is, and so on. Other rules, for instance, the rule of the transitivity of subordination, are provable from the basic laws of logic and for this reason may be called necessary, or apodictic, or analytic. Calling such a rule necessary, to contrast it with the former sort of rule, is in this way to say something not about the content of the rule but instead about the basis on which it is to be acknowledged. We know that Frege rejected Kant's modal distinctions on the grounds that they are logically without significance. Reading Frege's Begriffsschrift generalized conditionals as rules that license inferences, rather than as universally quantified claims, is perfectly consistent with such a view. We have seen that Frege claims in his elucidation of a Begriffsschrift judgment whose content is a generality that it stands for the judgment that the function is a fact whatever we may take as its argument. This, we noted, is incompatible with treating Begriffsschrift generalized conditionals as necessary truths. It is not incompatible, as we have just seen, with treating such sentences as the expression of rules governing inferences. That it is a fact that all A's are B is indeed necessary and sufficient for expressing that fact as a rule licensing inferences, that is, as a Begriffsschrift generalized conditional as it is read here. Nevertheless, it can seem surprising for our reading that Frege would elucidate generalities of Begriffsschrift in just this way. To understand why Frege's elucidation of generality takes the form it does requires some account of the purpose Frege's elucidations are to serve. 16. An especially striking feature of Frege's elucidations in Begriffsschrift is 32. That they are elucidations of judgments, that is, of sentences to which the judgment stroke has been attached. This suggests that Frege's elucidations concern acts of acknowledging the truth of various contents, not merely those contents themselves. It suggests that they are not so much clarifications of the contents expressed as clarifications of the judgeability conditions of judgments of various forms in Begriffsschrift. If that is right, then Frege's Begriffsschrift elucidations serve to set out the necessary and sufficient conditions for acknowledging the truth of Begriffsschrift sentences of various forms where such a judgment is not the conclusion of an inference but a judgment made solely on the basis of the content itself. It is the correctness of attaching the judgment stroke in various cases that is at issue in Frege's elucidations, and such elucidations are needed, in Frege's system of logic, because the axioms of that system must be acknowledged to be true before any inferences can be drawn on the basis of them. In Grundgesetze, after Frege has distinguished Sinn from Bedeutung, that same end is achieved by setting out the necessary and sufficient conditions under which Begriffsschrift sentences of various forms designate the true. Because the truth of a thought is necessary and sufficient for correctly acknowledging its truth, judgeability conditions immediately follow. On this reading of Frege's elucidations of his primitive signs, the purpose of those elucidations is to clarify the judgeability conditions of the contents expressed by sentences containing those signs. This reading is suggested by the fact that in Begriffsschrift Frege's elucidations are invariably of sentential signs to which the judgment stroke has been attached. It is further reinforced by the fact that in his elucidation of logically general sentences of Begriffsschrift Frege does not employ his Latin italic letters, which are the principal vehicle for the expression of generality in Begriffsschrift and are correctly used in conjunction with the judgment stroke, but instead the concaviti notation. Frege's use of the concaviti notation in his elucidation suggests that the elucidation is intended to clarify the correctness of a judgment, that is, the correctness of attaching the judgment stroke in the case in which the content is logically general, and it does so because only in this form can the generality be posed in a question. Only a generality expressed using the concaviti notation can be negated, only a generality so expressed has in this way an opposite. It follows that only a generality so expressed yields a content of POS. 33. Cybele judgment, that is, something that can be acknowledged, or its negation acknowledged, to be true. The Begriffsschrift sentence F. G. expresses a content of possible judgment, the Begriffsschrift sentence F. G. does not. Indeed, in Frege's logical language, Latin italic letters never appear except in sentences to which the judgment stroke has already been attached. 17. As we will see in section 2.3, one can directly infer a generality expressed using Latin italic letters in Frege's logic, but it is only inferentially that generalities so expressed can be acknowledged. If Frege's elucidation is of the correctness of acknowledging the truth of a Begriffsschrift generality directly, that elucidation must employ the concaviti notation for generality rather than a Latin italic letter, even though, in this case, the judgment stroke is attached. The elucidation tells us that a Begriffsschrift generality ought to be acknowledged as true just in case the function is a fact, whatever is taken as argument. That is exactly right, whichever of the two strategies outlined earlier one pursues. According to Frege's elucidation, the necessary and sufficient condition for correctly acknowledging the truth of a Begriffsschrift generalized conditional such as f g is that the function f psi g psi yields the value true no matter what object is taken as argument. The judgment that results provides in turn the basis for the inference license that is expressed, on our reading, by f g. 34. As justified by the law that f It by no means follows that the meaning of that second conditional expressed using Frege's Latin italic letters is exceed by Frege's elucidation of the judgeability conditions of the RST Begriffsschrift generality, the one expressed using the concavity notation. If, as has been suggested here, what a Begriffsschrift generality written using Frege's Latin italic letters expresses is not properly speaking a fact but instead a rule, a principle according to which to reason, then its meaning can be adequately revealed only in inference. That the function is a fact whatever one may take as its argument is necessary and sufficient for judging that a Begriffsschrift generalized conditional is true, and it follows, on our account, that the relevant inference license is valid. Frege's elucidation of a Begriffsschrift generality, then, understood as setting out the necessary and sufficient conditions for a correct judgment regarding a Begriffsschrift generality, is perfectly consistent with taking Begriffsschrift generalized conditionals involving Latin italic letters to express laws conceived as inference licenses. Indeed, as we read it, Frege's elucidation of generality in Begriffsschrift could take no other form than the one Frege gives it. 1.4 Our starting point. Frege says that arithmetic was his starting point. It seemed to him probable that arithmetic was grounded in logic alone, that all its concepts and modes of inference were strictly logical. His aim was definitively to show that this is so. But to do that he needed a better means of expression than that provided by natural language. In particular, he needed a notation for the expression of the laws that govern the inferences that are actually drawn in arithmetic so that those laws might be proven as theorems on the basis of the laws of logic alone. To that end, he devised a notation that enables the expression of rules of inference as claims, that is, as generalized conditionals or, as he also thought of them, as genuine hypotheticals. Unlike a universally quantified conditional of a standard logic, which expresses a fact, a Begriffsschrift generalized conditional expresses a law that governs inferences, and in the RST instance, a law that governs inferences in arithmetic, for instance, the law of mathematical induction. It is just this. 35. Idea, that genuine hypotheticals of Begriffsschrift express not claims from which to reason but rules on the basis of which to reason, that provides our starting point. Instead of beginning with the quantificational conception of generality as an account of what Frege means by logical generality, and understanding Frege's conception of lawfulness on that basis, we begin with Frege's conception of a law as that to which a mode of inference is subject, and on that basis develop an account of his conception of logical generality and thereby of his logic. 18. Our starting point is Frege's conception of a law as that which governs a mode of inference. Our RST task is to understand Begriffsschrift generalized conditionals expressed using Frege's Latin italic letters as formulations of such inference licenses. 36. 2. It's a question of grasping the property of thoughts that I call logical generality. Of course for this we have to reckon upon a meeting of minds between ourselves and others, and here we may be disappointed. Logical generality, c. 1923. Frege developed his Begriffsschrift in order to show that there are no peculiarly arithmetical modes of inference, no laws of arithmetic that are not derivable from the laws of logic and definitions. Principles of inference that appear to be peculiar to arithmetic are to be translated into formulae in his concept script and proved on the basis of logic alone. Because these formulae have the logical form of generalized conditionals, what is needed, RST and foremost, is an account of such sentences, both of the logical significance of Frege's two-dimensional conditional stroke and of the peculiar logical role his indicating letters play in lending generality of content to conditionals. 1. We begin with some general considerations regarding the kind of language Begriffsschrift is on our account. 2.1 Reading Begriffsschrift. In a written natural language such as English or German, a sentence is most immediately a record of speech that enables one capable of reading the language to reproduce the relevant sequence of phonemes. It is, in the RST instance, a direction for forming a spoken sentence in a language whose sequences of sounds serve as signs for expressing a sense. But although at RST the connection between the written word and that which it signifies is mediated by the relevant sounds, once this connection is established, We may also regard the written or printed sentence as an immediate expression of a thought, and so as a sentence in the strict sense of the word. We can learn, that is, to read a sentence of ordinary written language in a new way, to read it as a sentence of a fundamentally different kind of language. Instead of reading a sentence of English as a direction for 37. Forming a spoken sentence, we learn to read it as itself an immediate expression of a thought. Because the meaning of the language as it is conceived in this second way is carried by the written signs themselves, such a language is written for the eye not merely in the trivial sense that it is written but also in the more interesting sense that the meanings of sentences are now seen, as it were, rather than heard. Ordinary written natural language can be read as a language for the eye, it can come to be such a language. But written natural language was not formed as such a language. It simply reproduces the verbal speech, and because it does, there is only an imperfect correspondence between the way the words are concatenated and the structure of the concepts. Speech often only indicates by inessential marks or by imagery what a concept script should spell out in full. A concept script, by contrast with verbal language, is explicitly designed in such a way that it directly expresses the facts without the intervention of speech. Thus, whereas in English one would write, for instance, Romeo loves Juliet, in a more perspicuous notation one might write simply LRJ, understood as a presentation of two individuals, Romeo and Juliet, in a relation of loving, the former to the latter. Such a notation is logically more perspicuous than written English in two ways. First, it is not mediated by spoken English, one cannot read LRJ as one can read written English, as a direction for forming a spoken sentence. The letter R stands for Romeo not by way of the sound the letter makes when it is spoken but directly. It is a simple sign to be understood as representative of Romeo, and similarly for J and L. The sentential sign LRJ is also more perspicuous than written English insofar as it does not, as written English does, mark one object name as the subject. In English, one distinguishes between Romeo loves Juliet and Juliet is loved by Romeo. Romeo is the grammatical subject of the RST sentence, and Juliet is the grammatical subject of the second. In standard logical notations, as in Begriffsschrift, such a distinction is not marked. LRJ expresses the content that is common to the sentences Romeo loves Juliet and Juliet is loved by Romeo. Because, as Frege notes in Begriffsschrift 3, only this common content is significant for the correctness of inference, it is this common content that is expressed in a properly logical language. It is a fundamental insight of modern logic that, for the purposes of logic, a sentence such as Romeo loves Juliet is not about the grammati. 38. Cal subject Romeo, saying of him that he loves Juliet. Nevertheless, as standardly conceived, such a sentence, more perspicuously rendered LRJ, does have a logical subject. What it is about, logically, is the ordered pair Romeo, Juliet. What it says about the people so ordered is that the tuplace predicate loves applies to them. If it is possible also to conceive the sentence differently, as, say, about Juliet that she is loved by Romeo if, that is, it is possible also to take J as marking the argument place for the function LR psi. This is essentially derivative, grounded in the independently meaningful signs L, R, and J2. Indeed, it can seem obvious that sentences should be taken to have such antecedently intelligible parts out of which they are constructed, only so, it would seem, can an adequate account be given of our ability to understand novel sentences. We begin, for instance, with simple names and simple n-ary predicates, assigning to each a semantic value. Objects are assigned to the simple names, properties deemed over objects are assigned to one-place predicates, binary relations deemed over ordered pairs of objects are assigned to two-place predicates, and so on. Simple sentences are formed by appropriately combining those simple parts, and the truth conditions of the sentences, the contents expressed, are determined by the semantic values assigned to their proper parts. Because the meaning expressed by sentences so constructed is determined by the arrangement and meanings of their constituent parts, we explain our ability to grasp the meanings of novel sentences in terms of our grasp of the meanings of their constituent parts and of the ways those parts are correctly combined. Clearly there is something like this in Frege. Curiously enough, however, Frege does not so much as mention the compositionality of language, the fact that the content expressed by a sentence is a function of the contents expressed by its proper parts, until after the introduction of the technical notions of Sinn and Bedeutung in the early 1890s. What is emphasized in all his writings, early and late, is, as Frege puts it in the 1914 notes for Ludwig Darmstädter, I do not begin with concepts and put them together to form a thought or judgment, I come by the parts of a thought by analyzing the thought. According to Frege, one of the most important and fundamental insights coded in his logical language is that the subject/predicate distinction is to be replaced by the distinction between argument and function, where argument and function 39 are given only relative to an analysis. In this, he claims in Begriffsschrift 3, I strictly follow the example of the formula language of mathematics, in which, also, one can distinguish subject and predicate only by doing violence. The point is developed for the case of the sentence 2 4 = 16 of the formula language of arithmetic in the long Boole essay written shortly after Begriffsschrift. If you imagine the 2 in the content of possible judgment 2 4 = 16 to be replaced by something else, by or by 3 say, which may be indicated by putting an x in place of the 2, x 4 = 16, the content of possible judgment is thus split into a constant and a variable part. The former, regarded in its own right but holding a place open for the latter, gives the concept 4th-16. We may now express 2 4 = 16 by the sentence 2 is a 4th-16 or the individual 2 falls under the concept 4th-16 or belongs to the class of 4th roots of 16. But we may also just as well say 4 is a logarithm of 16 to the base 2. Here the 4 is being treated as replaceable and so we get the concept logarithm of 16 to the base 2, 2x = 16. The x indicates here the place to be occupied by the sign for the individual falling under the concept. A sentence of the formula language of arithmetic such as 2 4 = 16 can be carved up in various ways into function and argument to yield a sentence that ascribes a concept to a number. On one analysis, it says that 2 is a 4th root of 16, on another that 4 is a logarithm of 16 to the base 2, and so on. But what, we may ask, does the sentence say independent of any such analysis? The answer, we think, is obvious. 2 4 = 16 says that 2 to the 4th power = 16. We read it, that is, in essentially the way we would read the corresponding sentence of natural language. What we need to see is that much as we learn to read sentences of English in a new way, not as directions for forming spoken sentences but as immediate expressions of thoughts, so we can learn to read sentences of the formula language of arithmetic differently, as sentences of a fundamentally different kind of language. This point is critical to the reading aimed at here and thus will be developed with some care. Imagine, to begin with, someone who has learned to count objects and on that basis a procedure for ending sums. When given a problem of the form n plus m, the student represents n objects and adds units m times. Multiplication is easily mastered. Given a problem of the form n times m, one simply adds n to nm 1 times. The problem of taking a 4th power of n is conceived as the problem of ending the solution to n times n times n times n, and so on. In each case the student knows what to do, what procedure to follow, to end the answer. Now we provide our student with a sign for equality and teach the student to say what hitherto could only be shown, namely, that the sum of n and m is L, or, in the newly acquired notation, n plus m equals L, and similarly for multiplication and exponentiation. A sentence like 2 4 = 16, then, has for the student a xed logical form, f equals z, where f indicates the procedure to be followed for arguments x and y, and z is the result of following that procedure for those numbers as arguments. The sentence 2 4 = 16 says that 2 to the 4th power = 16. Suppose now that we try to teach our student the inverse operations, subtraction, division, roots, and logarithms. As is indicated by the fact that, by contrast with addition, multiplication, and exponentiation, these operations are not closed under the positive whole numbers, such operations involve something essentially new. One way to think about what it is that is new is this. We have sentences such as plus equals 5 that are understood to have the logical form of identities. Such a sentence is built up, RST, out of a pair of numbers to which a function is applied, and the result of applying that function to those numbers is then identified with another number, in this case, VE, plus equals 5. This sentence says of the sum of 2 and 3 that it is equal to VE. Suppose now that we try to explain subtraction by saying that what is wanted in that case is the function one gets by taking as arguments not the 2 and the 3 in plus equals 5, but instead the 2 and the 5, leaving the 3 position to be where the value goes. As long as the sentence plus equals 5 is understood by way of its constructional history, as built up in the manner just described, this new function that one is to get by taking the 2 and the 5 to mark the argument places has a radically different status from that of the addition. 4141. Function. Because the sentence is conceived as built up out of two numbers applied to a function to yield a number that is then identified with another number, our subtraction function cannot be recognized as a function, properly speaking, at all. Our so-called function is not really a function but at best a convenient form of words. It is only as if we could form such a function. But of course subtraction is a proper function. What is distinctive of it, and of the other inverse operations, is that to see that it is requires seeing the sentence plus equals 5 not as having inherently the form of an identity but instead as presenting, by means of familiar arithmetical symbols, an arithmetical relation among three numbers, one that can be carved up in various ways into function and argument. To understand subtraction, that is, one learns to see the sentence plus equals 5 in a radically new way. One learns to read it differently, not as the result of a stepwise process, but simply as exhibiting an arithmetical relationship between 2, 3, and VE, one that can be analyzed in a variety of ways. To see that subtraction and addition are both functions in exactly the same sense is to see that any two of the numerals in plus equals 5 can be treated as marking the argument places, leaving the one that remains to mark the value of the function for those arguments. Independent of an analysis, the sentence so conceived does not ascribe identity to two numbers or any other predicate to any subject. The sentence does not say anything in that sense at all. It merely exhibits three numbers in a certain arithmetical relation. Such a language, unlike the language of arithmetic on our RST reading of it, is essentially a written language, one that can exploit the two-dimensional writing surface for the sake of perspicuity. The critical feature of a sentence such as 2 4 equals 16 in the formula language of arithmetic as it is now being conceived is that it merely presents three numbers in an arithmetical relation and is variously analyzable. A different example of the sort of symbolic notation we have in mind here is this. We know that given a categorical judgment of the form no m is n, one can infer that no n is m. If the one sentence is true, then the other is as well. Nonetheless, the two sentences are different, and inference is required to get from the one to the other. In a Venn diagram, the content that is common to both sentences is exhibited as follows. 4242. M. N. Where this diagram is not to be read from left to right but simply taken in as a whole. It does not say that no m is n, nor does it say that no n is m. Instead, it simply presents m and n in the logical relation of mutual exclusion. Similarly, we have suggested, we can learn to read a sentence of the formula language of arithmetic such as 2 4 equals 16 not from left to right, but simply as a presentation of the numbers 2, 4, and 16 in a certain arithmetical relation, one that can be read, analyzed into function and argument, in a variety of ways. No doubt we could not come so to read the formula language of arithmetic without having RST developed and learned to read it as we ordinarily do, but that is a historical and psychological point, not a logical one. Two fundamentally different, but also fundamentally related, ways one can read the arithmetical sentence 2 4 equals 16 have been outlined. On the RST way of reading, the sentence says of 2 taken to the fourth power that it is equal to 16. If, on this reading, the sentence can also be analyzed as saying of, say, 4 that it is a logarithm of 16 to the base 2, it says this only in some other, essentially derivative way. The second way to read the sentence, achieved through a thoroughgoing transformation of the RST way of reading, is to take it merely to exhibit, by means of familiar features of the symbolism, an arithmetical relation among three numbers, merely to show, much as a Venn diagram does, how things stand if it is true. Only relative to an analysis that identifies some number as argument and the remainder as the function is the sentence so read correctly described as saying something about something. Independent of an analysis, the sentence has no subject and no predicate, no function and no argument, it merely exhibits three numbers in an arithmetical relation. In essentially the same way we can learn to read the sentence LRJ differently, not as saying of Romeo and Juliet that the former loves the latter but as only showing Romeo, Juliet, and the relation of loving in a certain relation. So conceived, the sentence presents not Romeo and Juliet in the 43-43 RST level relation of loving but instead, all three Romeo, Juliet, and loving in the second level logical relation of subsumption. The sentence so read does not say that these three entities stand in this relation, independent of an analysis it does not say anything at all. It only shows how things stand if it is true. In order to recover truth conditions from it, we must analyze it into function and argument. If we take R and J to mark the argument places and L xi zeta as the function, it is read as saying of Romeo and Juliet that the former loves the latter. If we take R alone to mark the argument place, it is read as saying of Romeo that he loves Juliet, that is, that Romeo falls under the concept loving Juliet. If we take J to mark the argument place, it is read as saying of Juliet that she is loved by Romeo. If we take L psi J to mark the argument place, it is read as saying of the property loving Juliet that it is a property of Romeo, that is, that the property loving Juliet falls under the second level concept property of Romeo, and so on. In each case the analysis yields truth conditions, an account of what is the case if the sentence is true and an ascription of the relevant concept to the subject identified as argument. Independent of any analysis, the sentence only shows what is the case if it is true. In that case no predicate is ascribed. In the language so conceived, as in the formula language of arithmetic as we have learned to conceive it, one can distinguish subject and predicate only by doing violence, only, that is, by carving the sentence up into function and argument. 3. On the standard reading of a simple sentence of Begriffsschrift such as LRJ, the sentence has a XED logical form, it is an ascription of a relation, loving, to an ordered pair of objects, Romeo, Juliet. What the sentence means, the thought it expresses, is what is the case if it is true, that Romeo loves Juliet. But given such a reading, we can also learn to read the sentence differently, not as an ascription of a relation to a pair of objects but instead as merely exhibiting two objects and a relation in a certain higher level logical relation. On this latter reading the sentence does not as such present truth conditions, though they are easily formulated relative to an analysis. Instead, it merely exhibits a content that, for the purposes of judgment and inference, can be variously analyzed into function and argument. According to the interpretation pursued here, Frege reads Begriffsschrift, and by extension sentences of natural language, in just this way. In the 1879 logic Frege claims that a Begriffsschrift sentence presents a mere combination of ideas bloße Vorstellungsverbindung. This early formulation is corrected in the 17 key sentences on logic. 44-44. In the case of thinking it is not really ideas that are connected but things, properties, concepts, relations. According to Frege's considered usage Vorstellung refers to an idea in the subjective sense, objective ideas just are concepts and objects. Because already in Begriffsschrift Frege thinks of symbols as usually only representative of their contents, so that each combination expresses only a relation between their contents. A sentence of Begriffsschrift is to be understood as a combination of things, properties, concepts, and relations, not Romeo and Juliet in the relation of loving, but instead Romeo, Juliet, and loving in a certain higher order relation. A further indication that this is Frege's view, even in the early logic, is the fact that he sees no difference in principle between taking an object name to mark the argument place and taking a concept word to do so. Just as we can analyze the Begriffsschrift sentence fo into the function f psi for argument o, so we can analyze it into the function phi for argument f psi. In Grundgesetze 22 Frege explicitly says that what is designated by the Begriffsschrift sign phi is the relation of an object to a concept under which it falls, that is, it is a sign for the relation of subsumption, a second-level function that takes objects and concepts as arguments to yield truth values as values. Much as the signs plus and equals of the formula language of arithmetic enable, on our reading, the exhibition of arithmetical relations among numbers in an arithmetical identity such as 2 plus 3 equals 5, so Frege's primitive signs enable the exhibition of logical relations among objects and concepts in sentences of the form fo. On this reading, just as Frege says, the thought itself does not yet determine what is to be regarded as the subject. If we say the subject of this judgment, we do not designate anything denite unless at the same time we indicate a denite kind of analysis. As we will see, Frege's two-dimensional conditional stroke preserves just this feature of the notation for the case of logically complex sentences. A Begriffsschrift conditional presents sentences in a logical relation, and just as the simple sentence LRJ can, a Begriffsschrift conditional can be analyzed in various ways. 2.2 The logical justification for a two-dimensional notation. Frege's Begriffsschrift notation was designed to enable the expression of everything necessary for a correct inference, where this x. 45 Pressive project requires in turn, Frege thinks, the perspicuous representation of logical relations by means of written signs, symbols for the logical relations. Because, as Frege also holds, a simple sequential ordering in no way corresponds to the diversity of logical relations through which thoughts are interconnected, his two-dimensional notation is designed to facilitate the apprehension of that to which we wish to direct our attention. Frege's conditional stroke is his sign for the primitive logical relation, and it is that stroke that gives his logical language its peculiar two-dimensional character. We need, then, to understand that sign in a way that reveals its logical justification. On the standard reading, Frege's conditional stroke functions in his logic as the horseshoe does in our logic. We know that the Begriffsschrift conditional a, b designates the true just in case either b is false or a is true, so, we assume, it expresses precisely the thought that is expressed by b proper superset symbol a. Frege's discussion in Begriffsschrift 5 of Begriffsschrift sentences that contain a series of conditions reinforces the reading. It is easy to see that alpha, beta, gamma denies the case in which alpha is denied and beta and gamma are affirmed. We must think of this as constructed from alpha, beta, and gamma in the same way as alpha, beta is constructed from alpha and beta. 46. If we must think of alpha, beta, gamma as so constructed, then we must think of alpha, beta as forming a single unit relative to the condition gamma, and therefore the whole as of the form if gamma, then if beta then alpha, that is, as expressing just what is expressed by gamma proper superset symbol. Adding a further condition, for instance, as in alpha, beta, gamma, would be to express what is expressed in standard notation as proper superset symbol. Were this the right way to read Begriffsschrift conditionals, the only logical justification for Frege's two-dimensional notation would be that it enables us to dispense with brackets. For as it is usually understood, and as Frege seems to understand it in the early logic, a Begriffsschrift sentence with multiple conditions has a XED logical structure. It is to be read according to some such rule as this: beginning at the top left, follow the horizontal until you come to a conditional stroke, say if followed by whatever is to the right of that conditional stroke, then say then and continue. Given that the sentence does have this structure, there is no compelling logical justification for a two-dimensional representation of it. In the mature logic, Frege self-consciously reads such sentences differently, as similar to tabular lists in which the two-dimensional expanse is utilized to achieve perspicuity. His own notation, he claims, achieves perspicuity in much the same way. That is, Frege comes explicitly to see what had been implicit in his inferential practice from the beginning, that Begriffsschrift conditionals can be read in various ways, just as a table can. Much as the formula LAN 4747. Gauge of arithmetic, as we have learned to read it, is a different kind of language from that it is generally taken to be, so Frege comes to suggest, his logical language is a different kind of language from that he originally took it to be. In a tabular list, for instance, a truth table for some binary connective in a three-valued logic, the values of a logically compound sentence are set out for all possible combinations of values of its components. We deem the connective asterisk of some imagined logic, for example, as follows: asterisk 123133213. Such a table sets out clearly and unambiguously the value of any sentence of the form A asterisk B given values for A and B, and it does so by way of a two-dimensional array, a tabular list. But of course all the information contained in the table could also be presented in a linear array. Reading down the columns, left to right, the information on the table could be coded, assuming a suitable convention for reading sentences of this form as 112.231.333. Reading instead by rows, top to bottom, yields 123/133/213, again, given suitable conventions for interpreting the sentence. Alternatively, entries could be listed by their values, and so on. Each such path through the table codes the information contained in the table in a sequential ordering. As we might think of it, each represents the way the table shows up from some one essentially linear perspective. Because it does, each linear presentation of the information contained in the table highlights some relationships while it obscures others. One linear presentation makes it easy to see what the values are for the cases in which the value of the RST sentence in the compound is, say, 2, but harder to discover what the values are in the cases in which the value of the second sentence is 2. In another it is easiest to see what the values of the component sentences must be to yield a certain value, and so on. In this way, each linear array suits some purposes at the expense of others. Because all such purposes are equally well served by the table itself, what is expressed in a single two-dimensional table is expressed in one dimension only by an equivalence class of lists. It should be noted, nally, that given one linear representation of the information provided in the table, it would be non-trivial in the absence of the table itself to show that just the same information was contained in another linear ordering. Begriffsschrift 4848. Conditional sentences, as they are to be read here, are essentially similar to such a table. We saw earlier that what would be expressed in quantificational logic as, is expressed in Begriffsschrift instead as P, Q, R. But whereas in the early logic Frege thinks of this latter sentence in terms of its stepwise construction out of R and the conditional formed from P and Q, in the mature logic he suggests that the resultant sentence merely presents P, Q, and R in a logical relation, one that can be read in various ways. In theta lambda, we may call theta the main component and lambda subcomponents. However, we may also regard theta as the main component and lambda alone as subcomponent. If we take theta as the main component and lambda as subcomponents, this sentence could be read as the conditional if and lambda, then theta. If we take lambda alone as subcomponent, it reads instead as if lambda, then if then theta. Like our truth table for the connective asterisk, this Begriffsschrift sentence is essentially two-dimensional, Corresponding to it are a variety of provably equivalent serially ordered linear structures. Sentences that are provably equivalent, such as, for instance, if and lambda, then theta, and if, then if lambda then theta, express one and the same thought according to Frege. As he explains in a letter to Husserl, if both the assumption that the content of A is false and that of B true and the assumption that the content of A is true and that of B false lead to a logical contradiction, and if this can be established without 49. Knowing whether the content of A or B is true or false, and without requiring other than purely logical laws for this purpose, then nothing can belong to the content of A as far as it is capable of being judged true or false, which does not also belong to the content of B. Because this content that is common to such equipollent propositions alone is of concern to logic, all that would be needed would be a single standard proposition for each system of equipollent propositions. Frege's two-dimensional notation provides just such a standard proposition for the case of conditionals with more than one condition. By contrast with sentences in our standard linear notation, each of which has one and only one main connective, sentences in Begriffsschrift have a main connective only relative to an analysis. The sentence P, Q, R, S, for instance, can be read in four different ways as follows. If, in this sentence, S is treated as the subcomponent and P, Q, R as the main component, whose main component in turn is P, Q, then the result would be most naturally expressed in quantificational logic as S proper superset symbol. In the sentence so read the main connective is between the last condition S and everything to the right of it, because what is to the right is also logically complex, it is to be read in turn as having its main connective between the lowest condition R and the conditional P if Q. So read, the sentence is conceived just as Frege suggests in Begriffsschrift it should, as progressively built up out of P to which Q is added as a condition, then R as a condition on the resulting kindi. 50-50. Conditional, then S on that conditional in turn. But, as Frege comes explicitly to see, we can also learn to read it differently. Taking S as subcomponent and PQR as main component, but now taking the main component of this component to be P, leaving Q and R as subcomponents, yields instead S proper superset symbol P, 5 that is, we take the main component to have its main connection between the two conditions, Q and R, and the condition P. A third path through our sentence results from taking both S and R as subcomponents and PQ as the main component, in which case the result might be expressed in a linear notation as proper superset symbol. If, nally, all of S, R, and Q are treated as subcomponents with P as the main component, we get proper superset symbol P. In this case the main connective is the RST horizontal, S, R, and Q are all conceived as conditions on the truth of P. Each of S proper superset symbol, S proper superset symbol P, proper superset symbol, and proper superset symbol P represents in this way one path through Frege's two-dimensional structure, one perspective it is possible to take on it. The equivalence of these four formulae, though it must be proven in standard notation, is a given of Frege's two-dimensional notation. Just as our truth table corresponded to an equivalence class of linear presentations of the information it contained, so Frege's one formula corresponds to an equivalence class of formulae in standard one-dimensional notation. The only case in which the two notations are comparable is the limit case of a simple conditional, only in that case is there a one-to-one correspondence between the Begriffsschrift conditional and the conditional as it is usually written. In a linear notation, on the standard reading of it, there is always a main connective. One is to understand a sentence such as P proper superset symbol as a conditional whose antecedent is P and whose consequent is Q proper superset symbol R. The sentence says that either P is false or Q proper superset symbol R is true. The same thought expressed in Frege's notation, namely 51-51. R, Q, P, does not, on our reading, say that either P is false or Q proper superset symbol R is true. Instead, it exhibits a logically complex relationship among the three sentences P, Q, and R, one that can be analyzed as saying that P is false or if Q then R true, but can as easily be analyzed in other ways as well. As we can think of it, the array of horizontals and conditional strokes on the left in this expression constitutes a complex sentence connective, one that functions as a single unit, much as plus and equals function as a single unit in the presentation of an arithmetical relation among three numbers in 2 plus 3 equals 5. Frege's conditional stroke, by contrast with the horseshoe, can thus be used to form NADIC sentence connectives of any degree of complexity one likes. The Begriffsschrift sentence A. B. exhibits a logical relationship among sentences, and the sentence A. B. C. B. E. similarly, exhibits a logical relationship among sentences. Once we have learned to read Frege's notation in this way, it is easy to see, in Frege's notation, that interchanging subcomponents is permissible. Changing the order of subcomponents does need to be justified, which is why interchange of subcomponents is given as a rule in Grundgesetze and is proved as a theorem in Begriffsschrift, but in Frege's notation one such rule can cover all cases of this form of embedding. In our standard notations, by contrast, having proved that, say, proper superset symbol R is equivalent to proper superset symbol R will not save one the trouble of having also to prove that, say, P proper superset symbol S, is equivalent to Q proper superset symbol S. Indeed, these look, in standard notation, to be quite different sorts of cases. Where Frege has one rule and a two-dimensional notation to X the equivalence. 52. Of the 4 linear sentences discussed earlier, as well as all 20 variants with Q, R, and S in different orders, a standard linear notation brings with it the demand that one prove, for each pair of the 24 sentences involved, that they are equivalent. Just by being set in a two-dimensional space as it is, Frege's conditional stroke combines in this way logical perfection with the utmost brevity, maximal logical precision, together with perspicuity and brevity. The rule of contraposition in Frege's logic reinforces the point. Depending on how one carves up the judgment PQRS into main component and subcomponents, an application of contraposition yields QPRS, or RPQS, or SPQR. All these cases involve the application of a single rule to the original sentence variously conceived. But a sentence in our standard linear notation. 53. As normally read, cannot be variously conceived. 6. There are no alternative perspectives to be taken on it. A logically compound sentence in standard notation has one, and only one, main connective, and each embedded sentence in turn has, at most, one main connective. As a result, the natural deduction proof of the equivalence of, say, P proper superset symbol and P proper superset symbol Q, is quite different from the proof of the equivalence of, say, P proper superset symbol and P proper superset symbol. The former looks like a case of contraposition, the latter does not. In the setting of our standard notation, these look to be completely different sorts of cases. In the setting of Frege's notation, it is easy to see that they are both the result of applying a single rule to a single formula. A multiply conditioned conditional sentence of Begriffsschrift corresponds to an equivalence class of formulae in a standard linear notation. But as the rules of interchange of subcomponents and of contraposition reveal, even in Frege's own logical language it is possible to express one and the same thought in different ways. Frege seems to be making just this point in a brief survey of my logical doctrines, in which he sets out a condition on two sentences being equivalent that is different from that set out in the letter to Husserl considered earlier. Two sentences A and B can stand in such a relation that anyone who recognizes the content of A as true must thereby also recognize the content of B as true and, conversely, that anyone who accepts the content of B must straight away accept that of A, I assume. There is nothing in the content of either of the two equivalent sentences A and B that would have to be immediately accepted as true by anyone who grasped it properly. Here Frege claims that equivalence is a matter not of provable equivalence but instead of self-evident equivalence. The reason he does is that this passage occurs in the context of a discussion of his own logical doctrines and so presupposes his own logical language. Frege is not here talking about the logical equivalence of two sentences in, say, English or German, as he was in the letter to Husserl. He is not talking about sentences that are provably equivalent, requiring nothing other than purely logical laws to establish that if one is true then the other is also. Frege is talking about his own logical language, and in such a language, he claims, the equivalence of two sentences, the fact that they express one and the same thought, is manifest to anyone who understands what they express. 54. By the criterion of equivalence set out in a brief survey of my logical doctrines, the three sentences A and C B A express the same thought and differ only in form. Given what the conditional and negation strokes mean in Begriffsschrift, one could not be said to grasp the thoughts expressed by any of these sentences without recognizing that if any one is true then the others are as well. That would seem to be why, according to Frege, transitions that take one from any one of these sentences to any other are not inferences, properly speaking, at all. Such transitions are not acts of reason that take one from one thought to another, but only transitions from a thought in one form to that thought in another form. As Frege puts the point in compound thoughts, we can see that B and A has the same sense as A and B without proof. This interchange should no more be regarded as a theorem here than for compounds of the RST kind, for there is no difference in sense between these expressions. In all such cases this divergence of expressive symbol and expressed thought is an inevitable consequence of the difference between spatio-temporal phenomena and the world of thoughts. Transitions that take one from a thought in one form to that same thought in another form do need to be justified in a properly rigorous system, but they are not inferences, properly speaking, any more than the move from 2 plus 3 equals 5 to 5 equals 2 plus 3 is a calculation. Much as a proper calculation, for instance, that involved in going from 2 plus 3 equals 7 to 2 plus 3 equals 5 requires other identities, so inferences proper require other premises. It is easy to read Frege's conditional stroke as a notational variant of the horseshoe of standard logic and to take his elucidation of that Begriffsschrift sign as a truth functional specification of its meaning. But, we have seen, the conditional stroke need not be read as a notational variant of the horseshoe, it can instead be read as something essentially two-dimensional, like a tabular list. If, as was suggested in section 1.3, Frege's elucidations are to be read as setting out the judgeability conditions of sentences of various forms, as setting out the necessary and sufficient conditions for correctly acknowledging the truth of the contents. 55. They express, then Frege's elucidations of the conditional stroke can be read as setting out not the meaning of that sign but only the necessary and sufficient conditions for acknowledging the truth of the thought expressed by a sentence that contains it. Frege writes in Begriffsschrift 5. A. B. stands for the judgment that the third of these possibilities does not occur, but one of the other three does. In Grundgesetze 12 the conditional stroke is introduced with the stipulation that the value of the two-place function psi zeta shall be the false if the true be taken as zeta argument and any object other than the true be taken as xi argument, and that in all other cases the value of the function shall be the true. 8. What these elucidations provide, on our reading, is not the meaning of the conditional stroke but only the circumstances in which a Begriffsschrift conditional sentence is true, that is, the conditions under which it is correct to acknowledge the truth of the thought expressed by a conditional sentence of Begriffsschrift. It does not follow from the mere fact that in these passages Frege sets out necessary and sufficient conditions for the truth of a Begriffsschrift conditional that Frege thinks that what Begriffsschrift conditionals express are truth conditions as they are normally understood, that conditionals in his logic are merely notational variants of conditionals of our standard logics. In his elucidation Frege does set out necessary and sufficient conditions for the truth, and hence judgeability, of a Begriffsschrift conditional, on the reading pursued here, only its role in inference can fully reveal the thought it expresses. 2.3 Begriffsschrift Latin italic letters. According to our reading, sentences of Begriffsschrift exhibit logical relations. In simple sentences such as LRJ, objects and concepts are exhibited in logical relations, for instance, here, the relation of subsumption, in conditionals it is whole thoughts that are exhibited in logical. 56. Relations. Both sorts of sentences are variously analyzable. But such sentences are not Frege's primary concern. As was suggested in Chapter 1, what are of utmost importance to Frege are the laws that govern modes of inference where such laws take the form of generalized conditionals. We need an account of such sentences. In particular, we need an account of Begriffsschrift generalized conditionals expressed using Frege's Latin italic letters. For, we will see, although Begriffsschrift generalized conditionals can be expressed using either Frege's Latin italic letters or his concaviti and German letters, only the former sorts of expressions are suitable to do duty in inference. Frege's two different ways of expressing generality, one using Latin italic letters and one using the concaviti and German letters, are equivalent at least to this extent. Given a generality expressed using Latin italic letters, one may make the transition to the corresponding generality expressed using the concaviti with widest scope, and conversely, from a generality expressed using the concaviti with widest scope one may infer the corresponding generality using italic letters. That is, the transition F is valid in Frege's logic, it is legitimate by one of Frege's few fundamental rules. Similarly, the judgment F is a fundamental law of Frege's logic. Inferentially, then, the two formulations are equivalent in the sense that anything that is provable from the one is provable from the other. Logically, on our reading, they are nonetheless very different. 9 On the standard reading, Frege's concaviti with German letters is his sign for the universal quantier, the Begriffsschrift sentence. F G is taken to be merely a notational variant of as usually understood, and Frege's rule and axiom are held to provide introduction and elimination rules for the universal quantier. According to this reading. 57. Begriffsschrift Latin italic letters and German letters function as free and bound variables, respectively. Russell explains the difference between these variables, a difference that was, he thinks, RST emphasized by Frege as follows: 10 Given a statement containing a variable x, say x equals x, we may affirm that this holds in all instances, or we may affirm any one of the instances without deciding as to which instance we are affirming. The distinction is roughly the same as that between the general and particular enunciation in Euclid. The general enunciation tells us something about all triangles, while the particular enunciation takes one triangle, and asserts the same thing of this one triangle. But the triangle taken is any triangle, not some one special triangle, and thus although, throughout the proof, only one triangle is dealt with, yet the proof retains its generality. Suppose, for instance, one wished to prove that psi x given that and that phi x. One could not draw the inference directly, for what phi x means is that the propositional function phi x is always true, and what means is that phi always implies psi x. In order to make our inference, we must go from phi x is always true to phi x, and from phi x always implies psi x to phi x implies psi x, where the x, while remaining any possible argument, is to be the same in both. 11 That is, we must replace the apparent variables in the quantized sentences that serve as premises with real variables that function as ambiguous object names. This gives us an instance of each of the two generalities, or, as Russell puts it, an undetermined one of all the propositions resulting from supposing to be this or that. 12 Once this has been done, the inference can be drawn by modus ponens. Real variables are thus essential in logic as Russell understands it. One needs to be able to introduce an arbitrary instance in order legitimately to apply rules of inference, for instance, modus ponens, to a generalized conditional. What one proves for this instance is then taken to hold generally, so that at the end of the proof one may pass back from real to apparent variables on the grounds that no inference is drawn in the course of the proof that could not equally well have been drawn were any other instance in the relevant class to have been considered instead. One reasons, in other words, about a particular case, but because no feature that this case does not share with all the other cases of the relevant kind is appealed to in the course of the proof, what is proven for that one case can be taken to be true generally for all members. 5858. Of the class. One needs real variables as well as apparent variables in such a logic because all deduction operates with real variables. 13. In 17 of Grundgesetze Frege might seem to be making essentially the same point. From the two sentences, all square roots of 1 are fourth roots of 1 and all fourth roots of 1 are eighth roots of 1, we can infer all square roots of 1 are eighth roots of 1. Now if we write the premises in this way: 4 equals 1 and 8 equals 1, 2 equals 1, 4 equals 1. Then we cannot apply our methods of inference. We can, however, if we write them thus: x4 equals 1 and x8 equals 1, x2 equals 1, x4 equals 1. Here we have a case of 15. The relevant rule in 15 is this. From the two propositions gamma and because uppercase Greek letters stand for objects, the rule given in 15 would appear to be the rule of hypothetical syllogism, that is, it applies to conditionals, sentences that have sentences did. 5959. Ignating truth values in antecedent and consequent. A sentence such as x4 equals 1 occurring to the right of a content stroke would have a truth value, however, just if x designated an object. Hence if the inference x8 equals 1, x4 equals 1, x4 equals 1, x2 equals 1 underscore 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 x8 equals 1, x2 equals 1 is indeed a case of the rule given in 15, then, it would seem, the quasi-sentences listed on the right must have truth values. But then the occurrences of x in these sentences must designate an individual, though it is left undetermined which one. What we need here is the notion of a simultaneous assignment of objects to free variables in different propositions. 15. If that is right, then Frege's Latin italic letters are functioning as free variables. It is easy to read Grundgesetze 17 as making Russell's claim that free variables are needed in logic because without them the logic of truth functions could not be brought to bear on logically general sentences. Other passages can seem to reinforce the point. But there is also a great deal of evidence in Frege's writings that, contrary to his claim in Begriffsschrift that his Latin italic letters serve to signify various things, Begriffsschrift Latin italic letters do not function as free variables. First, and most generally, it is Latin italic letters and not the concaviti with German letters that are, for Frege, the primary, and most natural, vehicle for the expression of logical generality. Latin italic letters used in the expression of generality are RST, introduced in Begriffsschrift 1, only much later, in 11, does the concaviti make its RST appearance. The concaviti is needed, Frege says in that later section, because it delimits the scope gebiet of the generality signed by the letter. 16. In the long Boole essay written shortly after Begriffsschrift, Frege again introduces generality, as marked by his Latin italic letters, before making any mention of his concaviti. The exposition has essentially the same structure in Grundgesetze. In 8 it is noted, RST, that a generality is distinguished from a statement of particular fact by the presence of letters that indicate in addition to those symbols that signify particular objects and concepts, but, Frege goes on, by this stipulation the scope of the generality 60-60 would not be well enough demarcated. 17. The point is made again in On the Aim. The purpose of the letter X is to make the whole judgment general in the sense that the content should hold whatever one may put in for X. It is sometimes necessary to convey the generality to a part of the judgment. Then I make use of German instead of italic letters. Similarly, we read in the To Logic, RST, that letters, like the in our example, serve to confer generality of content upon a sentence, and only 4 pages later, in a note, that in order to be able to narrow the scope over which the generality extends, I make use of Gothic letters, and with these the concavity demarcates the scope. Were Frege's Latin italic letters functioning as free variables, they would not be spoken of in this way, as the principal vehicle for the expression of generality. For the purposes of inference, a conditional that contains a variable in antecedent and consequent must be understood to be at once logically singular and ambiguous. It must be taken to be singular because otherwise the logic of truth functions could not be brought to bear on it, but it must also, for the purposes of proof of a generality, be conceived as systematically ambiguous, or, as Russell puts it, absolutely ambiguous. 18. It must refer to a particular object, but nevertheless to no object in particular. We have already seen that Frege at RST writes as if Latin italic letters of Begriffsschrift function in just this way. He claims in one of Begriffsschrift, I therefore divide all the symbols I employ into those which one can take to signify various things and those which have a completely XED sense. Frege also uses a variable name in his example in Begriffsschrift 8 to show why the identity sign is needed in logic. 19. In his later writings, however, Frege seems explicitly and categorically to reject the idea of such ambiguous symbols in logic. It is absolutely ruled out that a sign be equivocal or ambiguous. Where they do not stand for an unknown, letters in arithmetic have the role of conferring generality of content on sentences, not of designating a variable number, for there are no variable numbers. Nor do there seem to be any variable names, any variables, in Frege's logic on his mature understanding of it. 20. We may perhaps seek a way out by taking the view that the letters X and Y are not signs for what is variable, but are themselves the things that vary. But if we do this, we run foul of the established use of our signs. We cannot even say that although it is not given a determinate meaning, nevertheless it is given an indeterminate one, for an indeterminate meaning is not a meaning. There must be no ambiguous signs. 61. In a properly logical language, Frege comes to think, a designating symbol, whether it be an object name, a concept word, or a sign for a logical function, must designate something that is, some one thing in particular. Free variables do not designate some one thing in particular, and they cannot if they are to play their logical role in proofs of universally quantied sentences. Latin italic letters of Begriffsschrift, Frege comes to think, have a role that fundamentally contrasts with the role of designating symbols. Whereas an object name or concept word has its own specific meaning, that is, it designates something, some particular object in the case of an object name and a certain concept in the case of a concept word, a Latin italic letter only indicates an object, it does not have a meaning, it designates or means nothing. An italic letter simply does not have the purpose of designating a number, as does a number sign, or for that matter of designating anything at all. These letters are not at all intended to designate numbers, concepts, relations, or some function or other, rather they are intended only to indicate so as to lend generality of content to the propositions in which they occur. A Latin italic letter of Begriffsschrift does not designate indeterminately or arbitrarily, for it does not designate at all. Nor does it have a sense. A sign which only indicates neither designates anything nor has a sense, though, as Frege immediately goes on, that is not yet to say it could not contribute to the expression of a thought. It can do this by conferring generality of content on a simple sentence or on one made up of sentences. But, it will be objected, Frege's concavity with German letter also serves to confer generality of content, and in that case too the letters involved only indicate. Because, as Frege clearly recognizes, the concavity is needed in all but the special case in which the generality has widest scope, it surely is really the concavity that is the principal sign for generality in Begriffsschrift, just as the universal quantier is the principal sign for generality in any standard quantificational logic. Expressing generality by using Latin italic letters in the case in which the generality has widest scope is, as Frege himself says, merely an abbreviation. Because Frege takes this view even in Grundgesetze, it can seem clear that, contrary to the view we have begun to outline here, his concavity with German letter functions in just the way a universal quantier does. The crucial question, however, is whether, on Frege's most carefully considered, overall view, his concavity with German letters and his Latin italic letters function, respectively, as universal quan. 62-62. Tires and as free variables. Frege himself notes in the 1906 to Logic that it was not until after some time that he himself became aware of this use as a special case. On our reading, this is exactly right. Coming to clarity about the exact logical relationship between his two means of expressing generality in Begriffsschrift was not at all easy for Frege, and as we will see in more detail in section 3.3, it was not easy because that relationship is obscured in all but the most complex of cases. In the simplest cases, that is, in just those cases one is liable to have in mind in any initial explication of the notation, the use of the concavity notation as a special case, and so its real logical function, is essentially invisible. Frege does often describe his notation for generality in ways suggestive of a Russell-Lien reading, at least to anyone already familiar with that logic, but he also often describes that notation in ways that are incompatible with that reading. It is the latter passages we focus on here, and we do so because, all texts considered, it is the latter passages rather than the former that seem best to reap Frege's most considered views. On Frege's considered view, Latin italic letters have neither sense nor meaning. They do not designate indeterminately, they do not designate at all. Their role is to confer generality of content. The way they play this role is indicated, if only in a preliminary way, by the fact that, according to Frege, an expression such as a is greater than 2, taken out of the context of a conditional in which it occurs as the antecedent or consequent, is senseless. We cannot split up the sentence expressing the general thought without making the part senseless. For the letter a is meant to confer generality of content upon the whole sentence, not on its clauses. With a is greater than 2 we no longer have a part expressing a thought, it neither expresses a thought that is true nor one that is false, because a is neither meant to designate an object as does a proper name, nor to confer generality of content upon this part. It has no function at all in relation to the part. If a were functioning as a variable, it would have a function in relation to the part, indeed, that is the essential role of a variable, to confer content on the part in a way that enables the logic of truth functions to be applied to a sentence containing it. Yet Frege denies that his Latin italic letters function in this way. On his view, a conditional written using Latin italic 63-63 letters expresses a single thought which cannot be divided into component thoughts. Because they have no function at all in relation to the part, because they serve to confer generality only over a sentence as a whole, Latin italic letters of Begriffsschrift seem not to be functioning as variables. The logical role of Latin italic letters, as Frege understands them, is further indicated by the fact that they are modeled on the literal notation in arithmetic. The most immediate point of contact between my formula language and that of arithmetic is the way the letters are used. In Begriffsschrift itself Frege only illustrates the use of letters as they contrast with signifying symbols in arithmetic. The symbols customarily used in the general theory of magnitudes fall into two kinds. The RST consists of the letters, each of which represents either a number left undetermined or a function left undetermined. This indeterminateness makes it possible to use letters for the expression of the general validity of propositions, as in C equals AC plus BC. The other kind consists of such symbols as plus, square root, 0, 1, 2, each of which has its own specific meaning. Frege's thought is to adopt this fundamental idea of distinguishing two kinds of symbols and to use letters for the expression of generality. But how exactly are we to read the sentence C equals AC plus BC? Only much later, in Function and Concept and some notes written in 1910 in response to remarks by Jourdain, does Frege suggest an answer. Jourdain had written that in universal algebra, as Russell has pointed out, our signs of operation have variable meanings. Frege responds, if, for example, we wish to investigate what follows from the laws A plus equals plus C and plus C equals plus B quite independently of the usual denotation of the sign of addition. One ought wholly to avoid the word addition and the sign plus and express the laws thus: FAF equals FF, C, and FF, C equals FF, B. Now the letter F serves to make the consideration general. What Frege seems to have in mind can be illustrated for the simpler case in which it is object names that are replaced by letters. Suppose that one wished to investigate what other sorts of A are. 64. Arithmetical expressions may be put solva veritate for the expression in an arithmetical formula quite independently of the usual denotation of the signs 2, 3, 4, and 5. One wishes to investigate, that is, not the particular case but, as it were, cases of this form. One wishes to make the consideration general, so one writes instead. But now what should one do? In the particular case the task is obvious. Assuming that one knows one's basic arithmetical facts, one knows just what to do: add 2 and 3 to yield VE, and 4 and VE to yield 9, then multiply VE and 9 to yield the answer, 40. In the general case the problem is very different. One cannot add A and B or C and D, for these signs do not designate any numbers. Because they do not, solving the problem set by requires fundamentally different resources from those needed to solve. It requires appeal to features of the functions of addition and multiplication themselves, not to the values they give for particular arguments. Having only the operations of addition and multiplication to go on, one discovers, say, that equals AC plus BC plus add plus BD. As the manner of its derivation makes manifest, this law of arithmetic holds no matter what numerals are put in the place of the letters. Whereas in the numerical case one discovers a truth about numbers, that the sum of 2 and 3 times the sum of 4 and VE is equal to 40. In the algebraic case one discovers a truth about arithmetical functions, that the product of two sums equals the sum of 4 products. In the algebraic case, numbers do not come into it at all, the sentence is directly about functions. Making the consideration general in this way pushes our thinking up a level, from consideration of numbers to consideration of functions. Just this point is made in Frege's closing remarks in Function and Concept. To replace function symbols with letters, as Frege does in his remarks to Jourdain, is to move things up another level again. In that case one's concern is with second-level functions, and with the laws that involve them. 21. In the late fragment Frege again appeals to the use of the literal notation in arithmetic to clarify the logical role of Latin italic letters in Begriffsschrift. It is natural to copy the methods of arithmetic by selecting letters for indefinitely indicating parts of a sentence. If A is a man, A is a mortal. Here the equiform letters cross-refer to one another. Instead of let 65 ter's equiform with A, we could just as well take one's equiform with B or C. But it is essential that they should be equiform. However, taken strictly, we are stepping outside the canons of a spoken language designed to be heard and moving into the region of a written or printed language designed for the eye. The language we have just indicated contains two different constituents, those with the form of words and the individual letters. The former correspond to words of the spoken language, the latter have an indefinitely indicating role. Indicating letters, Frege says, do not have the form of words, they are not meaningful bits of language, as designating symbols are. Their role is essentially different from the role played by words. This role, we are furthermore told, is one that can be played only in a written language, a language designed for the eye, because all that matters to the proper functioning of indicating letters is that they be equiform. We could, that is, use any sort of meaningless squiggles we like as indicating letters, so long as they were equiform. Frege's indicating letters are in this respect quite like our schematic letters. Nevertheless, unlike schematic letters, such letters contribute to the expression of a thought, and they do so, we have suggested, by pushing everything up a level. Conferring generality of content on a Begriffsschrift conditional by replacing an object name that occurs in the main component and subcomponent with a Latin italic letter enables the expression of a logical relation among concepts. The general point that genuine hypotheticals express relations among concepts is RST made in the long Boole essay and again in Grundlagen 47. It is true that at RST cite the proposition all whales are mammals seems to be not about concepts but about animals, but if we ask which animal then are we speaking of, we are unable to point to any one in particular. Even supposing a whale is before us, our proposition still does not state anything about it. We cannot infer from it that the animal before us is a mammal without the additional premise that it is a whale, as to which our proposition says nothing. As a general principle, it is impossible to speak of an object without in some way designating or naming it, but the word whale is not the name of any individual creature. However true it may be that our proposition can only be varied by observing particular animals, that proves 6666. Nothing as to its content. To decide what it is about, we do not need to know whether it is true or not, nor for what reasons we believe it to be true. Aside from the conditional and horizontal strokes, the only designating symbols in the Begriffsschrift rendering of the judgment that all whales are mammals, M, W, are the two concept words W psi and M psi. The sentence contains no object names, so, Frege suggests, it is not about any particular animals, or any other objects. The fact that the proposition is varied only by consideration of actual animals does not imply that reference to animals is somehow involved in its content. The question of how we arrive at the content of a judgment should be kept distinct from the other question, whence do we derive the justification for its assertion? Again, we read in Logic in Mathematics, we must not think that I mean to assert something about an African chieftain from darkest Africa who is wholly unknown to me, when I say all men are mortal. I am not saying anything about either this man or that man, but I am subordinating the concept man to the concept of what is mortal. As Frege understands it, the generalized conditional that is expressed in English as all men are mortal does not say that everything that falls under the concept man falls also under the concept mortal. It instead subordinates one concept to another. Objects do not come into it at all though, of course, given that there is a logical relationship of subordination between the two concepts man and mortal, then it follows that all actual men are mortal. If anywhere there was a man who was not mortal, this would be sufficient to show not only that the matter of factual generality, that all men are mortal, is false, but also that the concepts man and mortal are not related by subordination. Nevertheless, the generality itself, Frege suggests, in no way involves reference to objects. A genuine hypothetical exhibits two concepts in the logical relation of subordination. If that is right, then Latin italic letters function together with the conditional stroke to enable the expression of logical relations among concepts, and they do so much as plus and equals function together in, for instance, 2 plus 3 equals 5 to enable the 6767. Expression of an arithmetical relation among numbers, one that can be analyzed in various ways. In order to prove, in standard modern logic, that all as are C given that all as are B and that all B's are C, one must RST turn to an arbitrary instance of something that is B if A, and thereby to a hypothetical judgment whose main connective is a horseshoe. Only then can the rules of the propositional calculus be applied. In effect, for the purposes of reasoning, categorical sentences are reduced to hypotheticals. The Boolean pursues the converse strategy of assimilating hypotheticals to categoricals. As Frege puts the point, Boole construes the hypothetical judgment if B, then A as a case of the subordination of concepts, by saying the class of time instance at which B is included in the class of time instance at which A. According to Boole, we are to understand a hypothetical syllogism as a case of Barbara. Both the quantificational logician and the Boolean thus see a similarity in underlying form in the two cases. The strategy in both cases is to take one argument form to be the basic one and to tee the other somehow into that mold. 22 Frege's way, on our reading, is different from both. Frege suggests in Grund Gesetze 17 that just as from the two propositions gamma and, so from the two propositions x4 equals 1 and x8 equals 1, x2 equals 1, x4 equals 1. We may infer the proposition x8 equals 1, x2 equals 1. But, it seemed, the latter could be an instance of the former only if x was functioning as a variable, that is, as a designating symbol, though it is left undetermined what is designated. For only so, we reasoned, could the x 68 prescience x2 equals 1, x4 equals 1, and x8 equals 1 be taken to stand for objects, as required for the application of the rule in 15. But, we have since seen, Frege comes explicitly to hold that x has no role to play in relation to the part. On Frege's mature view, Begriffsschrift judgments such as x8 equals 1, x2 equals 1 do not express relations among thoughts, for, again, such a sentence expresses a single thought which cannot be divided into component thoughts. That thought, furthermore, is a thought about concepts, that one concept is subordinate to another. If, then, the inference x8 equals 1, x4 equals 1, x4 equals 1, x2 equals 1 underscore 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 x8 equals 1, x2 equals 1 is an instance of the rule in 15, it is so not in virtue of the role the conditional stroke and variables play in Begriffsschrift, but instead in virtue of the fact that the conditional stroke together with Begriffsschrift Latin italic letters enables the expression of relations among concepts. Barbara, on this view, is an inference form that functions at the level of concepts, and hypothetical syllogism is an inference form that functions at the level of whole sentences or truth values. What Frege shows is that these are nonetheless inferences of the same fundamental form. His official formulation of the rule that governs these inferences makes exactly this point: if the same combination of signs occurs in one proposition as main component and in another as subcomponent, a proposition may be inferred in which the main component of the second is main component, and all subcomponents of either, save the one mentioned, are subcomponents. But subcomponents occurring in both need be written only once. From the perspective of the reading pursued here, to take a genuine hypothetical of Frege's logic to express a relation between two quasi-sentences is fundamentally to misunderstand the role played by Latin italic. 69. Letters in Frege's logic. In genuine hypotheticals, Latin italic letters function together with the conditional stroke to enable the expression of relations among concepts. They do not, in such sentences, belong with the concept words as if the conditional stroke then related two quasi-sentences, they belong instead with the conditional stroke to enable the expression of a relation between two concepts. Though it is made at the level of relations of concepts rather than at the level of relations of truth values, an inference in Barbara, in Frege's logic, is an inference of precisely the form given in the rule of 15. Given the way Latin italic letters function to lend generality of content in this logic, nothing is needed to play the role that is played by real variables in Russell's logic. In Frege's logic, as in a traditional term logic, one infers directly from the sentences all square roots of 1 are fourth roots of 1 and all fourth roots of 1 are eighth roots of 1 to the conclusion all square roots of 1 are eighth roots of 1. One can do this because what genuine hypotheticals express are not relations among sentences but instead relations among concepts. 2.4 The diversity of logical relations. We saw in section 2.2 that Frege's two-dimensional conditional stroke enables the formation of expressions for logical relations of arbitrary complexity among sentences. 23 A simple conditional such as AB exhibits a logical relation, and in just the same way a logically complex sentence such as ABCDE exhibits a logical relation. But such sentences seem to be of interest to Frege only indirectly. Insofar as his primary concern is with the laws that govern modes of inference, which are expressed in Begriffsschrift as generalized conditionals, that is, as genuine hypotheticals, mere hypothetical. 70. Compounds such as the sentences just given are of interest primarily because, In conjunction with indicating letters lending generality of content, they can be used in the expression of relations among concepts. The significance of the two-dimensional conditional stroke lies in the fact that it is to designate the subordination of a concept under a concept, and other important relations. A generalized conditional of Begriffsschrift, something of the form M. N. exhibits the concepts M psi and N psi in a relation of subordination. It shows that whatever falls under the concept N is correctly judged to be also M, and in this way gives as a formula the rule of inference that if one judges of something that it is N, one is entitled to infer that that same object is M. Furthermore, just as one can form sentence connectives of arbitrary logical complexity in Begriffsschrift as we read it here, so one can form connectives of arbitrary complexity among concepts. The Begriffsschrift judgment M. N. exhibits the concepts designated by M psi and N psi in the logical relation of subordination. The Begriffsschrift judgment A. B. B. A. similarly exhibits a logical relation among the two concepts designated. The sentence shows these concepts in a certain second-level logical relation, and it does so in a way that enables one to take various perspectives on the sentence as required for understanding the goodness of judgments and inferences. The fundamental expressive significance of Frege's Latin italic letters so understood is to preserve, in this way, the peculiar expressive power of his two-dimensional conditional stroke for the case of relations among concepts. Frege's Latin italic letters achieve their expressive purpose by moving everything up a level, from consideration of objects and their 7171 properties and relations to consideration of concepts and their properties and relations. On this reading, Frege's logical language functions as a fundamentally different kind of language from that of quantificational logic. Rather than directly saying something about something, Begriffsschrift sentences display objects, concepts, and truth values in logical relations of various kinds and can be analyzed in various ways. 24 In simple sentences such as LRJ, objects and concepts are exhibited in logical relations, for instance, the relation of subsumption. In conditional sentences such as PQR, truth values, the Bedeutung of sentences, are exhibited in other logical relations, relations that can be arbitrarily complex in virtue of the distinctive way Frege's conditional and horizontal strokes can be combined. In genuine hypotheticals, that is, generalized conditionals expressed using Frege's Latin italic letters, it is concepts and relations that are exhibited in logical relations, for instance, the relation of subordination. None of these sorts of sentences are to be read as saying that the relevant objects and concepts stand in those logical relations, they are only exhibited as standing in those relations. What is presented says something about something, that is, involves a function and argument, only relative to an analysis. As we read Begriffsschrift, there is no essential logical difference between reading LRJ as ascribing the second-level property of Romeo, phi, to the RST-level concept L psi j and reading it as ascribing the RST-level relation L psi zeta to the objects Romeo and Juliet. A multiply conditioned conditional of Begriffsschrift, similarly, can be read in various ways. In the conditional itself, there is no main connective. As we have just seen, Frege's Latin italic letters can be taken to function in conjunction with the conditional stroke to enable the point to be applied in conditionals that are generalized. On this reading, generalized conditionals of Begriffsschrift expressed using Latin italic letters exhibit concepts in logical relations of arbitrary complexity in a way that is strictly analogous to the way mere conditionals exhibit sentences in logical relations of arbitrary complexity. In both cases, as in the case of a table or tabular list, there are many different paths one can take through the two-dimensional array. We know already from the quantificational case that simple sentences such as 7272 LRJ must be variously analyzable to account for the goodness of the variety of inferences in which they can occur. In Frege's logic, the point is generalized to the case of multiply embedded truth functions and, through the use of Latin italic letters, even to generalized conditionals. But even these features of Frege's logic do not exhaust its extraordinary expressive power. Indeed, they only scratch the surface. Much as the full expressive power of quantificational logic is revealed only in sentences that involve both universal and existential quantities, so the full expressive power of Frege's logical language is revealed only in sentences that employ both the concavity notation and German letters, and Latin italic letters lending generality of content. We turn now to an account of such sentences. 73-73. 3. A more sophisticated instrument. We are very dependent on external aids in our thinking, and there is no doubt that the language of everyday life had RST to be replaced by a more sophisticated instrument before certain distinctions could be noticed. But so far the academic world has, for the most part, disdained to master this instrument. Introduction to Logic, 1906. Although Frege's notation remained essentially unchanged from its RST introduction in 1879 to the end of Frege's life in 1925, Frege's understanding of that notation was radically revised. The best-known revisions concern the distinction between Sinn and Bedeutung RST introduced in 1891, but as already indicated, there are others as well. First, the distinction between concept and object comes to be characterized more sharply in the mature logic, and from this results further the distinction between RST and second-level functions. In Begriffsschrift, Frege had characterized a function as that part of an expression that shows itself invariant. In the mature logic, a RST-level concept is conceived instead as a law of correlation that maps objects onto truth values. A second-level concept is similarly a law of correlation, one from RST-level concepts to truth values. The difference between generalities expressed using Frege's Latin italic letters and those expressed using the concavity and German letters is also clarified. Whereas in Begriffsschrift Frege had claimed that the concavity is merely a means of delimiting the scope of a generality, that in the case in which the generality has widest scope the sentence can be abbreviated by means of his Latin italic letters, in the Grundgesetze logic of 1893 the two means of expressing generality are logically distinguished, and by the late 1890s the distinctive expressive role played by the concavity is fully comprehended. Finally, and in part as a result of these developments, Frege's conception of the nature and status of the laws of logic is also fundamentally revised. The laws of logic are not merely maximally general, as Frege seems at RST to have thought, nor are they peculiarly formal, as is suggested in Grundlagen. 74. The laws of logic, like any other laws, have their own content. What is distinctive about them is that they concern higher-level concepts and relations. Already in the notation of the 1879 logic Frege unerringly draws the distinctions that are needed in his logic, only in the mature logic are these distinctions adequately comprehended. It is to this NE structure of Frege's more sophisticated instrument that we now turn. 3.1 The advance from level to level. In Function and Concept, read before the Gesellschaft für Medizin und Naturwissenschaft on January 9, 1891 and published that same year, Frege RST presents what he describes as some supplementations and new conceptions, whose necessity has occurred to me since then, that is, since Frege had last presented a paper on Begriffsschrift before the Society. 1. The essay begins and ends by recalling the history of arithmetic, the advance from level to level that culminates in an adequate conception of the concept of a function. As Frege outlines that history, it has three principal stages. First, people calculated with individual numbers to produce theorems such as that 2 plus 3 equals 5, that 2 times 3 equals 6, and so on. Then they went on to more general laws that hold good for all numbers. What corresponds to this in symbolism is the transition to the literal notation. That is, they began to formulate the basic and derived laws of elementary algebra. The last level is reached with the formulation of laws in higher analysis, which hold good for all functions, and the introduction of letters that serve to indicate functions indefinitely. Because, according to Frege, the RST place where a scientific expression appears with a clear-cut meaning is where it is required for a law, it is only at this third stage that we achieve an adequate conception of arithmetical functions. But a concept, on Frege's mature view, just is a function, it is a law of correlation whose value is always a truth value. A similar account, then, ought to be formulable for developments in the science of logic, not an actual history perhaps, but a rational reconstruction of advances in that science highlighting the fundamental conceptions and transformations that are required to realize a logically adequate language. This reconstruction will serve to introduce all the main themes at issue here. We begin with a very primitive language, Sellers's jumbles, a language that contains only object names. 2. In jumbles, instead of using predicate expressions to ascribe properties and relations to the objects named, one writes those names themselves in various ways. To say that something, the 7575 object O, is red, say, one writes its name in bold, O. To say that Romeo loves Juliet, one perhaps writes a name for the former just before a name for the latter, RJ. In this way, in jumbles, one exhibits how things stand with objects by exhibiting names, representatives of those objects, in various ways. In such a language one does not say how things are, rather, one shows how things are. One shows that two things have something in common, that they share some feature, by writing their names the same way. Now we enrich the language slightly with the introduction of signs for properties and relations, which enables us not only to show that, say, O is red, but also to say that it is, not only to show that Romeo loves Juliet, but also to say so, and so on. The next step is to learn to read the language in the new way already introduced in section 2.1, the sentence LRJ, for example, not as ascribing the relation loving to Romeo and Juliet, but instead as exhibiting two objects and a relation in the higher level logical relation of subsumption. Independent of an analysis into function and argument, the sentence so read does not say anything but only shows what is the case if it is true. To formulate truth conditions for the sentence requires giving it a function/argument analysis, and many such analyses are possible. In the language as it has been developed to this point, as in ordinary language, logical relations are almost always only hinted at left to guessing, not actually expressed. The next step is to make these relations explicit. We need, that is, to be able to express general laws about concepts, which requires in turn our moving up a level through the development of a sign for the conditional and the introduction of the literal notation. It is, for instance, always in order to judge of an object that it is colored given that it is red. What we want to show in our language is that this inference is a good one whatever the object being considered. We do so by RST showing that the judgment of an object that it is colored can be grounded in the judgment of it that it is red through the use of the conditional stroke and then replacing the object names with letters, or indeed any sort of squiggle so long as they are equiform, perhaps like this, cr. This sentence shows, on our reading, that its being red is a sufficient condition for the judgment of a thing that it is colored, that is, that one can 7676 judge of something that it is colored on the basis of the judgment that it is red, and it does so by presenting one concept as subordinate to another. Through its use of Latin italic letters lending generality of content and the two-dimensional conditional stroke, the sentential sign cr exhibits the properties of being red and being colored in the logical relation of subordination, and it does so in a way that is strictly analogous, at a higher level, to the way the sentence RJ of jumbles exhibits Romeo and Juliet in the relation of loving. Whereas the jumbles sentence RJ exhibits a relation among objects, a begriffsschrift generalized conditional exhibits a relation among concepts. The next step is to introduce signs that enable one not only to show that one concept is subordinate to another but also to say that it is. Frege's concavity notation can be read in just this way. If it is, then the judgment cr says of the concepts red and colored that the former is related to the latter by the relation of subordination. The sign psi, phi, that is, is to be read as a sign for the second-level relation of subordination, and the sentence C R as analogous to LRJ but at a higher level, as standing to its counterpart written using Latin italic letters as LRJ stands to the jumble sentence RJ. Here again, we can learn to read the sentence in a new way, not as ascribing the second-level relation subordination to the RST-level concepts read and colored, but as merely exhibiting RSTAN's second-level concepts in a logical relation. The sentence so read can be variously analyzed. We can, for instance, take the judgment 7777 C R to involve the second-level function psi phi for arguments C psi and R psi, or alternatively as involving the second-level function psi for argument C psi R psi. We can also analyze it as involving the second-level concept psi R for argument C psi, and so on. Now we are in a position to move up another level again. We saw that the logical relationship between a simple sentence such as rho and another co could be laid bare in the judgment that exhibits read as subordinate to colored expressed using Frege's Latin italic letters and the two-dimensional conditional stroke. But this sentence, read is subordinate to colored, similarly stands in certain logical relations to other sentences. One can correctly argue, for instance, that because read is subordinate to colored and colored is subordinate to extended, it follows that read is subordinate to extended. The null level is reached with the use of the literal notation to show that such an inference is a good one no matter what RST level concepts are being considered. The relation of subordination, which is a second-level relation of RST level concepts, is transitive, and we show that it is by replacing all RST level concept words with letters, for instance, this way: H F G F H G. This sentence, we should be able to see, exhibits not how things stand with objects, nor even how things stand with concepts, but in 7878. Stead how things stand with relations of concepts. It is analogous to the judgment CR, but at a higher level. In virtue of the peculiar expressive capacities here assigned to Frege's German and Latin italic letters, this Begriffsschrift sentence shows that the second-level logical relation of subordination is transitive. It exhibits a general law about concepts, and it makes essential use of the different expressive capacities of Frege's Latin italic and German letters in so doing. In this sentence, German letters together with the concavity and the conditional stroke serve in the formation of a concept name for the relation subordination, and the Latin italic letters enable one to show something about this designated concept, namely, that it is transitive. We are thus using a third-level concept, transitive, but have no sign for this concept. We show but do not say that a certain second-level concept, subordination, which is designated, is transitive. In logic, as in mathematics, we can discern in this way and advance from level to level beginning with judgments about particular objects, then up a level to judgments about concepts through the use of the literal notation, and nally, up a level again to judgments about higher level concepts and relations. Already in Chapter 2 a reading was developed of judgments at the second level, that is, of the logical significance of Frege's two-dimensional conditional stroke, of the role his Latin italic letters play in lending generality of content, and of the way these signs of Begriffsschrift function together to enable the exhibition of logical relations, paradigmatically the relation of subordination, among concepts. Our interest now is in the later developments, Frege's mature understanding of the concept of a concept, of the concavity notation, and of the laws of logic as laws that hold for RST-level concepts generally. 3.2 What is a function? In Begriffsschrift, a function is characterized as that part of an expression that shows itself invariant, and Latin italic letters are described as symbols, which one can take to signify various things. Together these remarks suggest that the expression that remains invariant in, say, 1 2 plus 3 1, 2 2 plus 3 2, 3 2 plus 3 3, and so on, is a function that, if the argument position is marked by, say, x, yields a variable name, x2 plus 3x. The impression is reinforced by the fact that 7979. Frege appeals to just such a name in his example, in Begriffsschrift 8, aimed at showing why the sign for identity is necessary in logic. We are to let a straight line rotate about a xed point A on the circumference of a circle, call the point of intersection of the two lines the point B corresponding to the straight line at any given time. In that case the name B denotes something undetermined as long as the corresponding position of the line is not yet specified. The name B, that is, has the form f, the point it signs varies with the position of the line rotating about the xed point A on the circumference of the circle. It is just this conception of an arithmetical function that Frege explicitly and repeatedly rejects in his later writings beginning with Function and Concept in 1891. 3. Both the Grundgesetze account of functions and that of Function and Concept begin with essentially the view Frege himself takes in Begriffsschrift, that a function of x is a mathematical expression that contains x and expressions such as x. In the mature works Frege immediately rejects the formulation on the grounds that a function is not an expression any more than a number is a numeral. So, perhaps one might say, the function is what is designated by the expression x much as the number 2 is not the numeral 2 but instead what is designated by it. But what sort of entity is designated by x? Not any number, though if x were replaced by a sign for a number, then the resulting expression would designate a number. As it stands, then, x seems only indefinitely to indicate a number. In Frege's Begriffsschrift terminology, depending on what number one takes the x to signify, the whole expression will signify various numbers. But as Frege now points out, these numbers are also not the function. The essence of the function manifests itself rather in the connection it establishes between the numbers whose signs we put for x and the numbers that then appear as denotations of our expression, a connection intuitively represented in the course of the curve whose equation in rectangular coordinates is y equals x. Accordingly the essence of the function lies in that part of the expression which is there over and above the x. The expression for a function is in need of completion, unsaturated. The letter x serves only to hold places open for a numeral that is to complete the expression. 80. Neither the x in x nor any number given as argument is part of the function. The function is what is designated by that part of the expression that is left over when the x is removed. The x serves only to mark the argument place. The nature of the confusion Frege is concerned to dispel can be brought out by consideration of embedded functions, the function too, say. Like any function, the function designated by the expression 2 correlates numbers as arguments with numbers that are the values of the function for those arguments. The essence of the function, Frege suggests, lies in this correlation. But our function seems to be arithmetically complex. In its expression, the function designated by 1 plus x seems to occur as the argument for the function y2, and yet what occurs as the argument for that function can only be a number, not a function. If we nonetheless insist on thinking of the function designated by 2 as embedding one function in another, then, because we cannot think of 1 plus x as itself a function in this context, and because it is clearly not a number, we shall have to think of it as a kind of indefinite number or variable name. Because any function can be embedded in this way, one comes to think that a function is a kind of indefinite number or variable name, one that becomes determinate when a number is supplied as the value of the variable in that variable name. In fact, as Frege comes clearly to see, 1 plus x does not function as a variable name in 2. The difference between 1 plus x and 2 is merely the difference between a less complex function expression and a more complex function expression. The signs for functions such as that designated by 2 are built up out of the signs for arithmetically simple functions, but the functions so designated are not complex. They, like any arithmetical functions, are laws of correlation between numbers. For Frege aims in his mature writings to establish that a function is something in its own right over and above the numbers it correlates as argument and value. In Function and Concept he illustrates what is wanted, the notion of a function as something in its own right, albeit unsaturated by analogy. We are to imagine a line of night length divided by a point. One is inclined in that case to count the dividing point along with both segments, but if we want to make a clean division, i.e. so as not to count anything twice over or leave anything out, then we may only count the dividing point along with one segment. This segment thus, 8181, becomes fully complete in itself, and may be compared to the argument, whereas the other is lacking in something, viz. The dividing point, which one may call its endpoint, does not belong to it. Only by completing it with this endpoint, or with a line that has two endpoints, do we get from it something entire. As a line without an endpoint is lacking something, is not something complete or entire, but is nevertheless a perfectly objective entity, so, Frege now holds, a function is incomplete or unsaturated but nevertheless perfectly objective, something in its own right. It is what is designated by that part of an expression such as x when the two tokenings of x are removed. But why does arithmetic require such a notion? Why must we take a function to be something objective, albeit unsaturated? The answer, Frege suggests in the opening remarks of Function and Concept, lies in higher analysis because here for the RST time it was a matter of setting forth laws holding for functions in general. Frege's example of such a law is this, dfx fx dx fx dfx dx fx dfx dx equals plus. By contrast with a law such as c equals ac plus bc, which with individual functions but does not require the coinage of the technical term function, laws that hold for functions generally do require explicit reference to functions. Such laws, then, introduce something essentially new, though, Frege thinks, to be sure, people have not always been clearly aware of this. Two key moments in the history of higher analysis will serve to highlight what it is that is new here. In traditional accounts of derivatives, one begins with the notion of the rate of change of a straight line, that is, its slope as given by the difference quotient fxx plus delta delta. The rate of change of a smooth curve is then conceived as the limit, as delta x approaches 0, of the difference quotient. Where f equals x2, for example, the derivative dx2/dx is given by lim delta x rightward arrow plus 0 2 82. This, we know, is equal to 2x. The problem is to prove the equality, and the RST attempts to solve it were algebraic. Lim delta x rightward arrow plus equals 0 2 0 2 0 2x plus delta. If, now, it could be assumed that delta x does go to 0, then that would give the answer that is wanted, 2x. But we cannot assume that because if delta x did go to 0 then the difference quotient by way of which we derived our answer would be meaningless, 0. If, however, delta x does not go to 0 but only approaches it indefinitely closely, then we cannot get the answer that is wanted, 2x, but only 2x plus delta x. The solution, Leibniz famously argued, is to take delta x to be, though not equal to 0, nevertheless very, very small, infinitesimally small, so small that when it is added to any ordinary number, the sum is just that number itself. 5. The term delta x is not equal to 0, so the difference quotient is meaningful, and yet in a way delta x is equal to 0 because 2x plus delta x equals 2x. Problem solved. Unsurprisingly, the solution was not met with universal approval. That Newton's method of oxygens did not fare much better is suggested by Berkeley's delightful observation that he who can digest a second or third oxygen, need not, methinks, be squeamish about any point in divinity. 6. By the mid-19th century it had become clear that the problem with these early attempts to understand limit operations such as differentiation did not concern the details but instead the conception of the task as essentially algebraic. As the work of Cauchy, Bolzano, and Weierstrass showed, limit operations are fundamentally different in kind from standard algebraic operations, as different from them as algebraic operations are from calculations with numbers. As the point can be put, whereas the function psi2 in 2 takes as its argument not the function 1 plus x but instead the value of this function for some argument, the function d phi slash dx in dx2 slash dx does take the function x2 as argument. It is just this difference that is highlighted in a law such as dfx fx dx fx dfx dx fx dfx dx equals plus, as it contrasts with a law of algebras such as c equals ac plus bc. In the former case but not the latter, the expression of the law requires the use of letters that indefinitely indicate functions. It shows thereby that the argument in this case is not a number but instead a function. But if functions can themselves be arguments for higher level functions just as objects such as numbers can be arguments for RST level functions, then, d. 8383. Spite their incompleteness, functions must be something in their own right, something objective. Because, according to Frege, a concept, as that notion is needed in logic, just is a function that gives truth values as values, concepts similarly must be something in their own right, something objective, albeit unsaturated. Just as objects can, concepts can serve as arguments for concepts. 7. 3.3 The expressive role of the concavity with German letter. As the development of higher analysis reveals, arithmetical functions must be something in their own right, something objective that can serve as arguments for higher level functions despite their being inherently unsaturated. Concepts, similarly, Frege comes to hold, are something objective, albeit unsaturated, that can serve as arguments for higher level concepts. These higher level concepts, in turn, he eventually comes to see, are designated by expressions that make essential use of his concavity and German letters. In the elucidations of the 1879 logic and in the 1879 logic itself, no distinction is marked between RST and second-level concepts. Even in the 1893 logic, which does draw this distinction, the concavity with German letter is again introduced as a means of marking distinctions of scope. Were that its only role, there would be no logical justification for introducing a new sort of letter in combination with the concavity. On the other hand, already in the early logic various second-level concepts and relations are introduced and theorems about them proved. It is also possible to see that the concavity with German letters plays an essential role in the formation of expressions for these second-level concepts and relations. Frege proves, for instance, that the second-level relation of following in a sequence is transitive, if y follows x in the f sequence, and if z follows y in the f sequence, then z follows x in the f sequence. In Begriffsschrift, gamma f beta gamma f beta gamma f beta. In this judgment the second-level relation of following in a sequence is designated using a Dean sign. What this sign means is given by 8484. Phi. Phi. In this latter sign the Greek letters psi and zeta mark the object name positions and phi the two-place relation position. The sign taken as a whole thus functions as a concept word for the second-level concept of following in a sequence, one that in the context of a judgment might be variously analyzed. Only later did Frege come explicitly to realize that it is precisely this expressive role played by the concavity with German letters in the formation of such higher-level concepts which, it will be suggested in section 3.4, are the subject matter of logic that provides the logical justification for the introduction of a new sort of letter in combination with the concavity. A Begriffsschrift generality is correctly acknowledged to be true just in case the corresponding function is a fact whatever we may take as its argument. It follows, as Frege sees, that a negated generalized negation of Begriffsschrift is true just in case the corresponding function is a fact for at least one object as argument. The Begriffsschrift judgment lambda is correctly translated there are lambda s. What Frege does not seem at RST to have realized is that a particular affirmative, something of the form ρ mu, can itself be construed as an instance of a negated generalized negation. Only in the long Boole essay written shortly after Begriffsschrift is the link between particular and existential judgments emphasized. In 2 equals 4. 4 equals 16 we may insert two negation strokes in immediate succession, which then cancel each other out. 85. 2 equals 4. 4 equals 16 and think of this as concatenated as indicated here, 2 equals 4. 4 equals 16. Thus the only distinction between 2 equals 4 and 2 equals 4. 4 equals 16 is that 2 equals 4. 4 equals 16 takes the place of 2 equals 4. Just as 2 equals 4 is the judgment that there is at least one square root of 4, so 2 equals 4. 4 equals 16 is the judgment that there is at least one thing that is a fourth root of 16 and a square root of 4. It is the judgment that some fourth roots of 16 are square roots of 4. Nevertheless, Frege seems not yet to have realized that such sentences involve a second-level concept. Shortly after Begriffsschrift was written, Frege realized that in a genuine hypothetical one concept is subordinated to another. In the dialogue with Punjar, written sometime before 1884, Frege claims that a particular affirmative similarly puts concepts in a logical relation. Out of context the word some has no sense, it is an auxiliary like all, each, none and so on, which, in the context of a sentence has a logical function to perform. This function consists in putting two concepts in a certain logical relationship. Because only one concept would seem to be involved in a simple existence claim such as there are men, Frege now suggests that in such cases we should select a concept, for instance, being identical with itself, to enable the formulation of the sentence as a predicate. 86. Lar affirmative, there are men identical with themselves or something identical with itself is a man. The content of what is predicated, the existence expressed by there is, in such sentences, Frege thinks at this stage, is contained in the form of the particular judgment. Only in Grundlagen and subsequent writings are higher-level concepts, among them the concept of existence, explicitly acknowledged as such. In the 1893 logic Frege draws a more thoroughgoing distinction between judgments expressed using his Latin italic letters and judgments expressed instead using the concaviti notation. Although a judgment expressed using Latin italic letters expresses a subordination of concepts, that same judgment expressed using the concaviti and German letters has, he suggests, the form of a subsumption of RST-level concepts under a higher-level concept. That is, both phi and phi designate second-level concepts, and both psi and psi. Phi designate second-level equal-leveled relations, but neither psi nor psi. Phi designates anything. Latin italic letters cannot be used in the formation of concept words. Nor, for the same reason, can they be used in the formation of names for truth values. Whereas equals is a name, because it denotes the true, Roman letters, and combinations of signs in which they occur, are not names, because they only indicate though, as Frege notes in Grundgesetze 32, such a mark is transformed into a name of a truth value by the introduction of Gothic letters in place of Roman letters and by the prixing of concavities. If that is right, the two judgments 4 equals 1 and x4 equals 1. 2 equals 1 x2 equals 1 do not express one and the same thought, the latter is not merely an abbreviation of the former, as Frege had claimed in Begriffsschrift. Indeed. 87. They do not even have the same logical form. In the RST sentence a second-level concept is designated. The sentence has the logical form of a subsumption of a RST-level concept under a second-level concept. In the second sentence only RST-level concepts are designated. The logical form of this sentence is that of a subordination. By the early 1890s Frege seems to have come to think that his Latin italic letters and his concaviti with German letters play very different expressive roles. Nevertheless, in Grundgesetze 8 and 17 he also suggests that a generality using a Latin italic letter is merely a special case of a generality expressed using the concaviti notation, that the concavity notation is required only to mark distinctions of scope. That is, he both distinguishes logically between the two means of expressing generality and claims that they are not essentially, that is, logically, different. In remarks written after 1893, there is evidence that Frege did come to resolve this conflict in his thinking and to comprehend fully the peculiar logical role played by his concavity notation. As already indicated, Frege remarks in a note to the 1906 to Logic regarding the use of letters in arithmetic that here and there in arithmetic there is also a use of letters which roughly corresponds to that of the Gothic letters in my concept script. But I have found no indication that anyone is aware of this use as a special case. Probably most mathematicians, were they to read this, would have no idea of what I am alluding to. It was not until after some time that I became aware of it myself. As Frege points out in this passage, there is a use of letters in arithmetic that corresponds to the use of his German letters, but this is a special case. Even he himself did not recognize this use as a special case until quite late. Earlier, in the 1896 essay on Mr. Piano's conceptual notation and my own, Frege provides what seems to be an example of the use of letters in arithmetic that he has in mind. From the point of view of inference, generality which extends over the content of the entire sentence is vitally different significance from that whose scope constitutes only a part of the sentence. Hence it contributes substantially to perspicuity that the eye discerns these 88. Different roles in the different sorts of letters, Latin and German. There is a similar distinction in the way the letters alpha and x are used in the formula sin, alpha 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 x. 0. Infinity. Indefinite integral d. In which alpha really serves as a calculation sign. It is not merely incidental, I think, that Frege uses such an example here rather than something much simpler such as, say, xn times xm equals xn plus m. In a law such as xn times xm equals xn plus m, the letter x functions as a variable and the letters n and m as parameters. The equation holds no matter what numbers are put for n and m. But of course it also holds no matter what number is put for x. There is in such a law no essential difference between the two sorts of letters, the same sort of letter could be used throughout. Similarly, in a Begriffsschrift judgment such as x equals 16 4 equals x 2 equals 4, there is no essential difference between the two sorts of letters. The concavity is needed to mark the scope of the generality in the subcomponent, but no further purpose is served by the choice of a different sort of letter with the concavity. The same sort of letter could have been used throughout. It would seem to be just this sort of case that Frege has in mind when he suggests that the concavity notation functions merely to mark distinctions of scope. Frege's arithmetical example is crucially different. We can illustrate how it is different by using a somewhat simpler example, for instance, the law that dxn/dx equals nxn1, because in this law, the different letters do serve radically different purposes, as is immediately evident by consideration of instances of it, dx2/dx equals 2x, dx3/dx equals 3x2, and so on. In these various instances, d/dx takes RST-level arithmetical functions as arguments. In dxn/dx equals nxn1, by contrast, we have a general law about functions of a certain kind. Xn serves in this law indefinitely to indicate not numbers but functions. This is the crucial point, though in xn times xm equals xn plus m the letters x, n, and m all can be read as serving in the same way indefinitely to indicate numbers. In dxn/dx equals nxn1, x and n cannot be read as serving in the same way indefinitely to indicate numbers. Instead, the letter n serves to raise everything up a level, from consideration of derivatives of predicate. 89. Lar functions to a law about functions of a certain kind generally. Just the same is true of alpha and x in Frege's example. The arithmetical identity dxn/dx equals nxn1 expresses a general law about functions. In its expression the letters x and n play very different roles. Because they do, it contributes substantially to perspicuity that different sorts of letters are used in the two cases. Similarly, in Begriffsschrift on our reading of it, German and Latin italic letters play very different roles in the expression of general laws about concepts. As dxn/dx equals nxn1 expresses a general law about functions, so, for instance, f, h, f, g, h expresses a general law about concepts. In this law the Latin italic letters f, g, and h serve to raise everything up a level. The concavity with German letters is used in the formation of a second-level concept word, and the Latin italic letters f, g, and h enable one to exhibit something about the concept so designated, namely, its transitivity. It is just these logically different roles, apparent only at the level of laws that hold for concepts generally, that are marked by Frege's use of two different sorts of letters, German with the concavity and Latin italic without it. Frege's use of two different sorts of letters in the two cases is, then, logically justified, but one can see why only by considering the most general case, the case of the laws of logic. According to the reading just outlined, Frege came fully to comprehend the logical role of the concavity notation, and thereby the logical distinction between sentences expressed using his two notations for generality, only decades after the notation itself was developed. A Begriffsschrift genuine hypothetical expressed using Latin italic letters has the form of a subordination of concepts, expressed using the concavity notation. The sentence instead has the logical form of a subsumption of RST-level concepts under a second-level concept. Frege explains just this distinction in the 1919 notes for Ludwig Darmstädter. We begin with the basic case, that of a genuine hypothetical requiring only Latin italic letters in its expression as it contrasts with a mere conditional. 1990. Where we have a compound sentence consisting of an antecedent and a consequent, there are two main cases to distinguish. The antecedent and consequent may each have a complete thought as its sense. A second case is where neither antecedent nor consequent has a sense in itself, but where nevertheless the whole compound does express a thought which is general in character. In such a case we have a relation, not between judgments or thoughts but between concepts, the relation, namely, of subordination. This is just what we have already seen. Latin italic letters together with the conditional stroke enable the expression of relations among concepts. After some claricatory remarks, Frege turns to those cases that require the use of the concavity notation. A general statement can be negated. In this way we arrive at what logicians call existential and particular judgments. The existential thoughts I have in mind here are such as are expressed in German by es gibt. In existential sentences of this kind we are making a statement about a concept. Here we have an instance of how a concept can be related to a second-level concept in a way analogous to that in which an object is related to a concept under which it falls. Closely akin to these existential thoughts are thoughts that are particular, indeed they may be included among them. But we can also say that what is expressed by a sentence of the particular form is that a concept stands in a certain second-level relation to a concept. The notion of a second-level concept makes an appearance in this passage only when the case of a negated generality is considered, that is, only where the concavity notation is ineliminable. Frege marks the distinction between exhibiting two concepts in the relation of subordination, on the one hand, and showing using the concavity and German letters that a RST-level concept falls under a second-level concept, on the other, by noting that in the one case, that in which Latin italic letters are used, we have a relation between concepts, the relation, namely, of subordination, and in the other, the case in which a concavity and German letters are employed, what is expressed, is that a concept stands in a certain second-level relation to another concept. The two cases, then, are essentially different. 8. A judgment whose content is an unnegated generality can be expressed using Latin italic letters. These letters enable the exhibition of 9191 concepts in the logical relationship of subordination. But a judgment whose content is a negated generality can only be expressed using the concavity notation. It does not express a logical relation among concepts at the same level, but instead, Frege suggests, the subsumption of a concept under another, higher level concept. Such a judgment, on our reading, can serve only as a premise in an inference. It does not express an inference license, a law according to which to reason. 9. The expressive role of the concavity, as we read it, is to enable the formation of higher level concept words that are needed in the expression of laws at the third level. The second level relations. Psi and psi. Phi are the basic cases. Because only the RST can be used in the formation of a law, that is, in the expression of what Frege calls a genuine hypothetical, we begin with it, the second level relation of subordination. Psi. Phi. If we now replace psi with the function psi, another, more complex relation is formed, psi. Phi. If it is further stipulated that psi equals phi, then this expression designates the relation of following in a sequence. It is correctly ascribed to a function f and a property f just if f follows in the f sequence. If psi in our original formula is replaced instead by the function psi, we get psi. Phi. 92. This is the second level relation that is ascribed, for instance, in Every Boy Loves Some Girl. Where psi equals phi, another important second level relation is designated. Psi, which holds, for instance, of the concept number and the successor relation. It is also, in a slightly more complex form, the relation that is ascribed in the density axiom of geometry. To judge that between any 2 points there is a third is to ascribe that second level relation to the concept's point, and still more logically complex second level relations are formulable as well. If, for instance, the expression in the formula just given is replaced by rho, the resultant concept is rho psi. It is this concept that is critical to limit operations. To form, for instance, the second level unequal leveled relation of continuity, which takes a function and a point as arguments, one puts the concept psi0 for the two occurrences of psi, the relation psi less than or equal to zeta less than or equal to psi4, and the relation psi less than or equal to f less than or equal to psi for rho. The result is a more determinate concept, but because it takes functions and points as arguments, it is one that is nonetheless second level. Obviously, one could go on. As we should furthermore expect, sentences that contain such expressions are analyzable in various ways. That Begriffsschrift sentences can be carved up in various ways for the purposes of judgment and inference has already been shown for the case of simple singular sentences, for the case of conditionals and genuine hypotheticals, and also for the case of generalized conditionals expressed as subsumptions using the concavity notation. We saw that a sentence such as, for instance, 93, 4 equals 16, 2 equals 4, can be read either as ascribing the second level property psi to the RST level concept psi 4 equals 16 psi 2 equals 4, or as ascribing the second level relation psi phi to the RST level concepts psi 2 equals 4 and psi 4 equals 16, or in yet other ways. A particular affirmative such as 4 equals 16, 2 equals 4, is essentially similar, though because of its greater logical complexity even more analyses are possible. Depending on how the horizontals are taken to be amalgamated, it can be read as follows. As 4 equals 16, 2 equals 4. It is the judgment that it is not the case that the concepts square root of 4 and not a fourth root of 16 are related by the relation of subordination. As 4 equals 16, 2 equals 4, it is the judgment that there is something that is both a square root of 4 and a fourth root of 16. As 4 equals 16, 2 equals 4. It reads as the judgment that the property fourth root of 16 has the property of some square root of 4. 94. As 4 equals 16, 2 equals 4, that same sentence ascribes the second level property of compossibility to the concepts square root of 4 and fourth root of 16. Just as Frege tells us already in Begriffsschrift 12, a particular affirmative of Begriffsschrift can be read either as of the form some S is P or as of the form it is possible for an S to be a P. Other analyses are clearly possible as well. Independent of an analysis into function and argument, this particular affirmative of Begriffsschrift does not say any one of these things to the exclusion of the others. Rather, it exhibits what Frege at RST calls the conceptual content, the Begrifflicher Inhalt, that is common to them all. In the case of second-level relations, the expression of which is more complex, even more analyses are possible. Already in the early logic, Frege employs two different sorts of letters with and without the concavity. Because he draws no distinction between RST and higher-level concepts, however, there is, in the early logic, no logical justification for using a different sort of letter with the concavity. The concavity, Frege thinks, serves only to mark distinctions of scope. For the case in which the concavity has widest scope, he introduces as a mere abbreviation the use of Latin italic letters without the concavity. It follows that genuine hypotheticals and particular affirmatives have essentially the same logical form, so, after Frege has seen that genuine hypotheticals present concepts in relations, he supposes that particular affirmatives do so as well, in spite of the fact that in simple existentials only one logically simple concept need be involved. The confusions are not fully cleared up until after the appearance in 1893 of the Grundgesetze logic. As Frege says, it was not until after some time that he became aware of the use of German letters as a special case. What exactly it was that he became aware of was that whereas a genuine hypothetical presents concepts in the relation of subordination, both a particular affirmative judgment and a simple existential judgment subsume a concept under a higher level concept. The logical justification for the use of German letters as they contrast with Latin italic letters lies in the role the concavity plays in the formation of concept words for just such higher level concepts. 95-95. 3.4 The formality of logic. We have traced the emergence of two related themes in Frege's mature understanding, that of a function as something in its own right that can serve as an argument for a higher level function, and that of a concavity with German letter as it is used in the formation of higher level concept expressions, where a higher level concept just is a function that takes lower level concepts as arguments to yield truth values as values. What we need now to see is that the subject matter of logic, on Frege's mature view, is a particular sort of higher level concept. In both his early and later writings, Frege takes the laws of logic to be somehow objective, that is, true or false, properly speaking, and together to form a body of knowledge the content of which is properly expressed in the form of a complete and adequate axiomatization. Nevertheless, his conception of the nature of those laws seems to have been radically revised between the early and the late logic. The developments, it will be suggested, occur in three stages. At RST, in Begriffsschrift, Frege seems to think of the laws of logic as merely more general than the laws of the special sciences, indeed, as maximally general but not in any relevant sense different in kind from other laws. 10 In the Longbuhl essay written shortly after Begriffsschrift, and also in Grundlagen, Frege adopts the notion of form as it contrasts with that of content to characterize the peculiarity of the laws of logic. The laws of logic, he now suggests, are fundamentally different from the laws of the special sciences because they are formal in a way those other laws are not. The third stage is reached with the idea, explicitly formulated only in 1906 in Foundations of Geometry 2, that the laws of logic are at once contentful, just as the laws of the special sciences are, and qualitatively different from those other laws. Frege's null word on the matter thus seems to combine elements of both his earlier views. In the preface to Begriffsschrift, Frege describes the laws of logic as the laws on which all knowledge rests, as the laws of thought, which transcend all particulars. Because, as we have already seen, he does not at this stage draw any sharp distinction between concept and object, or between RST and second-level concepts, it seems reasonable to take him to understand the peculiar character of laws of logic in terms of a kind of maximal generality. We know that any science abstracts to some extent from the particular state of things. In mechanics, for instance, 1 Ig. 9696 knows the chemical properties of objects, in topology one ignores the particular shapes of objects, and so on. The laws of a special science concern only certain properties of objects. Because in logic one ignores all properties of objects, the laws of logic could then be thought of as most general, maximally general, but not otherwise different from other laws. Frege's conceptual notation, on this conception, is one Leibnizian universal characteristic among many for instance, the symbol systems of arithmetic, geometry, and chemistry, and is distinguished from those other notations only by its greater centrality. Soon after the publication of Begriffsschrift, Frege seems to adopt instead something much more like the Boolean view of logic as distinctively formal. He begins to distinguish the formal part, which in verbal language comprises endings, praxis, suffixes and auxiliary words, from the material part proper. The signs of arithmetic, he now thinks, provide the material part, and his signs the formal part, the logical cement that will bind these building stones together. His logic is to be thought of as a formal symbol system in just the sense in which Boole's is a formal symbol system, though it is also true, as Frege points out, that because his signs for logical relations are not borrowed from arithmetic as Boole's are, his symbol system alone is suited to express a content. When we view the Boolean formula language as a whole, we discover that it is a clothing of abstract logic in the dress of algebraic symbols. It is not suited for the rendering of a content, and that is also not its purpose. But that is exactly my intention. I wish to blend together the few symbols which I introduce and the symbols already in mathematics to form a single formula language. In it, the existing symbols correspond to the word stems of language, while the symbols I add to them are comparable to the suffixes and form words form order that logically interrelate the contents embedded in the stems. For this purpose, I could not use the Boolean symbolism, for it is not feasible to have, for example, the plus sign occurring in the same formula part of the time in the logical sense and part of the time in the arithmetical sense. Solely in virtue of its choice of primitive signs, Frege's logical language is suitable for the expression of a content in a way in which Boole's is not. 9797. But if, as Frege now seems to think, the signs for logical relations provide only the formal part, the logical cement that is needed to form concepts out of concepts, then concept expressions and sentences formed solely out of such signs would seem to lack all content. The purely logical concepts and sentential contents expressed thereby would have the form of concepts and judgments, but they would not be concepts and judgments, properly speaking, for they would lack all content. Frege indicates that he would concur. He writes, for instance, that my concept script has a more far-reaching aim than Boolean logic, in that it strives to make it possible to present a content when combined with arithmetical and geometrical signs, implying thereby that independent of its combination with those arithmetical and geometrical signs, Frege's concept script cannot present a content. In some asides, the thought is even more explicit. Frege claims, for instance, that disregarding content, within the domain of pure logic his concept script commands a somewhat wider domain than Boole's formula language. Logic, he suggests, is a purely formal discipline, one that disregards content. Of the theorems proven in Part 3 of Begriffsschrift, theorems that are described in Begriffsschrift 23 as having a content derived from pure thought, he now claims, that my sentences have enough content, insofar as you can talk of the content of sentences of pure logic at all, follows from the fact that they were adequate for the task. This conception of logic as peculiarly formal, as itself devoid of content, remains to the fore in Grundlagen. Why should we think that the doctrine of relation concepts is, like that of simple concepts, a part of pure logic? Frege's answer in Grundlagen is that the doctrine of relation concepts belongs to pure logic because it concerns only the form of a relation, something any and all relations share insofar as they are relations. What is of concern in logic is not the special content of any particular relation, but only logical form. And whatever can be asserted of this is true analytically and known a priori. This is as true of relation concepts as of other concepts. Just as A falls under the concept F is the general form of a judgment content which deals with an object A, so we can take A stands in the relation phi to B. 98-98. As the general form of a judgment content which deals with an object A and an object B. Logic, Frege thinks at this stage, is not concerned with the special contents of particular concepts and relations but only with the logical forms of concepts and relations and with the logical forms of the judgment contents in which they occur. 11. Logic so conceived fundamentally contrasts with the special sciences. Whereas the special sciences have their own special contents in virtue of having their own particular concepts and relations, the science of logic has no special content of its own. Its concern is with logical form as it contrasts with content. If, as Frege now thinks, logic is distinctively formal, then judgments in logic ought to be not merely more general than judgments in other sciences but qualitatively different, and so they are according to the author of Grundlagen. The laws of number, are notorially applicable to external things, they are not laws of nature. They are, however, applicable to judgments holding good of things in the external world, they are laws of nature. They assert not connections between phenomena, but connections between judgments, and among judgments are included laws of nature. Laws of nature, Frege indicates, assert connections between phenomena, they assert, that is, not merely that this is the case and that is the case but that this is the case because that is the case. Similarly, the passage suggests, a law of logic asserts not merely that this law of nature holds and that law of nature holds but that this law of nature holds because that one holds. Of course a law of logic itself makes no reference to particular laws of nature, just as a law of nature makes no reference to particular matters of fact. Instead, much as a law of nature asserts connections between kinds of things, so a law of logic, on this view, asserts connections between kinds of judgments, that is, between judgments of this or that form. So understood, the Begriffsschrift judgment HFG. F. H. G. 9999. Which in Begriffsschrift seems to have been conceived as merely more general than a law of a special science, is now taken to concern judgments that have the form of generalized conditionals and to assert a connection among judgments of that form. Although in Grundlagen Frege takes logic to concern form rather than content, he is not a formalist, and he is careful to explain why. His own view, which, he thinks at this stage, is correctly described as a formal theory is, as he puts it in On Formal Theories of Arithmetic, that all arithmetical propositions can be derived from definitions alone using purely logical means, and consequently that they must be derived in this way. The formalism he rejects is characterized as the view that the signs of the numbers 1, 2, 1, 3, of the number pi, etc. are empty signs. Interestingly enough, however, his objection to this sort of formalism, at this stage in his thinking, is not so much that the view itself is wrong as that formalist definitions of numbers are logically odd. The formalists seek to define numbers by their properties, but the definitions they give are not definitions of objects at all. One says, for example, that square root 2 is something that, when multiplied by itself, yields 2. But so far, by means of such a definition one has merely obtained a concept, and there arises the question whether this concept is empty or fooled. As long as it has not been proved that there exists one and exactly one thing of this kind, it would be a mistake in logic to immediately use the denied article and say the number which when multiplied by itself yields 2, or the square root of 2, the concept of a number which when multiplied by itself yields 2 no more has the property of yielding 2 when multiplied by itself than the concept of a right-angled triangle is a triangle or has a right angle. The formalist, that is, fails to distinguish clearly between concepts and objects and between properties of concepts and characteristic marks of concepts. Because he fails to do so, his theory of fractional, negative, etc., numbers is untenable. The formalist offers as a definition what is only a guide toward definition. The formalist view is distanced from Frege's own, at this stage, by a technical difficulty. Frege claims in Grundlagen that the demand never to lose sight of the distinction between concept and object requires in turn that both existence and uniqueness be established if an object name is to be introduced. One must show not only that something does fall under the con. 100 sept used in the definition but also that no more than one object does. If we are to use the symbol A to signify an object, we must have a criterion for deciding in all cases whether B is the same as A, even if it is not always in our power to apply this criterion. Formalist theories do not meet this requirement and are therefore to be rejected. The further demand always to separate sharply the psychological from the logical, the subjective from the objective, seems intended to ensure that the results of Frege's investigations, though they do not concern anything that is actual, are nonetheless objectively valid. On this view of numbers, we are not concerned with objects which we come to know as something alien from without through the medium of the senses, but with objects given directly to our reason and, as its nearest kin, utterly transparent to it. And yet, or rather for that very reason, these objects are not subjective fantasies. There is nothing more objective than the laws of arithmetic. Frege's thought is perhaps this. Logic, as Frege thinks of it in Grundlagen, concerns itself not with any particular content but instead with the logical form of thought itself. Because logic concerns the form of thought, its laws must be objective, that is, exactly the same for all rational beings. Although not in precisely the sense in which judgments in the special sciences are truths, judgments regarding the forms of thought can thus be said to be truths, even, in a sense, maximally objective. Nevertheless, there is a problem, and Frege knows it. If, as Frege seems at RST to have thought, logic were merely more general than the other sciences, then no special difficulty would attach to the idea that logic is, properly speaking, a science capable of extending our knowledge. But if logic is concerned only with form, as Frege begins to think after learning about Boole's logic around 1880, discoveries would seem to be impossible in logic. Logic, so conceived, could not be a science, properly speaking, at all. 12. The thesis of logicism compounds the difficulty. If logic is formal and arithmetic merely derived logic, then how do the empty forms of logic disgorge so rich a content? The author of Grundlagen, himself. 101. A formalist about logic, needs an answer. In Grundlagen, though in no earlier or later writings, Frege offers an argument to show that even analytic judgments, grounded in logic alone, can be ampliative, that is, extensions of knowledge, properly speaking. The argument, which derives from considerations RST set out in the long Boole essay, aims to put an end to the widespread contempt for analytic judgments and to the legend of the sterility of pure logic. Both Boole's logical algebra and Frege's concept script are designed perspicuously to represent logical relations by means of written signs, thereby providing the logical cement required in the formation of new concepts out of old. But, as Frege points out in the long Boole essay, the logical relations represented in Boole's algebra enable only the simplest sort of concept formation by means of logical multiplication and addition. In Frege's imagery, concept formation in Boole's logic uses the boundary lines of concepts we already have to form the boundaries of new ones. The much more powerful expressive resources of Frege's logic, in particular, those that involve the concavity notation, enable the formation of radically new concepts, concepts such as that of the continuity of a function at a point that do not merely trace over old boundary lines. This difference, Frege suggests in the Boole essay, explains the legend of the sterility of pure logic. It is the fact that attention is principally given to the sort of formation of new concepts from old ones, while other more fruitful ones are neglected, which is surely responsible for the impression one easily gets in logic that for all our toing and froing we never really leave the same spot. The account will not do as it stands, however. If arithmetic is merely derived logic, then all its concepts are definable in purely logical terms, that is, in terms that provide only the logical cement and not the material part. It follows, as already noted, that the concepts of arithmetic are not really concepts at all but only forms. What needs to be explained, then, is not the fruitfulness of logic relative to a content already given, but how it is that the empty forms of logic can disgorge so rich a content. 13 Frege's Grundlagen answer is well known: fruitful definitions enable fruitful proofs, that is, proofs of theorems that are not merely explicative in Kant's sense. Frege's proofs in Part 3 of Begriffsschrift, for example, involve definitions in strictly logical terms that enable derivations of theorems which at first glance seem to be possible only on the grounds of some intuition. In those 102 theorems the predicate is not contained in the concept of the subject, as required by Kant's conception of analyticity, and yet, as Frege shows, the predicate in the theorem proved can be shown, by logic alone, to attach to the concept of the subject. As the point is put in Grundlagen, such theorems are contained in the definitions, but as plants are contained in their seeds, not as beams are contained in a house. The theorems proven are analytic, grounded in logic alone, but also ampliative in Kant's sense because the judgment is not proven solely on the basis of an analysis of the concept of the subject. They are, then, extensions of our knowledge, properly speaking, or so the author of Grundlagen argues. After 1885 we hear no more about logical form as it contrasts with content. Kant's analytic/synthetic distinction is no longer invoked to demarcate the province of logic, and no further mention is made of fruitful definitions. After 1891 Frege does appeal to the distinction between the Sinn and the Bedeutung of an expression to explain how judgments of identity can constitute valuable extensions of our knowledge, but he nowhere appeals to that same distinction to explain how proofs can do so as well. The problem of the apparent sterility of logic vanishes without a trace, and the reason it does is that Frege's talk of form comes to be replaced after 1891 with talk of higher-level concepts and relations. Logic, Frege comes again to think, has its own content. It is, in this respect, like any other science, and as in any other science, discoveries are possible in logic. What is distinctive about the science of logic is that its content is higher order. We read, for instance, in Function and Concept that if we use the functional letter f as an indefinite indication of a concept, then f gives us the form that includes the last examples. The expressions 2 equals 1, greater than or equal to 0, 0, 2 3 2 plus 2 equals 0. Arise from this form in a manner analogous to that in which x2 gives rise to 1 2, 2 2, 3 2. Now just as in x2 we have a function whose argument is indicated by x, I also conceive of f 103 as the expression of a function whose argument is indicated by f. Such a function is obviously a fundamentally different one from those we have dealt with so far, for only a function can occur as its argument. The form that is common to existential judgments, Frege now claims, is to be understood in terms of a higher-level function, one that takes functions as arguments. Similarly, whereas in Grundlagen Frege takes logic to concern the general form of a thought content, for instance, the form of falls under the concept f, in Grundgesetze he thinks of this form in terms of an unequal-leveled function of two arguments, namely the function phi, where psi occupies and renders recognizable the place of the object argument and phi that of the function argument. This function is the relation of an object to a concept under which it falls. It is the relation of subsumption. The concern of logic is not form, as Frege, following Boole, had thought, but instead higher-level concepts such as that of existence and higher-level relations such as that of subsumption. In Begriffsschrift Frege takes judgments in the science of logic, which in Grundlagen he describes as empty forms, to be properly contentful. Axioms and theorems of logic on that early view are not empty forms into which content might be injected any more than air is merely an empty space into which objects can be put. Laws of logic, the author of Begriffsschrift seems to think, are merely more general than other laws. By 1884 Frege had come to think that the laws of logic are qualitatively different from other laws, they are not laws of nature but instead laws of the laws of nature. But because, at this second stage in Frege's thinking, this qualitative difference between the two sorts of laws is conceived in terms of the difference between form and content, Frege loses sight of the contentfulness of the laws of logic. Frege's mature conception of the formality of logic affects a synthesis. As Frege understands them after 1891, the laws of logic are at once fully contentful and also qualitatively different from the laws of the special sciences. As Frege puts the point in Foundations of Geometry 2, logic is formal if by that we mean that as far as logic itself is concerned, each object is as good as any other, and each concept of the RST level as good as any other and can be replaced by it. But even logic is not unrestrictedly formal. If it were, then it would be without content. Just as the con. 104 Sept point belongs to geometry, so logic, too, has its own concepts and relations, and it is only in virtue of this that it can have a content. Toward what is thus proper to it, its relation is not at all formal. To logic, for example, there belong the following: negation, identity, subsumption, subordination of concepts. And here logic brooks no replacement. Like any science, Frege now suggests, logic has its own concepts and relations and its own laws regarding those concepts and relations. What is distinctive about it is that its concepts and relations, by contrast with those of the special sciences, are second level. They are concepts and relations under which fall the concepts and relations of the special sciences. Even formal rules of inference, then, are not formal in any sense that would contrast inferences governed by them with those inferences that are good in virtue of the meanings of the concepts involved. What distinguishes the laws that govern formally valid inferences from those that belong to the special sciences, which govern instead inferences that are materially valid, is that they concern concepts that are one and all higher order. But, it will perhaps be objected, the concepts and relations of Frege's logic are not one and all higher order. Identity, for instance, takes objects as arguments. It is not a higher order relation. Nor are the conditional and horizontal strokes higher order, for they take truth values, among other objects, as arguments. The objection is based on a confusion the nature of which can be illustrated by appeal to the formula language of arithmetic. Suppose one said that the laws of higher analysis concern not numbers or arithmetical functions but instead kinds of arithmetical functions, that is, second-level functions f, which takes functions as arguments, and it was then objected that among the signs of higher analysis are, for instance, plus and, which take numbers as arguments. The right response would be to point out that in a law of higher analysis the sign plus does not serve any function on its own, as, for instance, it might be thought to in 2 plus 3. Instead, it functions, together with the other signs and indicating letters, in the formation of expressions that designate higher-level functions. The fact that primitive signs of Begriffsschrift occur in the laws of logic, signs that in other contexts can be understood as taking objects as arguments, similarly does not show that Frege is wrong to say that the concern of logic is higher-order concepts and relations. In calculus the primitive signs of arithmetic, signs that in other contexts can be read as taking numbers as arguments, are used to form expressions for higher-order functions, and in logic, the primitive signs of Begriffsschrift that in other contexts can be 105 read as taking objects as arguments are used similarly to form expressions that designate higher-level concepts and relations. Already in Grundlagen Frege indicates that the sign for identity can be dispensed with. Following Leibniz, he adopts as his definition of identity the principle of the substitutivity salva veritate of identicals, things are the same as each other, of which one can be substituted for the other without loss of truth. 14 To say that A equals B, then, is to say that the second-level properties phi and phi have a certain third-level property, namely, the property beta. On the reading adopted here, The concept of identity is properly thought of as a logical concept for just this reason. So, we can say, laws of logic are distinctive insofar as only indicating letters occur to the right of rightmost horizontals in the laws of logic. That by itself does not show that the concepts and relations of logic are one and all higher order, however. The conditional stroke seems to be a distinctively logical sign. Nevertheless, what it designates is a RST level relation. Is it, then, somehow exempt from Frege's rule that in logic each concept of the RST level is good as any other and can be replaced by it? The answer is no, because, contrary to appearances, this sign will not occur in isolation in actual applications of any law of logic but only as a constituent of a higher level concept. Consider, for instance, the RST law of Begriffsschrift, ABA. This law exhibits something that is the case no matter what truth values are taken as arguments. So, it would seem, the indicating letters here LL the argument places of the RST level relation. Psi zeta psi. That is not, however, the best way to conceptualize this law in applications of it. We know that any Begriffsschrift sentence can be given a function/argument analysis, that is, it can be conceived as involving an ascription of a concept. Because it can, we can construe this RST law of Begriffsschrift as an ascription of a third-level property to a second-level relation, say phi, psi, phi. On this reading, it is such a second-level relation, not the RST-level relation previously considered, that is the argument for the law. What the law says, so analyzed, is that this second-level relation holds of any two concepts and two objects. Clearly, in the sign used to designate the second-level relation, the conditional stroke does not function as a RST-level relation but is instead a constituent of a sign designating a second-level relation. In this way, instead of construing the axiom as a truth function, we construe it as involving the ascription of a third-level concept to a second-level relation. Obviously we can do the same for any other axiom or theorem of Begriffsschrift that seems to involve the conditional stroke functioning as a RST-level relation sign. Among the primitive signs of Begriffsschrift are signs for RST-level concepts. Nevertheless, their role in logic, according to Frege's considered view, is to enable the formation of expressions that designate higher-level concepts and relations. In the 1879 Begriffsschrift, the RST logical symbol to be introduced after the content and judgment strokes is the sign for the conditional, followed by the negation stroke and the sign for identity. The last sign to be introduced is the concavity. In Begriffsschrift, that is, Frege follows the ordering of any standard textbook of logic. He begins with truth functions, that is, the propositional calculus, and then moves on to the predicate calculus. In Grundgesetze the order of presentation is very different. There the RST signs to be introduced are, again, the judgment stroke and the horizontal, but these are now followed by the negation stroke, the sign for identity, and the concavity. The last primitive sign to be introduced in Grundgesetze is the conditional stroke, and it is introduced, as we have already seen, in order to enable us to designate the subordination of a concept under a concept, and other important relations. As far as logic is concerned, the author of Grundgesetze suggests, the conditional stroke has no significance in isolation, no significance independent of the other logical signs that together with it enable the formation of higher-level concepts. The logical significance of the conditional stroke is 107. Revealed only in combination with Frege's signs that express generality of content, and the conditional stroke itself has a role in logic only in such combinations. Its role in logic is to enable the expression of higher-level relations such as subordination. 3.5 Mastering the instrument. Already in Chapter 2 an account was developed of the logical justification for Frege's two-dimensional notation and of the peculiar expressive function his Latin italic letters play in lending generality of content despite their having neither sense nor meaning. Begriffsschrift Latin italic letters, it was argued, preserve the expressive power of the two-dimensional conditional stroke by driving everything up a level. As Frege already saw shortly after the completion of Begriffsschrift, genuine hypotheticals of his logical language exhibit concepts in logical relations such as that of subordination. Only more than a decade later did he come fully to appreciate the role of the concavity with German letters in driving things up yet another level. The three developments in Frege's thinking that have been traced here: that concepts are something objective, something in their own right that can serve as arguments for higher level concepts, that the concavity notation serves in the formation of concept words for higher level concepts, and that the laws of logic concern just such higher level concepts are, on our reading, one and all aspects of this hard-won insight. Beginning with the thought that the fundamental idea of Begriffsschrift is to express laws governing modes of inference as formulae, we have been led to a conception of logic according to which its topic is the higher order concepts and relations under which the concepts and relations of the special sciences fall. The task of logic on this conception is to discover the laws that govern such concepts, that is, the laws of the special sciences, where sentences expressing such laws make essential use of the distinctive expressive capacities of Frege's concavity with German letters used in the formation of higher-level concept words and of Frege's Latin italic letters lending generality of content. These sentences, furthermore, exhibit the peculiar virtue of the simpler sentences already considered. They, like any other sentences of Begriffsschrift on our reading, are variously analyzable into function and argument for the purposes of judgment and inference. They are essentially two-dimensional. As Frege Nally 108 came explicitly to realize, his formula language was a radically different sort of language than he had at RST thought. As we will soon see, sentences of that language do not express contents of possible judgment, the circumstances that obtain if they are true, as Frege at RST thought. That notion of sentential content is to be split in the mature logic into the thought expressed, on the one hand, and the truth value designated, on the other. 109. 4. It will be seen that the years have not passed in vain since the appearance of my Begriffsschrift and Grundlagen, they have brought the work to maturity. But just that which I recognize as a vital advance stands, as I cannot conceal from myself, as a great obstacle in the way of the dissemination and the effectiveness of my book. I have moved farther away from the accepted conceptions. Grundgesetze, 1893. Frege's understanding of the logical language RST presented in Begriffsschrift in 1879 and then again in the RST volume of Grundgesetze in 1893 was radically revised in the intervening years. His conception of a concept, of the distinction between objects and concepts, of the laws of logic, and of the roles played by the various primitive signs of his logic all were fundamentally rethought in the 1880s. But though we have traced these developments, the guiding thread that underlies and connects them one to another has thus far figured only implicitly. We need to understand the vital advance that brought Frege's logic to maturity. We need an account of the Sinn/Bedeutung distinction. 4.1 The shape of Frege's discovery. Although we find it natural to construe Frege's introduction of the Sinn/Bedeutung distinction in the early 1890s as the discovery of an extra-logical theory of the cognitive aspect of language use, Frege himself takes the discovery of the distinction between Sinn and Bedeutung to be a properly logical advance. He indicates why in the opening sentences of his comments on sense and meaning. In an article I distinguished between sense and meaning in the RST instance only for the case of proper names. The same distinction can also be drawn for concept words. Now it is easy to become unclear about this by confounding the division into concepts and objects with 110. The distinction between sense and meaning so that we run together sense and concept on the one hand and meaning and object on the other. To every concept word or proper name, there corresponds as a rule a sense and a meaning, as I use these words. We tend to confound the distinction between sense and meaning with the distinction between concept and object, Frege suggests, and as a result confuse the notion of a concept with that of sense and the notion of an object with that of meaning. We think, that is, that only object names function referringly in language, that all cognitive content is predicative. Although he does not explicitly say so, Frege appears here to be diagnosing his own earlier mistake. If he is, then his discovery is not the discovery of a notion of sin to supplement a semantic notion of Bedeutung present already in the early logic. Nor even is it simply the discovery of the distinction between sin and Bedeutung. It is the discovery of a distinction between two different distinctions. Much as a traditional term logic connotes the logical distinction, drawn in a modern logic, between referring and predicative expressions, so, Frege seems to have come to think, the logical distinction between referring and predicative expressions, as he had understood it in the early logic, rests on a conation of two logical distinctions, that between object and concept with that between meaning and sense. As we will see, the relevant texts, early and late, support precisely this thought, that in the years between 1884 and 1893 Frege came fundamentally to reconceive the way a properly logical language functions as a language. According to Frege's early view, object names function in language as referring expressions, as representatives of objects. It follows that a sentence containing an object name that is not representative of any object cannot have any meaning. The sentence Leo Sask is a man is the expression of a thought only if Leo Sask designates something. It would also seem to follow on this view of the logical role of object names that identities are logically useless, that where J and K are representative of the same object, the identity J equals K is trivial in just the way J equals J is too. Frege resists the conclusion. Certainly it is true that if object names were merely representatives of objects, then, assuming that J and K are representatives of the same object and are functioning normally, the sentence J equals K would have the same judgeable content as the sentence J equals J. We know, however, that the former can require proof whereas the latter is trivial, merely an instance of the law of identity. The same content. 111 can be fully determined in different ways, but, that the same content, in a particular case, is actually given by two modes of determination is the content of a judgment. So, Frege concludes in the 1879 Begriffsschrift, symbols, usually only representatives of their contents, at once appear in propria persona as soon as they are combined by the symbol for identity of content, for this signifies the circumstance that the two names have the same content. The account is hopeless. In the RST place, it requires an ambiguity in the meanings of symbols, a bifurcation is necessarily introduced into the meaning of every symbol, the same symbols standing at times for their contents, at times for themselves, and this contravenes Frege's requirement, set out in one of Begriffsschrift, that symbols have a completely XED sense. But even if such systematic ambiguity were admitted, the proposed solution to the problem of the contentfulness of some identities would fail. Suppose that it is true that J equals K, that is, that J and K have the same content. It follows that Fj and Fk2 must have the same content because in this context the symbols J and K for their contents, not for themselves. But, we are told in 3, Frege's Begriffsschrift does not distinguish between propositions which have the same conceptual content. Indeed, it is clear that even if J equals K, nevertheless Fj and Fk do not have the same conceptual content, for not all consequences derivable from the one combined with certain other judgments can be derived from the other combined with those same judgments. Consider, for example, the premise if Fj, then Gm. Frege's Begriffsschrift solution to the problem of the logical significance of identities is no solution at all. Because the same object can be fully determined in different ways and it can be the content of a judgment that it is the same object that is designated in both cases, identities are necessary in logic. It would seem to follow that what matters to the correctness of an inference is something more n-grained than what matters to the correctness of judgment. We know that if J equals K, then Fj is true just in case Fk is true, that it is the same circumstance that obtains if Fj is true and if Fk is true. But, as Frege's reactions on identity indicate, the sentences Fj and Fk nevertheless seem not to have the same content in the sense of Begriffiger Inhalt. In the case in which the names are associated with different modes of determination, the judgment as to identity of content is, in Kant's sense, synthetic. Close as he comes, however, Frege does not, in Begriffsschrift, conclude that the Begriffiker Inhalt of a sentence containing an object name, its content as it matters to correct inference, is differ. 112. And from its truth conditions, the circumstance that obtains if the sentence is true. Frege's RST extended discussion of object names after 1890 is in On Sense and Meaning. The similarity between his early Begriffsschrift discussion of identity and this later discussion is remarkable. As in the earlier work, Frege rejects the idea that a sentence of the form A equals B can be understood to express a relation among objects because sentences of this form often contain very valuable extensions of our knowledge and cannot always be established a priori. He again rejects the idea that considered independently of the manner in which designates something, such a sentence expresses the thought that is wanted because in that case the sentence A equals B would no longer refer to the subject matter, but only to its mode of designation. We would express no proper knowledge by its means. As the point is put in Begriffsschrift, the case of interest to logic is not the case in which the different names for the same content are, merely an indifferent matter of form, but instead the case in which the different names are associated with different modes of determination. Frege does have a new example, however, one that differs from the earlier example in two important respects. In the Begriffsschrift example, Frege employs one name, A, that involves only a trivial mode of determination, and another, B, that is a variable name because what it designates is a function of the position of the line in the example. In Frege's example in On Sense and Meaning, both object names, the point of intersection of A and B and the point of intersection of B and C, clearly contain a mode of presentation, and neither is a variable name. The statement contains actual knowledge, so, Frege immediately concludes, it is natural, now, to think of their being connected with a sign, besides that which the sign designates, which may be called the meaning of the sign, also what I should like to call the sense of the sign, wherein the mode of presentation is contained. An object name is not merely representative of an object, Frege now claims, rather, it expresses a sense and designates a meaning. Appealing to essentially the same considerations as are rehearsed in Begriffsschrift, Frege now draws a very different conclusion, remarking only that it is natural to do so. Although Frege at RST thinks that object names function logically as representatives of objects, already in the 1879 logic he raises a difficulty for 113. That conception. In identities, which are necessary in logic, object names do not seem to function logically as representatives of objects. Frege's early view of the logical role of concept words faces a correlative difficulty, though it is not explicitly recognized. Frege thinks that concept words function predicatively, that is, that their role in language is to characterize objects independently given. But, as he also sees, a genuine hypothetical expresses a relation among concepts. The problem, quite simply, is that if concept words function merely predicatively, then there can be no relations among concepts that are not mediated by the objects they characterize. Object names, we have already seen, are understood in the early logic merely as representatives of objects. They represent objects, but not as anything. Concept words, correspondingly, do not function as representatives of objects. They are not general or common names of objects but are essentially predicative. The role of a concept word, on Frege's early view, is to characterize an object otherwise given. It provides a way of thinking about an object and has no independent existence. As Frege himself puts the point in a letter, apparently to Anton Marti, dated August 29, 1882, a concept is unsaturated in that it requires something to fall under it, hence it cannot exist on its own. That an individual falls under it is a judgeable content, and here the concept appears as a predicate, and is always predicative. A concept, Frege seems at RST to think, cannot exist on its own any more than a particular instance of a property such as redness can, and for much the same reason. 3. If, as Frege seems at RST to have thought, a sentence constitutively involves two fundamentally different sorts of expressions playing essentially different logical roles, the one to give an object or objects and the other to present those objects as thus and so, then in the case in which no object is given, no thought can be expressed. There can be no characterizing, no presentation of things as thus and so, if nothing is given to be so characterized or so presented. There cannot, then, be a sentence that is about concepts in just the way in which a singular sentence is about objects. But how, then, are we to understand the subordination of concepts in general sentences? A general sentence contains no object names and seems not to be about objects but instead about concepts. Nevertheless, if a concept cannot exist on its own, if it is always predicative, then even a general sentence, if it is to have any content, must in some way be about objects. In Begriffsschrift Frege suggests 114 exactly that. The difference between a singular sentence and a general sentence, as it is explained in the 1879 logic, is the difference between a sentence with a determinate content and one with an indeterminate content. The basic case is that of a singular sentence of something as something. Such a sentence is nonetheless variously analyzable into function and argument and, independent of an analysis, merely presents a combination of ideas. For to obtain a general sentence, one RST gives an analysis, that is, one imagines the sentence divided up into a constant part and a variable part. The variable part, the argument name, is then replaced by a letter which one can take to signify various things. The argument becomes indeterminate, as in the judgment, whatever arbitrary positive integer we take as argument for being representable as the sum of four squares, the proposition is always true. Instead of a singular sentence characterizing a determinate object as thus and so, we now have a general sentence involving indeterminate reference, and here the distinction between function and argument acquires a substantive inhaltliche significance. What a general sentence expresses is the thought that the relevant predicative expression is correctly applied not merely to this object or that object but to any object. A general sentence that expresses the subordination of one concept to another is thus not to be conceived as about concepts in the way a singular sentence is about objects. It is instead to be distinguished from a singular sentence as the indeterminate is distinguished from the determinate. A singular sentence is determinately about objects, a general sentence is indeterminately about objects, or so Frege suggests in Begriffsschrift. But, as Frege also sees, the validity of some inferences is explicable only if concepts too can serve as arguments. In order to express an indeterminate function of the argument A, we put A in parentheses following a letter, for example, phi. Similarly, psi 115 represents a function of the two arguments A and B. We can read phi as A has the property phi. Psi can be translated by B stands in the psi relation to A. Since the symbol phi occurs at a place in the expression phi, and since we can think of it as replaceable by other symbols psi, chi, which then express other functions of the argument A, we can consider phi as a function of the argument phi. Although phi in phi functions predicatively, it can nonetheless be thought of as replaceable and hence as the argument in a function/argument analysis. The point is reinforced by Frege's remark, in his discussion of generality in 11, that since a letter which is used as a function symbol, like phi in phi, can itself be considered as the argument of a function, it can be replaced by a German letter in the manner just specified. It can, that is, be replaced by a German letter and a concavity containing the letter inserted into the content stroke. In that case, as Frege puts it in 9, which provides the RST discussion of the notion of a function, the argument is determinate, but the function is indeterminate. This, however, is incoherent by Frege's own lights, because an argument is by definition that which is indeterminate and a function that which is determinate. The source of the difficulty is manifest. In Begriffsschrift, Frege thinks of an argument both as the symbol which is regarded as replaceable by others and as that which denotes the object which stands in these relations. An argument is that which is indeterminate in a function/argument analysis, and a function is that which is determinate, held invariant, in such an analysis. Clearly, then, the function is always predicative or unsaturated. But as Frege himself notes, contrary to his official account of an argument, the argument need not in every case be saturated, that is, an object. It can be a concept. But how can a concept provide the argument for a function if a concept is always predicative and cannot exist on its own? Given 116. Frege's early conception of concepts, and thereby of Rst-order generalities as indeterminately about objects, Frege can achieve no satisfactory account of higher-order generalities, generalities in which the function is indeterminate. In a letter to Husserl dated May 24, 1891, Frege sets out a schema to clarify his mature view. Proposition, proper name, concept, word, downward arrow, sense of the proposition. Sense of the proper name. Sense of the concept word. Downward arrow, meaning of the proposition. Meaning of the proper name. Meaning of the concept word. Rightward arrow, object falling under the concept. With a concept word it takes one more step to reach the object than with a proper name, and the last step may be missing, i.e., the concept may be empty without the concept word ceasing to be scientifically useful. I have drawn the last step from concept to object horizontally in order to indicate that it takes place on the same level, that objects and concepts have the same objectivity. Husserl's view of concepts, Frege suggests, would be given by the schema. Concept word, downward arrow, sense of the concept word, downward arrow, object falling under the concept. Husserl has no conception of the Bedeutung of a concept word. Nor is it only Husserl who lacks this conception. Both intentional and extensional logicians do so as well, Frege thinks. Indeed, he suggests in his comments on sense and meaning that we can understand familiar debates between intentionalist and extensionalist logicians by reference to just this lack. Both have achieved an insight, but lacking the notion of the Bedeutung of a concept word, they oscillate between two equally unacceptable positions. The intentionalist takes the sense to be the meaning of a 117 concept word, and the extensionalist takes instead the extension, the objects that fall under it, to be the meaning. The intentionalist logicians are only too happy not to go beyond the sense, for what they call the intention, if it is not an idea, is nothing other than the sense. They forget that logic is not concerned with how thoughts, regardless of truth value, follow from thoughts, that the step from thought to truth value more generally, the step from sense to meaning has to be taken. They forget that the laws of logic are RST and foremost laws in the realm of meanings and only relate indirectly to sense. The extensionalist, then, is right to reject the sense as the meaning of a concept word. But the extensionalist is wrong to think that it is instead the extension that is the meaning. We concede to the intentionalist logicians that it is the concept as opposed to the extension that is the fundamental thing. But again, the concept is not, pace the intentionalist logician, the sense. What both the intentionalist logician and the extensionalist logician fail to see is that the meaning of a concept word is neither the sense expressed nor the objects to which the concept word is correctly applied. It is a concept, that is, a law of correlation, objects to truth values. Whereas in the case of an object name the mistake is to think that the name only designates an object, that it does not also express a sense. In the case of a concept word the mistake is to think that the word only expresses a sense, that it does not also designate something or, if it does, that it designates a class or collection of objects. As Dumet says, whereas task, with proper names, was to argue that they have sin, in the case of predicates the whole interest lies in their having Bedeutung. 5. According to Frege's early conception of the way a properly logical language functions, the logical role played by object names is essentially different from that played by concept words. Object names serve a referring function, they give objects as that about which a judgment is made. Concept words, by contrast, are essentially predicative. A concept provides a way of regarding an object, a way of taking it to be. A whole sentence, then, can be thought of as a kind of picture of something as something. It is a kind of picture of a state of affairs, a picture of the circumstance that obtains if the sentence is true. It is just this 118 Conception of the functioning of language that is superseded in the mature logic. In the mature logic both sorts of expressions function in the same way, both sorts of expressions designate something in much the way object names were originally thought to refer to something, and both involve a kind of characterization, a way of thinking about that which is designated. The sense of an expression presents the entity meant, whether it be an object or a concept, under an aspect, as conceived in a particular way. Frege's early conception of the distinction between referring expressions and predicative expressions, which grounds his early conception of a content of possible judgment as a state of affairs, the circumstance that obtains if the sentence is true, connates the logical notion of Bedeutung, that which is designated, with the notion of an object, and the logical notion of Sinn, that which is expressed, with the notion of a concept. His early conception of a content of possible judgment is to be split in the mature logic into the thought expressed, on the one hand, and the truth value designated, on the other. 4.2 The formula language of arithmetic. Frege says in his comments on sense and meaning that it is easy to run together sense and concept on the one hand and meaning and object on the other. Frege himself, we have suggested, does just that in the early logic. He thinks that object names serve only to refer to objects and concept words only to characterize objects as thus and so, and as a result, he thinks of the content of a sentence in terms of its truth conditions, the circumstance that obtains if the sentence is true. On his mature conception of the way object names and concept words function in a properly logical language, the notion of meaning, Bedeutung, is not confused with that of an object. Just as object names do, concept words have meaning, not, as on a traditional conception, in virtue of their being general or common names for objects, but in virtue of serving to designate concepts, which are unsaturated or incomplete but nevertheless fully objective. A concept, on Frege's mature view, is something in its own right that can serve as an argument for a function. Correlatively, in the mature logic, the notion of sense, Sinn, is not confused with that of a concept. Just as concept words do, object names express senses, not, as Russell thought, in virtue of their 119 being disguised descriptions, but by presenting an object under a mode of determination. According to Frege's mature understanding, both object names and concept words function in language both to designate something and to express something. 6. The fundamental logical difference between them is to be understood not in terms of a difference in how they function but instead in terms of a difference in what is expressed and thereby designated in the two cases, something saturated or complete in the case of object names and something unsaturated or incomplete in the case of concept words. Frege's formula language functions as a language in a way that is radically different from that he had at RST thought. As he does, we can further clarify this conception of how a properly logical language functions, and in particular the notion of Sinn, by reacting on how, according to Frege, the formula language of arithmetic functions. As Frege understands it, a true conceptual notation is at once a lingua characterica and a calculus ratiocinator, that is, it at once expresses a content in a way which tests the things themselves and is completely rigorous in the sense that there is an algorithm, i.e. a totality of rules which govern the transition from one sentence or from two sentences to a new one in such a way that nothing happens except in conformity with those rules. At least up to a point, Frege thinks, the formula language of arithmetic is such a language. for it directly expresses the facts without the intervention of speech, and in calculations the deduction is stereotyped serieinformig, being almost always based upon identical transformations of identical numbers yielding identical results. In the formula language of arithmetic, one can operate the GERS mechanically because the mathematical notation has, as a result of genuine thought, been so developed that it does the thinking for us, so to speak. Because it is not a matter simply of assigning names, but of symbolizing in its own right the numerical element, the direct isomorphism between the numerical element represented and the representation of it ensures that the mere manipulation of symbols according to rules preserves truth. But what is the numerical element symbolized in the formula language of arithmetic? In Grundlagen, Frege provides an answer. In the early logic, we have seen, Frege understands identities as expressions not of complete equality but of sameness in a respect. As two objects can be the same in color or length, so two names can be the same in con. 120 tent, in that of which they are representative. An identity of the form A equals B, where two different modes of determination correspond to the two names, signifies the circumstance that the two names are in this way in partial agreement. By the time he had nished Grundlagen, Frege had come to think that this view is mistaken, that it is instead the Leibnizian conception of identity as complete equality that is the right conception. Two things are identical just if the one can be substituted for the other salva veritate. Nor was this an isolated insight. Frege's realization that the equal sign in arithmetic expresses complete equality, that is, identity, was at the same time a realization about all the signs of arithmetic. The thought that numbers are collections of objects, that the plus sign means putting together, and that the equal sign signifies agreement in a respect are, he came to see, fundamentally related one to another and also completely mistaken. The conception of number as a series of things of the same kind, as a group, heap, etc. is very closely connected with the view which takes the sign of equality to designate partial agreement only, and with the view of the plus sign as synonymous with end. But these views collapse at the RST serious attempt to use them as a foundation for arithmetic. If we make such an attempt, we are always obliged to smuggle in something which is in conflict with these views. Even Frege himself may have at RST seriously attempted to use these views as a foundation for arithmetic. By the time Grundlagen was completed, they had collapsed. The formula language of arithmetic functions in a way that is very different from that one might naturally assume. As presented in Grundlagen, the problem is to give an account of statements of identity in arithmetic, statements such as, for instance, that 1 plus 1 plus 1 equals 3, and the view to be rejected is one according to which the tokenings of the numeral 1 in 1 plus 1 plus 1 equals 3 designate units which are put together to form a collection that is then identified with the collection designated by 3. The question whether the units so combined are identical or different reveals the in this conception of number. We suppose, to begin with, that a number is a collection of units. Were it such a collection, the units collected would have to be either the same or different. Assume, RST, that the units are different, as it would seem they must be if a plurality is to be reached. Then, as Jevons argues, a sum such as 1 plus 1 plus 1 is more perspicuously represented as 1 plus 1 plus 1, thereby making manifest our otherwise tacit understanding. 121. That each of these units is distinct from each other. Subtracting one from such a collection would be a matter of literally taking away, and taking away different units would leave different collections, different twos. There would be not only distinct ones but also distinct twos and so on. As a result, one would be left with a chaos of numbers. There would be not a single number which was the RST prime number after 5, but innately many, 7, 8, 1, 2, etc. We should not speak of the sum of 7 and 5 with the denite article but of a sum or all sums, some sums, etc., and hence we should not say the sum of 7 and 5 is divisible by 3 but all sums of 7 and 5 are divisible by 3. If the units were different, we would be left with a chaos of numbers. Indeed, If the units were different, no numbers would be reached at all because any collection of distinct units can be assigned different numbers depending on the way in which we have chosen to regard it. Regarding each stroke in a collection of, say, 9 strokes as a unit to be counted, we assign to the collection the number 9. We can, however, as easily regard each triplet as the unit relative to which to count, and in that case the number assigned is not 9 but 3. In conceiving the number 9 as a collection of units representable as a series of strokes, we put together different things, different units, or strokes. The result is an agglomeration in which the objects contained remain still in possession of precisely those properties which serve to distinguish them from one another, and that is not number. Well then, the units must be identical. But if they were identical, then 1 plus 1 plus 1 would be the same as 1, just as gold and gold is never anything else but gold. Were the units to be combined identical, they would collapse into one another, we could not get beyond the single unit. Again, the notion of number eludes us. If we try to produce the number by putting together distinct objects, the result is an agglomeration in which the objects contained remain still in possession of precisely those properties which serve to distinguish them from one another, and that is not number. But if we try to do it in the other way, by putting together identicals, the result runs perpetually together into one and we never reach a plurality. The units put together in a sum must be identical, and yet they cannot be. There is only one number 1, and yet 1 plus 1 plus 1 equals 3. Number, Frege. 122. Concludes, cannot be a collection of units, plus cannot mean the same as and, equals does not signify identity in a respect. It is nonsense to make numbers result from the putting together of ones. Frege's investigations reveal that the notion of a unit involves a confusion of two different notions, that of a concept relative to which the items in a collection are identical one with another and are to be numbered, and that of the particular objects that fall under that concept. For example, in the proposition Jupiter has 4 moons, the unit is moon of Jupiter. Under this concept falls moon I, and likewise also moon 2, and moon 3 2, and nally moon 4. Thus we can say, the unit to which I relates is identical with the unit to which 2 relates, and so on. This gives us our identity. But when we assert the distinguishability of units, we mean that the things numbered are distinguishable. A statement of number, we are now to see, assigns a number to a concept. If I say the king's carriage is drawn by 4 horses, then I assign the number 4 to the concept horse that draws the king's carriage. The logical form of the sentence, Frege argues in Grundlagen 57, is that of an identity. A statement of number has the form the number of f equals n, where f is the concept to which the number is assigned and n is the number of objects that fall under f, the number assigned to f. What we had taken to be the number itself, namely, a collection, is only that which is counted. The notion of a collection in terms of which we had tried to understand the notion of number is split in this way into the more n-grained notion of the concept relative to which things are counted, on the one hand, and the less n-grained notion of the number assigned to that concept, on the other. 7. Of course there are collections of objects. What Frege has shown is that what is needed to understand a statement of number regarding a collection is not reference to the collection itself but instead reference to the relevant concept and to the number assigned to that concept in light of the objects that fall under it. Although Frege shows that the conception of number as a collection of units is fundamentally misguided, it is nonetheless one that can seem very natural. It is very easy to think of the numerical element in terms of the idea of relative magnitude. Were that conception correct, the Roman numeration system would be a perspicuous language of arithmetic, a Leibnizian lingua characterica of number, because expressions in that language directly exhibit relations of relative magnitude. 2 is twice as many as 1, so, supposing we depict 1 as I, we should express 2 as 2. 3 is 3 times as many as 1 and 1 more than 2, so it is 123. Symbolized 3. For convenience, abbreviations are introduced, v.e., for instance, as v to abbreviate I. Then we can express 4 as 4 on the grounds that 4 is 1 less than ve, and 6 as 6 because it is ve and 1 more 8. In such a numeration system, bigger numbers are represented by symbols that are bigger, and bigger by as much as the numbers themselves are bigger. 3 as represented in a Roman numeral is literally and manifestly 2 and 1, one can see in the symbols themselves that 2 and 1 make 3. The Roman numeration system is in this way a lingua characterica of the numbers conceived as collections of units. If, furthermore, the Roman numeration system were a perspicuous notation of arithmetic, a lingua characterica, then the Arabic numeration system would be a remarkably unperspicuous symbol system of arithmetic. It would be unperspicuous precisely because the symbols, 1, 2, 3, and so on, do not themselves exhibit relative magnitudes. It is inscribed in the symbols themselves that 3 is greater than 2, and by how much, it is not inscribed in the symbols themselves that 3 is greater than 2. To know which of these two Arabic signs represents the larger number requires knowing what they mean. The number 222 is smaller than the number 999, but the numeral 222 does not look any smaller than the numeral 999. From the perspective according to which Roman numerals perspicuously represent the numbers, the 10 digits of the Arabic notation are quite like the convenient abbreviations V, X, and so on that we nd already in the Roman system. Larger numbers, which in the Arabic system are given by the relative positions of digits in combinations of them, give the numbers through a kind of a code. Knowing the code is being able to get back to the numbers themselves, perspicuously represented in Roman numerals, as needed. Were numbers collections of units, the Arabic system would be an unperspicuous notation of arithmetic because it does not map relative magnitudes. It would not be a lingua characterica of arithmetic. Nevertheless, that symbol system is enormously powerful. Because algorithms can be formulated in the Arabic numeration system for all the basic arithmetical operations, one can formalize arithmetic using Arabic numerals. Simply by manipulating Arabic symbols according to rules, anyone who knows this formula language can in principle perform calculations of any degree of complexity. It is as if, as Frege says, the mathematical notation does the thinking for us. This is, furthermore, all but impossible in the Roman numeration system. The results of calculations can be recorded in Roman numerals, but one cannot calculate in the 124 language. 9. Only the Arabic numeration system is a language within which to calculate, only that system is a calculus ratiocinator. Relative to the system of Roman numerals conceived as a Leibnizian lingua characterica of number, the Arabic numeration system would be, however, merely an abstract calculus. We would then have to ask what the relationship is between the rules that govern our calculations using Arabic numerals and the arithmetical truths proved thereby, what the relationship is between calculability in the Arabic notation and arithmetical truth perspicuously representable only in the Roman system, between, as it were, the proof theory of arithmetic and its semantic notion of truth. Fortunately, the question needs no answer because, as we have seen, a number is not a collection of units. The Roman numeration system is not a lingua characterica of arithmetic. There is only one 1, and yet 1 plus 1 plus 1 equals 3. How are we to understand this? Although it is not yet explicit in Grundlagen, Frege's way is in terms of the distinction between sense and meaning. The expressions that ank the identity sign designate the same number but differ in sense. As Frege puts the point in on the concept of number, after complaining that the problems he is discussing had already been essentially resolved in Grundlagen, there are various designations for any one number. It is the same number that is designated by 1 plus 1 and 2, it is inevitable that various signs should be used for the same thing, since there are different possible ways of arriving at it, and then we have to ascertain that it really is the same thing we have reached. 2 equals 1 plus 1 does not mean that the contents of 2 and 1 plus 1 agree in one respect, though they are otherwise different. Numerical signs, whether they are simple or built up by using arithmetical signs, are proper names of numbers. The plus sign does not mean the same as and. In the sentences 3 and 5 are odd, 3 and 5 are factors of 15 other than 1. We cannot substitute 2 and 6 or 8 for 3 and 5. On the other hand, 2 plus 6 or 8 are always substitutable for 3 plus 5. It is therefore incorrect to say 1 and 1 is 2 instead of the sum of 1 and 1 is 2. It is wrong to say number is just so many ones. Both in function and concept and in Grundgesetze, Frege develops these points using his technical notions of Sinn and Bedeutung. 2 4 equals 4 2 and 4 4 equals 4 2 express different thoughts, and yet we can replace 2 4 by 125 125. 4 4, since both signs have the same meaning. Consequently, 2 4 equals 4 2 and 4 4 equals 4 2 likewise have the same meaning. I call the number 4 the denotation of 4 and of 2 2, and I call the true the denotation of 3 2. However, I distinguish from the denotation of a name its sense. 2 2 and 2 plus 2 do not have the same sense, nor do 2 2 equals 4 and 2 plus 2 equals 4 have the same sense. The sense of a name of a truth value I call a thought. To the end of his life Frege was convinced that his conception of the Sinn and Bedeutung of an expression provides precisely what is needed to understand the formula language of arithmetic. 10. The sense of an expression, as Frege understands it, is what is grasped by a thinker who understands the expression. So, we should ask, what is it that one needs to know in order to grasp the sense of, say, 375 or 58 plus 62 or any other expression in the formula language of arithmetic? The answer seems obvious. One needs to know, RST, the rules that govern the formation of the numerals and of more complex expressions such as 7. One needs also to know that the number designated by 0 is assigned to concepts under which nothing falls, that the number 1 is assigned to concepts under which only one thing falls, and so on. Finally, one needs to know the algorithms of arithmetic, the algorithms of addition, subtraction, multiplication, and so on. To know all of this is to grasp the sense of expressions such as 375 and 58 plus 62. The rules and algorithms of the formula language of arithmetic in this way exhaustively X the content, the sense, or sin, of such signs. This content is, as we might think of it, the computational content of such expressions in the Arabic numeration system, with the proviso that computational content in this sense cannot be understood in abstraction from counting, that is, assignments of numbers to concepts. Computational content, as it is to be understood here, can no more be understood to involve only computations than, on Frege's view, inferential content can be understood to involve only inference as contrasted with judgment. Because inferences, on Frege's view, can be drawn only on the basis of premises that are acknowledged to be true, the notion of inference, and so of inferential content, begrifflicher Inhalt, cannot be understood independently of the notion of judgment, and the notion of computational content that is wanted here similarly cannot be understood independently of the notion of counting, that is, of judgments of the form the number of f equals n. 126 126. An expression such as 58 plus 62 of the formula language of arithmetic expresses its sense, its computational content. That is, it pictures, not relative magnitudes, but instead senses, and where the signs are different, as they are in, say, 80 plus 40, the sense, the computational content, is also different. This is the essential point. The Arabic numeration system is a lingua characterica, a notation that tells the things themselves, not in virtue of picturing relative magnitudes but in virtue of picturing computational content, the senses of expressions as they are xed by the three sorts of rules just mentioned that govern the employment, in counting and calculating, of the symbols they involve. It is for just this reason that computations can be fully rigorized in this notation, that one can compute in the Arabic numeration system by manipulating the symbols according to the rules and algorithms that X the senses of the symbols and of combinations of them. But, as already indicated, Arabic numerals such as 37 and 58 plus 62 do not express computational contents in abstraction from the numbers they designate. Such contents contain modes of presentation of numbers. The numerals that express such contents constitutively designate numbers. What does 58 plus 62 designate? It designates the sum of FTY8 and 62, and the rules that govern the use of the signs enable a canonical determination of what number that is. The positions of the 8 and the 2 determine that we need to write a 0 in the ones column and carry a 1 over to the tens, where the number it signs is added to the sum of VE and 6 to give 12, and so we write a 1 in the hundreds column and a 2 in the tens, and there is our answer, 120. Computing, guided by the computational content that is expressed in the notation of Arabic numerals, enables the advance from that content to a canonical representation of the number designated. The expression 58 plus 62 designates precisely the same number as that designated by 120, but it gives that number in a different way. That is, it gives it by way of a computational content that is different from that exhibited in 120. One can, furthermore, readily see that the computational contents are different, for the signs are different, they involve different primitive symbols in different arrangements and thereby exhibit distinct computational contents. The sentence 58 plus 62 equals 120 is, then, a recognition judgment, properly speaking, a judgment in which the same object is recognized as the same again although it is given in a different way. This is, moreover, a perfectly objective matter. The rules of arith. 127 Medic themselves fully determine the truth value of this identity. To say that it is a recognition judgment is not to say that anyone does recognize these numbers as the same. No one need have worked the problem out, and no one need ever do so. All the same, the identity is a recognition judgment because in it a number, that is, some one number, is given in two different ways. If it is the Arabic numeration system rather than the Roman that is a proper conceptual notation of arithmetic expressing in its own right the numerical element, then it is not counting, tallying the number of objects in a collection, that is the essence of number but instead computation, that is, calculations with numbers, where numbers are in turn constitutively applicable to concepts in counting. 11 Already in his Habilitationsschrift Frege suggests that no beginner will get a correct idea of an angle if the gur is merely placed before his eyes. If a beginner is shown how to add angles, then he knows what they are. Similarly, no beginner will get a correct idea of a number if a collection is merely placed before his eyes and counted. The beginner must be shown how to add numbers, then he knows what they are. Frege makes the point in Grundlagen 104, have we really no right to speak of 1000 until such time as that many objects have been given to us in intuition? Is it till then an empty symbol? Not at all. It has a perfectly definite sense, even although psychologically speaking and having regard to the shortness of human life, it is impossible for us ever to become conscious of that many objects. In spite of that, 1000 is still an object whose properties we can come to know, even though it is not intuitable. To convince ourselves of this, we have only to show, introducing the symbol n for the nth power of a, that for positive integral a and n this expression always refers to one and only one positive whole number. We do not need to produce a collection of 1000 objects in order to have a means of designating this number and discovering its properties. What is needed is only that we x the sense of this form of expression, that is, that we x the rules that govern its use in calculations. To understand that this is all that is required is to understand how it is possible for a mathematician to perform quite lengthy calculations without understanding by his symbols anything intuitable, or with which we can be sensibly acquainted. All we need to know is how to handle logically the content as made sensible in the symbols, and, if we wish to apply our calculus to physics, how to effect the transition to the phenomena. 128. An arithmetical expression such as 24 plus 23 expresses a sense, a computational content, and thereby designates an object, that is, a number. We can furthermore see in this example just how it is that the sense of the expression contains a mode of determination of the object designated. Rules govern both the calculations to be performed given such an expression and the correct application of the primitive object names involved in it. To grasp the sense of the expression is to know those rules, to be able to perform those calculations, and to apply those object names. By substituting identicals for identicals according to rules, one thus can arrive at a canonical name for the number designated. As should also be evident, even the simple object names of arithmetic, the 10 digits, are not merely arbitrary signs for numbers, for they too are caught up in the web of interconnected rules and algorithms that X the contents of the signs in the formula language of arithmetic. That we use the sign 3 to designate the number 3 is indeed arbitrary. We realize perfectly that other symbols might have been assigned to stand for the same things. But the sign 3 is not merely an arbitrary name for the number 3. In virtue of its role in the Arabic numeration system as a whole, in the formula language of arithmetic, it expresses a sense, and like any sense, this sense contains a mode of presentation of the number designated. It was suggested in Chapter 2 that a sentence of the formula language of arithmetic such as 2 plus 3 equals 5 should be read as merely presenting the numbers 2, 3, and ve in an arithmetical relation, one that can be variously analyzed. On that account, the numeral 2 designates the number 2 independent of any analysis. In fact, as we should by now be able to see, independent of their use in equations, the primitive signs of arithmetic only express senses. In a particular use, relative to some analysis, a digit such as 3, say, does designate the number 3, but independent of any context of use it only expresses a sense. Like any other primitive sign of the formula language of arithmetic, the numeral 3 contributes a sense, that is, what we are calling computational content, to an arithmetical expression that in turn expresses a sense and designates some object. It is this latter expression that is variously analyzable into function and argument. For example, we use the primitive signs 2, 3, 5, equals, and plus to form the equation 2 plus 3 equals 5, which expresses a sense and designates the truth value true. This sentence can then be analyzed into function and argument in various ways, for example, into the relation psi equals zeta for the number ve, determined in two different ways, as argument. Relative to this analysis, the numeral 5 does designate the number ve, but the numeral 129 2 does not designate the number 2. Rather, it serves as a part of the expression 2 plus 3 which forms an object name for the number ve. Independent of such a context of use and of some particular analysis, a primitive sign of arithmetic does not designate anything, it only expresses a sense that can contribute to the sense of a sign in use and thereby to the determination of a meaning. It is just this insight that is expressed in Frege's context principle, according to which we are never to ask for the meaning of a word in isolation, but only in the context of a proposition. Number words, as Frege almost says in Grundlagen 60, signify something only in the context of a proposition. Independent of a proposition they only express a sense. On this account, the object names that we use in the formula language of arithmetic are constitutively such as to designate objects, that is, numbers. It nevertheless does not follow that every object name expression in the language is guaranteed to designate a number. The expression 2/0, for instance, has a finite sense, but it designates nothing. It has sense but no meaning. The notion of sense, computational content, cannot be understood independently of the notion of meaning. Nevertheless, there can occur arithmetical signs that express a sense yet lack a meaning. The positional Arabic numeration system is a conceptual notation of arithmetic, at once a lingua characterica and a calculus ratiocinator. It in its own right the numerical element, and because it does, the manipulation of symbols in this system according to its rules enables one to establish truths. As Leibniz says of a lingua characterica generally, we can pass from a consideration of the relations in the expression to a knowledge of the corresponding properties of the thing expressed. 12a conceptual notation of pure thought, similarly, ought to symbolize in its own right the logical element so that manipulations of the symbols in that system according to its rules likewise enable the establishment of truths. But what is the logical element? In the Begriffsschrift of 1879 Frege assumes that the logical element, everything necessary for a correct inference, that is, inferential content or begriffiger inhalt, can be given by the truth conditions of a sentence, by the circumstance that obtains if the sentence is true. It is this notion of content that is split in the mature logic. Just as a perspicuous language of arithmetic pictures, or traces, not relative magnitudes but instead computational content, so, Frege came to see, a perspicuous language of thought pictures, or traces, not truth conditions but instead inferential content. 130 4.3 The formula language of pure thought. Frege shows in Grundlagen that a number cannot be understood as a collection of units because if it were, the units collected would be either the same, and they could not then form a plurality, or different, and they would then form only an aggregate to which different numbers could be assigned depending on our way of looking at it. The problem arises, he argues, because we confuse the notion of a concept relative to which the items in a collection are identical one with another and are to be numbered with that of the number of the particular objects that fall under that concept. The attempt to understand sentential content by appeal to truth conditions or states of affairs, the circumstance that obtains if a sentence is true, similarly rests on a confusion, Frege comes to think. In the case of number, the problem is that a collection of units can be assigned different numbers depending on our way of regarding it. In the case of sentential content, analogously, the problem is that a picture of things as thus and so can be assigned different truth values depending on our way of regarding it. Frege explicitly makes the point in the late essay Thoughts. We think that truth consists in a correspondence of a picture to what it depicts. But if I do not know that a picture is meant to represent Cologne Cathedral, then I do not know what to compare the picture with in order to decide on its truth. When we ascribe truth to a picture, we do not really mean to ascribe a property which would belong to this picture quite independently of other things. We always have in mind some totally different object and we want to say that the picture corresponds in some way to this object. My idea corresponds to Cologne Cathedral is a sentence, and now it is a matter of the truth of this sentence. So what is improperly called the truth of pictures and ideas is reduced to the truth of sentences. When we call a sentence true, we really mean that its sense is true. A collection of objects, 9 beans, say, can be represented by a kind of a picture, for instance, by 9 strokes on a page, and a state of affairs, that Romeo loves Juliet, say, can similarly be represented by a picture, for instance, by marks representative of Romeo and of Juliet in a certain relation, perhaps thus, RJ. But, as Frege argues in Grundlagen, number does not belong to the collection of strokes independent of our way of regarding it, and likewise, as he points out in Thoughts, truth or falsity does not belong. 131 to a picture such as RJ quite independently of other things. 13 As Frege shows, the conception of the collection as a collection of 9 strokes presupposes both the concept of a stroke and the number 9 that is assigned to it. Similarly, he suggests in the passage just quoted, the conception of a picture, the picture RJ, say, as a picture of Romeo loving Juliet presupposes both the thought expressed and a truth value. Of course there are states of affairs, just as there are collections of objects, and sentences do have truth conditions, at least those that designate truth values do. But just as understanding the notion of number requires appeal not to collections of objects but instead to the more n-grained notion of a concept relative to which one counts and the less n-grained notion of a number that is assigned to that concept, so to understand the content expressed by a sentence requires appeal not to truth conditions but to the more n-grained notion of a thought, the sense expressed by the sentence, and the less n-grained notion of truth. It was suggested earlier that grasping the computational content or sin of an expression in the formula language of arithmetic involves 3 different capacities. First, one needs to know how to form and to recognize individual numerals such as 37 and 64722 and also more complex arithmetical signs such as 37 plus 642 and 3747. One also needs to know how to apply such signs, in particular that 0 is assigned to concepts under which nothing falls, and so on. Finally, one needs to know the algorithms of arithmetic, how to perform calculations according to the rules of arithmetic in order to prove identities. Grasp of the cognitive content or sin of an expression in Frege's formula language of thought involves three strictly analogous capacities. First, one needs to know how to form and to recognize simple and logically complex sentences of the language. One needs, that is, to be able to distinguish well-formed complexes of expressions from those that are not well-formed. One needs to know, for instance, that the Gothic letter may not occur without prext, save in itself, that in psi 132 any proper name may be substituted for psi. Of course, one also needs to know that object names and concept words are no more intersubstitutable one for the other than the numerals and function signs of the formula language of arithmetic are. Second, one needs to know how to apply the signs of the formula language of thought in correct judgments. One needs to know, for instance, that the value of the function psi shall be the false for every argument for which the value of the function psi is the true, and shall be the true for all other arguments, and that the value of the relation psi zeta shall be the false if the true be taken as zeta argument and any object other than the true be taken as xi argument, and that in all other cases the value of the function shall be the true. Knowing in this way the conditions under which a sentence of Begriffsschrift composed of such signs designates the true, one knows how correctly to apply the language, how to employ it in making correct judgments about how things are. 14. Having grasped in this way the functions designated by the basic combinations of the primitive signs and the role Latin italic letters play in lending generality of content, one ought to be able to see, for instance, that designates the truth value true whatever object gamma denotes and hence that is a correct judgment, and so on for all the basic laws of Begriffsschrift. Much as the simple truths of arithmetic form the basis for calculations in the formula language of arithmetic, so these basic truths of logic form the basis for inferences in the formula language of pure thought. 133. The third and last thing one needs to know is how to draw valid inferences, that is, the rules that govern correct inferences from Begriffsschrift judgments. Frege summarizes these rules in Grundgesetze 48. All and only these three capacities are required to grasp the content, that is, the thought or sin expressed by a Begriffsschrift sentence as understood here. Much as an expression in the formula language of arithmetic expresses computational content in virtue of the various rules governing the use of the symbols of that language in counting and calculating, so an expression in the formula language of thought expresses cognitive content in virtue of the various rules governing the use of the symbols of that language in judging and inferring. An expression in the formula language of arithmetic such as 2 plus 1 does not picture relative magnitude, it is not, as the Roman numeral 3 is, a picture of a collection of objects. What an expression in that notation pictures is the numerical element, everything necessary for a correct calculation, what we have called its computational content. An expression in the formula language of pure thought, similarly, pictures not truth conditions but instead everything necessary for correct judgment and inference, what we have called cognitive content. Sameness and difference in sign, on this view, correspond not to sameness and difference in truth conditions but instead to sameness and difference in the thought expressed, in cognitive content, that is, in content as it matters to judgment and inference. Furthermore, just as in the case of the formula language of arithmetic, object names in the formula language of thought can designate one and the same object under different modes of presentation. In such cases sentences that contain those object names express different thoughts despite the fact that they have identical truth conditions. To take a familiar example, the sentences "the morning star is a planet" and "the evening star is a planet" have exactly the same truth conditions, because in both cases what is referred to is Venus and the property ascribed is that of being a planet. But the two sentences do not express one and the same thought, because the mode of presentation of Venus is different in the two cases. Venus is arrived at in two different ways in this case, just as the number 4 is arrived at in different ways in the expressions 2-2 and 7-3. Because, as we will see, judgment on Frege's considered view is an advance from a thought to a truth value, it follows that judging that the morning star is a planet is different from judging that the evening star is a planet. Because the thoughts are different, the 134 acts of judgment are different, even though it is one and the same object about which the judgment is made and one and the same property that is ascribed. For just the same reason, the inference "the morning star is a planet, therefore, the evening star is a planet" is invalid as it stands, even though the truth of the premise is sufficient to ensure the truth of the conclusion. The judgment that the evening star is a planet does not immediately follow from the judgment that the morning star is a planet, any more than that 2 plus 3 equals 7. 2 follows immediately from 2 plus 3 equals 5, in both cases a recognition judgment is required, that the morning star equals the evening star in the RST case and that 7-2 equals 5 in the second. Furthermore, we can see in the notation itself that this is so, because in the notation differences in sign correspond to differences in sense. Comparison with yet another symbol system will further clarify the point. As pictured in a standard language of chemistry, phenylalanine is given thus. 15. This is not what a molecule of phenylalanine looks like, and yet the picture is enormously useful because it traces the chemical bonds that matter to the synthetic pathway through which such a molecule might be constructed, and it reveals biochemically significant similarities and differences between this amino acid and other organic molecules. Furthermore, the picture simply presents the structure, that is, various atoms in a particular molecular arrangement. Because it does, it can be regarded in various ways, for instance, as a benzene ring with a complex in place of one hydrogen, or as an amino acid distinguished from, say, alanine in having the group in place of CH3. We can divide it, that is, into a main component and subcomponents in various ways. Furthermore, there are, in the picture, clearly significant subunits, the benzene ring, obviously, but also CH2. 135 H C NH2 CH2COOH CH2 NH2 and COOH are all treated as units in our depiction relative to the main bonds. Like any Dean signs, these signs are easily unpacked to reveal in turn the bonds they involve, and the Dean signs might well need to be so unpacked to account for a particular synthetic pathway. Sentences of Begriffsschrift similarly picture not what a sentential content, with all its tone and coloring, looks like, but only its sense, that is, its content as it matters to the correctness of judgments and inferences it can gure in, as well as its significant similarities to and differences from other contents. For instance, the judgment that would be rendered in English as the judgment that every result of an application of a procedure F to an object X follows this X in the F sequence has its content pictured in Frege's formula language thus: gamma F beta F. As in our sign design for phenylalanine, this sign design includes a Dean sign that marks a significant unit. The same thought expressed using only the primitive signs of Begriffsschrift is this: F F F. The thought so expressed reveals all the primitive logical bonds that are involved in it. Furthermore, just as any chemical bond may be regarded as the last one for the purposes of organic synthesis, so any of the primitive logical bonds in the thought expressed here may be regarded as the main one for the purposes of judgment and inference, though, again, there are laws that govern what can and cannot be judged or inferred in a proof. We know that understanding the goodness of inference can require taking any one of a variety of different perspectives on a sentence, any one of the various different pathways through it that are available, depending on what other premises are involved in the inference. 136 136. To infer, for instance, that Romeo admires Juliet on the grounds that Romeo loves Juliet and that anyone who loves Juliet admires her requires analyzing Romeo loves Juliet into function and argument in a way that is different from that required in the inference Romeo loves Juliet. Anyone who loves someone loves himself or herself, therefore, Romeo loves himself. Frege's two-dimensional notation, which merely sets out the logical relationships among the senses of primitive object names and concept words, makes it easy to see just what analyses are possible and so what the inference potential of a sentence is. As we will see later, an analogous point holds also for the case of judgment. Our example from the language of chemistry furthermore highlights both the respect in which a Dean sign is, and the respect in which it is not, significant in a properly logical language. Dean signs, Frege points out, are quite inessential. Considered from a logical point of view, for, it is clear, nothing could be proved using the deniendum in, say, the denition of following in a sequence that could not be proved using the deniens instead. Nonetheless, as Frege also points out, to be without logical significance is still by no means to be without psychological significance. Just as one needs conceptually to carve up the depiction of a phenylalanine molecule in one particular way in order to see that molecule as an amino acid, so one needs to carve up the thought depicted earlier in one particular way in order to see it as exhibiting the fact that every result of an application of a procedure F to an object X follows this X in the F sequence. It is this way of looking at the sentence that reveals its importance as a theorem in the general theory of sequences, and the use of the Dean sign helps to reveal this, but again, we could not make do in the proof of this theorem with the Dean sign alone. As Frege says, we often need to use a sign with which we associate a very complex sense. Such a sign seems, so to speak, a receptacle for the sense, so that we can carry it with us, while being always aware that we can open this receptacle should we have need of what it contains. If therefore we need such signs in which, as it were, we conceal a very complex sense as in a receptacle, we need also denitions so. 137 137. That we can cram this sense into the receptacle and also take it out again. Much as the standard symbol for the benzene ring is useful for marking out a significant part of a vast range of organic molecules, so Dean signs in Begriffsschrift are useful in marking for us significant parts of thoughts. They impose a kind of secondary structure on the thought, one that highlights its larger significance in the body of knowledge as a whole. But that secondary structure, although it may help us to see what is important about a particular theorem, why it is worth proving at all, is not logically significant. Logically speaking, the only significant differences between the various logical bonds depicted are those marked by the axioms and rules of the language itself. It was suggested earlier that to understand an expression in the formula language of arithmetic is to grasp its computational content as determined by the rules that govern the use in calculations and in statements of number of expressions in that language. To understand an expression in Frege's formula language of thought is similarly to grasp its cognitive content as determined by the three sorts of rules that govern the use of expressions in that language in judgments and inferences. Sense, so conceived, attaches to an expression only relative to a whole language, a complete totality of signs. Whereas for the classical logician the smallest unit of cognitive significance is the term, and for the modern logician it is the sentence conceived as expressing a proposition. What is the case if it is true? On Frege's mature account, it is the whole language that is the minimum unit of cognitive significance. To grasp the sense of a sentence, on this account, it is not sufficient to know what is the case if it is true, that is, the necessary and sufficient conditions for correctly acknowledging its truth. One must also know what follows from it with or without auxiliary premises. For users of natural language, such knowledge is largely tacit. In Begriffsschrift this knowledge is made explicit, at least for the fragment of language with which Frege is concerned. As Frege says of the formula language of arithmetic, so we can say of Frege's own formula language, the notation has, as a result of genuine thought, been so developed that it does the thinking for us, so to speak. One can 138 138. See in the sentence itself everything necessary for a correct judgment and for a correct inference involving it, just as one can see in an expression of arithmetic everything necessary for a correct statement of number and for a correct calculation involving that expression. From the perspective afforded by Frege's mature understanding of how Begriffsschrift functions as a language, a symbolic language designed perspicuously to express not inference potential so conceived but instead truth conditions, would be quite like the Roman numeration system designed perspicuously to express not computational content but instead relative magnitude. In neither case is what is mapped or pictured what is needed in a conceptual notation proper, one that is at once a lingua characterica and a calculus ratiocinator. Once Frege had come explicitly to realize that sentences of Begriffsschrift directly express not truth conditions, that is, the circumstance that obtains if the sentence is true, but instead cognitive content, that is, everything necessary for a correct inference, explaining the cognitive significance of some identities was easy. Even the simplest object name expresses a sense wherein the mode of presentation is contained, a sense that is grasped by everybody who is sufficiently familiar with the language or totality of designations to which it belongs. Because two names that designate the same object can nonetheless differ in sense, can arrive at the object in different ways, lead to it from different directions, statements of identity can contain very valuable extensions of our knowledge and cannot always be established a priori. The problem on the side of concept words is similarly resolved in the mature logic. The problem for Frege's early view of concept words, as developed in section 4.1, concerned not the cognitive significance of identities but instead the objective significance of generalities. More specifically, as long as the logical notion of a concept was confused with the logical notion of sin, it was impossible to understand generalized conditionals as expressing relations directly among concepts. If the role of a concept word were merely predicative, if it served, that is, only to characterize objects otherwise given, then even a logically general sentence, to have any content at all, would have to be in some way about objects. Frege did see, even in the early logic, that this cannot be right because understanding the goodness of some inferences requires taking not an object but instead a concept as the argument for a concept, but only after he had realized that his early conception of concept words as essentially predicate. 139 139. Tiv rested on a confusion of the concept/object distinction with the sin/Bedeutung distinction. Could he see why it is not right? Concept words, on Frege's mature view, do not only express senses, they also designate concepts which, although unsaturated, are fully objective entities that can stand in logical relations one to another and can serve as arguments for higher level functions. The laws of the special sciences, and the laws of logic as well, can then be taken to be fully objective, substantive truths despite the fact that they involve no reference to any objects, and in the case of the laws of logic no reference even to any RST-level concepts. In the Longboule essay, Frege takes a concept word directly to signify a concept, to be a kind of map of that concept. He does so, we can see in retrospect, because he connates the notion of sense with the notion of a concept in the early logic. Concepts, we are told in that essay, are to be formed out of concepts just as the signs for them are formed out of primitive signs using the logical cement provided by Frege's concept script, rather as the number 3, on the collection's conception, is to be formed out of units just as the sign for 3 can be formed out of i's. Just as, on that conception of number, different collections form different numbers, so it follows on Frege's early conception of concepts that different constructions yield different concepts, that, as Frege himself explicitly notes, one could form concepts with different contents whose extensions were all limited to this one thing, the earth. Indeed, Frege calls his language a Begriffsschrift, a concept script, for just this reason. What his formula language maps or traces is what he thinks of in the early writings as conceptual content, so, he at RST thinks, sameness and difference in signs correspond to sameness and difference in concepts. But, as he later sees, Concepts are no more formed by cementing together concepts than numbers are formed by putting together units. Concepts are functions, objects to truth values in the case of RST level concepts and concepts to truth values in the case of higher level concepts. The senses expressed by concept words have parts, concepts themselves do not. 16. One and the same concept, then, can be designated by different concept words, by expressions that express different senses. To show that two concepts are mutually subordinate is to show just that. Begriffsschrift, then, is not a concept script at all on our reading, it is a Sinnschrift, a formula language of thought. 17. As Frege himself comes to see, a sentence of Begriffsschrift is a picture of a thought whose parts correspond to the parts of that. 140. Thought. We can regard a sentence as a mapping of a thought, corresponding to the whole part relation of a thought and its parts. We have, by and large, the same relation for the sentence and its parts. The structure of the sentence can serve as a picture of the structure of the thought. Thoughts so conceived are variously analyzable for the purposes of judgment and inference, and are perspicuously expressed only in a two-dimensional written language of the sort we have learned to read as Frege's Begriffsschrift. Frege's new conception in terms of Sinn and Bedeutung of the way a properly logical language functions also clarifies a surprisingly wide variety of features of ordinary language and its use, despite the fact that this aspect is not properly of concern to logic itself. Frege clearly takes this unanticipated explanatory power to constitute strong evidence for his view. His new conception of the way a properly logical language functions explains, for instance, the marvelous creativity of language, the fact that with just a few sounds and combinations of sounds it is capable of expressing a huge number of thoughts, and, in particular, thoughts which have not been grasped or expressed by any man. Because, on the mature view, the primitive symbols of the language express senses that are combined in the thoughts expressed by sentences formed from these symbols. Our capacity for grasping novel thoughts can be directly explained by the fact that thoughts are built up out of their parts as sentences are built up out of words. 18. Understanding indirect discourse is similarly straightforward. The thought, which otherwise is the sense of a sentence, in indirect discourse becomes its denotation. Indeed, Frege claims, only in this way can indirect discourse be correctly understood. In our whole proposition, the proper name Copernicus designates a man, just as the subordinate claim that the planetary orbits are circular designates a thought, and what is said is that there is a relation between this man and that thought, namely that the man took the thought to be true. Here the man and the thought occupy, so to speak, the same stage. Because the clause that the planetary orbits are circular here designates a thought, rather than expressing one, only clauses that express the same sense can be substituted for it salva veritate. Because a judgment is now to be understood as 141. An advance from a thought to a truth value, judgments are different if the thoughts expressed are different. If now A equals B, then indeed what is meant by B is the same as what is meant by A, and hence the truth value of A equals B is the same as that of A equals A. In spite of this, the sense of B may differ from that of A, and thereby the thought expressed in A equals B differs from that of A equals A. In that case the two sentences do not have the same cognitive value. If we understand by judgment the advance from the thought to the truth value, as in the present paper, we can also say that the judgments are different. From the fact that, say, Hesperus is phosphorus and the fact that someone judges that Hesperus is Venus, it cannot be inferred that that same person judges that phosphorus is Venus, despite the fact that the sentences Hesperus is Venus and phosphorus is Venus have precisely the same truth conditions. Light is shed also on explanations and counterfactual claims in natural language. 19. We say, for instance, that ice oats on water because it is less dense than water. This judgment, Frege now suggests, involves three different thoughts: that ice is less dense than water, that anything that is less dense than water oats on water, and that ice oats on water. It involves, that is, Not only the judgment that ice oats on water and the judgment that ice is less dense than water, but also the judgment that there is a lawful or causal connection between the two claims. In Begriffsschrift, this lawful connection would be expressed in a genuine hypothetical, as a relation between the concepts less dense than water and oats on water, though its status as a law proper would be revealed only by its ultimate justification, by a determination of the grounds of its truth. The account of counterfactual claims is essentially similar. To judge that if iron were less dense than water then it would oat on water is to deny that iron is less dense than water, but to assert an internal connection between something's being less dense than water and its oating on water. Again, the truth of the whole claim depends on the genuine hypotheticals being necessary, that is, properly lawful rather than merely accidental. Though an accidental generality is expressed as a genuine hypothetical in Frege's logic as we read it, and has thereby the status of a law for the purposes of inference, following it back to its ground would reveal that it is merely contingent or accidental, grounded in accidental facts about particular objects. 142 And so could not properly support the counterfactual claims of natural language. But again, the light that is shed on these various aspects of our understanding and use of natural language expressions by Frege's mature understanding of the functioning of language in terms of Sinn and Bedeutung is only confirmation of the view. It is in Begriffsschrift, and only in Begriffsschrift as it is read here, that the sense of a sentence is perspicuously expressed. We must look to Frege's formula language of pure thought adequately to understand the notions of Sinn and Bedeutung. Though Frege's logical language was originally designed to express everything necessary for a correct inference, Frege himself did not at rst adequately understand the nature of such a language. He did not understand what it is that is the logical element, and so confused the notion of content as it is given by truth conditions which, in Frege's logical language as here conceived, can be given only relative to an analysis, and the logically prior notion of cognitive content as it is exceded by the rules that govern the correctness of judgments and inferences in the language. What Begriffsschrift expressions directly map are not truth conditions but cognitive content, that is, thoughts, everything necessary for correct judgment and inference. Such content is, furthermore, essentially two-dimensional, for what matters to the correctness of judgment and inference is that sentences be variously analyzable. The extended, two-dimensional, inferentially articulated space of Frege's mature conception of the thought expressed by a sentence effectively displaces, on our account, the one-dimensional space of his early conception of a content of possible judgment in terms of truth. Relative to the thought that a Begriffsschrift sentence expresses, a one-dimensional representation of its truth conditions provides only a single facet of that thought. Like an image on the wall of Plato's cave, a one-dimensional representation of a thought, as Frege comes to understand thoughts, is only a shadow of the fulgor. 20. 4.4 The striving for truth. Judgment, one is often told, is the ascription of a predicate, the endorsement of the application of a concept. Already in 1879 Frege seems to have held that this cannot be right. On the one hand, as regards what follows from it, the content expressed by a sentence must be variously analyzable into function and argument if the goodness of inferences in which it occurs are to be understood. Only relative to an analysis has it a subject and a concept applied to that subject. On the other hand, as regards what a judgment follows from, Frege indicates, although one's basis for a judgment can be various, the content acknowledged to be true is nevertheless in each case the same. One can, for instance, arrive at the judgment that 2 4 equals 16 either by taking 2 to the 4th power or by ending the positive 4th root of 16 or by calculating the logarithm of 16 to the base 2. Similarly, one can arrive at the judgment that Romeo loves Juliet by interrogating Romeo, by discovering relevant facts about Juliet, or by some other means wreaked it in some other function/argument analysis of the relevant sentence. Nevertheless, the judgment is in each case the same. Reaction on the case of denial, that is, on the case of acknowledging the truth of the negation of a sentence, reinforces the point. Suppose, for instance, that it is discovered that the thought expressed by the sentence Jane gave Jack a book for his birthday is false. It is, then, the negation, that it is not the case that Jane gave Jack a book for his birthday, that is acknowledged as true. But the grounds for the acknowledgement can be various, that it was not Jane but Jean who gave Jack the book, that it was not Jack but John to whom Jane gave the book, that it was not a book but a boat, not his birthday but his graduation, or even that she did not give him the book at all but only lent it to him on that occasion. Any part of the sentence can be denied in this way, thereby indicating that in the sentence itself all parts of it are logically on a par. What is asserted is not that the predicate applies but that the thought as a whole is true. The judgment itself is simply an acknowledgement of the truth of the thought expressed. 21 At RST, in Begriffsschrift, Frege tries to register this point by thinking of judgment as an ascription of the predicate is a fact. To judge, on the early view, is not to ascribe now this property, now that to a subject, but it is to ascribe a property, namely, the property is a fact to the whole content. To judge, on the early view, is to endorse the whole content of a sentence as a fact. As Frege later argues, such a predicative conception of judgment is hopeless. One might be tempted to regard the relation of the thought to the true not as that of sense to meaning, but rather as that of subject to predicate. One can, indeed, say, the thought that 5 is a prime number is true. But closer examination shows that nothing more has been said than in the simple sentence 5 is a prime number. The truth claim arises in each case from the form of the 144 assert oric sentence, and when the latter lacks its usual force, example in the mouth of an actor upon the stage, even the sentence the thought that 5 is a prime number is true contains only a thought, and indeed the same thought as the simple 5 is a prime number. It follows that the relation of the thought to the true may not be compared with that of subject to predicate. Once Frege had given up the idea that judgment can be understood in terms of predication, that is, as an ascription of the predicate is true or is a fact, it was quite natural for him to argue instead, as he does in On Sense and Meaning, that the meaning, Bedeutung, of a sentence, assuming that it has one, is a truth value, either the true or the false. For the question of judgment is always and only the question of the truth of a thought. Judgment, on Frege's considered view, is an acknowledgement of truth. More exactly, it is the acknowledgement of that sort of truth which it is the aim of science to discern, and where there is no concern for truth of this sort, there is no judgment, at least in the sense of judgment that concerns Frege. That is why the assertions of the actor, novelist, and poet are not to be taken seriously, they are only mock assertions. As stage thunder is only sham thunder and a stage GHT only a sham GHT, so stage assertion is only sham assertion. It is only acting, only shin. Furthermore, because the assertoric force is lacking in such cases, it does not matter whether the thoughts expressed are true or false or have no truth values at all, thoughts in myth and shin do not need to have truth values. If, on the other hand, one adopts an attitude of scientific investigation, the question whether a sentence has or lacks a truth value is paramount. If it is the question of the truth of something, we have to throw aside all proper names that do not designate or name an object, though they may have a sense. We have to throw aside concept words that do not have a meaning. These are not such as, say, contain a contradiction, for there is nothing at all wrong in a concept's being empty, but such as have vague boundaries, for shin the sense is enough. The thought, though devoid of meaning, of truth value is enough, but not for science. It is, nally, a perfectly objective matter whether a sentence has or lacks a truth value on Frege's view. We think, for example, that there was in fact 145 no such person as Odysseus, that Odysseus is merely a character in a story. Hence we do not take claims about Odysseus seriously, we do not concern ourselves with whether or not the claims are true. But however we take claims about Odysseus, whether seriously or not, it is an objective matter whether they belong to the realm of shin or to the realm of truth, that is, whether they can be taken seriously. If the accounts of Odysseus's exploits were not after all fictional but were properly historical narratives, then the thoughts would remain strictly the same, they would only be transposed from the realm of fiction to that of truth. To discover that accounts of Odysseus's exploits were historical narratives would be to discover that they belong to the realm of truth. One can discover that sentences one had taken to be only fictional, to express only mock thoughts, are sentences that belong after all to the realm of truth. One can similarly discover that sentences that one had taken seriously as belonging to the realm of truth are after all merely fictions, not because they have not been uttered with assertoric force but because they designate no truth values. One can, in other words, think that one is engaged in properly scientific discourse, think that one is operating in the realm of truth, when in fact one is not. Frege provides examples of this sort of case both in the introduction to Grundgesetze and in the late essay Thoughts. I simply mean to designate a man, independent of me and my ideating, and to assert something about him. We may grant idealists that the attainment of this intention is not completely sure and that, without wishing to, I may perhaps lapse from truth intuition, but this can change nothing about the sense. By using the expression that lime tree, I mean, to designate what I see and other people too can look at and touch. There are now two possibilities. If my intention is realized, if I do designate something with the expression that lime tree, then the thought expressed in the sentence that lime tree is my idea must obviously be denied. But if my intention is not realized, if I only think I see without really seeing, if on that account the designation that lime tree is empty, then I have wandered into the realm of fiction without knowing it or meaning to. In that case neither the content of the sentence that lime tree is my idea nor the 146 content of the sentence that lime tree is not my idea is true, for in both cases I have a predication which lacks an object. The content of the sentence that lime tree is my idea is fictional. I am convinced that the idea I associate with the words my brother corresponds to something that is not my idea and about which I can say something. But may I not be making a mistake about this? Such mistakes do happen. We then, against our will, lapse into fiction. Yes, indeed. By the step with which I win an environment for myself I expose myself to the risk of error. Judgment in this way involves both a kind of seriousness, a concern for truth that is lacking in fictional discourse, and also a moment with respect to which one is entirely passive. Because judgment is an act of acknowledging the truth of a thought, according to Frege, the thought regarding which one judges must have a truth value. I must actually have a brother in order to make judgments about him, and if I do not, however content I am that I do, then my judgments have exactly the same status as the judgments of the actor on the stage. They are only sham judgments, not judgments, properly speaking, at all. When one judges truly that, say, Mont Blanc is more than 4,000 meters high, one's knowledge is knowledge regarding the mountain and not one's thought of it. On the other hand, the thought acknowledged to be true in a correct judgment must be something that can be grasped in thought, by thinking, and a physical object such as Mont Blanc seems exactly the wrong sort of thing for thought to grasp. It is no more Mont Blanc itself that I grasp in thinking that Mont Blanc is more than 4,000 meters high than it is the number 7 that I grasp in my hand when I clutch 7 coins. Indeed, it cannot be the object itself that is grasped in thinking because, again, what is grasped in thinking must be variously analyzable. Strictly speaking, it is not in itself that the thought is singular, but only with respect to a possible way of analyzing it. One's knowledge, then, is not about that which one grasps in thinking. On the one hand, proper names designate objects, and a singular thought is about objects, but on the other hand, we can't say that an object is part of a thought as a proper name is part of the corresponding sentence. What, then, does the object have to do with the thought? The answer depends on whether or not one adopts an attitude of scientific investigation, on whether or not one strives after truth. If one lacks that sort of 147 seriousness, then Frege's answer is, nothing. As far as the mere thought content is concerned, it is indeed a matter of indifference whether a proper name has a meaning. But, as Frege immediately continues, in any other regard it is of the greatest importance, at least it is so if we are concerned with the acquisition of knowledge. It is this which determines whether we are in the realm of Shin or truth. To adopt an attitude of scientific investigation is to expose oneself to the risk of thinking that one is making a judgment, uttering a sentence with assertoric force, when in fact one is doing nothing of the sort. For even to judge at all, whether correctly or incorrectly, depends on factors wholly outside one's control. It is the striving for truth that drives us always to advance from the sense to the thing meant. Relative to that striving, then, the object is in a way constitutive of the thought, even though it is not a part of it, a constituent of it. One aims, for example, to pose the thought as a question, to ask whether or not the thought is true, but that question can be posed only if the relevant objects exist. If the relevant objects do not exist, then, relative to the striving for truth, the thought is merely mock, not a real thought at all, because it cannot be taken seriously. It cannot, in that case, be so much as posed as a question. To say that Fregean thoughts are object-dependent is to register the fact that the act of judgment involves not only the active moment of assent but also a moment with respect to which one is entirely passive. Quite simply, not all thoughts are available to be taken seriously, in particular, those that involve object names, relative to some analysis or other, that fail to designate any objects cannot be taken seriously. Such thoughts are merely shams, no more to be taken seriously than the sham assertions of an actor on the stage. Just the same is true, on Frege's account, in the case of concept words. To say that thoughts are concept-dependent and all thoughts are if they so much as purport to be taken seriously is to register the fact that we are equally passive on the side of concepts. One is free to decide whether or not to use a particular concept word in an attempted act of judgment, but only if the concept word does designate a concept will the attempted act succeed as an act of judgment. On Frege's view, it is possible to think that one has grasped a concept in the case in which there is nothing there to be grasped, just as it is possible to think that one has designated an object in the case in which there is no object there to be designated. 148. Ignated. As the point is put in the inertia essay, a concept is something objective, we do not form it, nor does it form itself in us, but we seek to grasp it, and in the end we hope to have grasped it, though we may mistakenly have been looking for something where there was nothing. There is, however, one important difference between the two cases on Frege's view. Whereas grasp of an object would seem to be an all-or-nothing affair, either the object name one uses designates an object, and it is fully determined which, or it does not. One's grasp of a concept can be more or less sure, one conception of it better or worse than another without either being fully adequate. The concept itself is fully determinate in the sense of having sharp boundaries. 22. But although the concept itself has sharp boundaries, it is not necessary that these boundaries be clearly perceived. Especially in the early days of a science, we do not have a clear grasp of the sense of the simple sign, its outlines are confused as if we saw it through a mist, we see everything through a fog, blurred and undifferentiated. Achieving knowledge of a concept in its pure form, Frege thinks, can require immense intellectual effort, which may have continued over centuries. In the case of concepts, what comes RST in the logical and objective order is not what comes RST in the psychological and historical order. Frege's Habilitationsschrift begins with an example of just this phenomenon. According to the old conception, length appears as something material which LLS the straight line between its end points. The introduction of negative quantities made a dent in this conception, and imaginary quantities made it completely impossible. Now all that matters is the point of origin and the end point. All that has remained is certain general properties of addition, which now emerge as the essential characteristic marks of quantity. Similarly, in the case of the concept number, it seemed, at a certain stage in the history of our acquisition of this concept, that a number submits to being taken away from another number greater than itself, but to take it away from a number less than itself is ridiculous. 23. Even Euler, who saw no difficulty in the notion of a negative number, refused to admit complex numbers, because all conceivable numbers are either greater than 0 or less than 0 or equal to 0, then it is clear that the square roots of negative numbers cannot be included among the possible numbers. 24. Only 149. 149. After immense intellectual effort continued over centuries have we succeeded in stripping off the irrelevant accretions which veil it from the eyes of the mind. It is not obvious that we have achieved knowledge of this concept in its pure form even now. As Frege claims, and as both the example of quantity in geometry and that of number in arithmetic illustrate, the problem with our conceptions, that which veils concepts from the eyes of the mind, is that those conceptions contain irrelevant accretions, that is, content that does not properly belong to the relevant concepts. We once thought, for instance, that from the concept of number itself it can be shown that negative numbers are impossible, or that any number is greater than, or less than, or equal to 0. We once thought, to take now an example from calculus, that from the fact that a function is continuous it can be inferred that it is differentiable. In each case our conception of the concept seemed to justify inferences that, as we later discovered, are not in fact valid. Indeed, as Frege claims already in the long Boole essay, almost all errors made in inference have their roots in the imperfection of the concepts. More exactly, as the point would have been put after the distinction between concept and sin was in place, they have their roots in the imperfection of our conceptions, in the senses we attach to concept words. As long as our conceptions are imperfect in this way, and the outlines of the sense are thus confused, our knowledge of the concept itself is similarly confused. Like any expression in a properly logical language as here conceived, a concept word expresses a sense that is exceded by the three sorts of rules governing its use in judgment and inference that are coded in the language as a whole. The sense of a concept word in this way presents a concept under a mode of determination, a conception of it. The word has cognitive content for a thinker for just this reason. But one's conception, at any given historical moment, may be odd. One's perception of the boundaries of the concept may be blurred or altogether illusory. According to Frege's account in the Inertia essay, we discover that our conceptions are odd in these ways by discovering that our conceptions and judgments involving them lead to contradictions. Contradictions, Frege thinks, are created by treating as a concept something that was not a concept in the logical sense because it lacked a 150 sharp boundary. In the search for a boundary line, the contradictions, as they emerged, brought to the attention of the searchers that the assumed boundary was still uncertain or blurred, or that it was not the one they had been searching for. Their all driving force is the perception of the blurred boundary. Because our grasp of concepts is mediated in this way by conceptions that are constitutively inferentially articulated, we can discover that what we had taken to be judgeable thoughts about phlogiston or motion lead to contradictions that reveal in turn the us in these conceptions. It is by just such a mechanism that we are able to strip those conceptions of the irrelevant accretions that can attach to them and, on Frege's account, veil the concepts themselves from the eyes of the mind. Correlatively, when we get things right, that is, when our conceptions, the senses we attach to concept words, are adequate to the concepts themselves in setting the boundary lines of the concepts where they are as a matter of objective fact, then our judgments involving those concepts are wholly successful. What we judge to be so is so. The work of science, on Frege's view, in the discovery of true thoughts for just this reason. As it has been understood here, a Fregean thought, insofar as it is thinkable, available to be grasped by a thinker, is not world-involving. If the signs that are involved in a sentence themselves have sense, then the sentence as a whole expresses a sense. It expresses something thinkable. But that same thought, we have suggested, is judgeable, available to be acknowledged as true, and hence also available to serve as a premise in an inference just if the relevant objects and concepts exist. A judgeable content must designate a truth value, either the true or the false, and is thus essentially world-involving. Because it is often only after immense intellectual effort that we achieve knowledge of a concept in its pure form, it follows that we must work not only to achieve true thoughts but also, and antecedently, to achieve adequate conceptions of things and thereby thoughts that are available to be judged true at all. We must work our way into the realm of truth, and we can do so, on the account just sketched, in virtue of our inferentially articulated conceptions of things. It is by discovering the contradictions buried in our faulty conceptions that we achieve better conceptions in geometry and arithmetic, in the natural sciences, and even in logic itself. In so doing, we come to have the eyes to see things as they are. 25. 151 151. 4.5 The Science of Logic. We have seen that Frege's early understanding of the nature of a logical language is shaped by the idea that object names and concept words serve two radically different functions, the one to refer to objects, that is, to function as a representative of objects, the other to characterize objects so referred to, or represented, as thus and so. The contents of complete sentences, then, are conceived in terms of the notion of a content of possible judgment, something as something. Already in the early Begriffsschrift the inadequacies of this conception are apparent. If names functioned only as representatives of objects, then no account could be given of the cognitive value of some identities. If concept words functioned only to characterize objects otherwise given, then no account could be given of the objective significance of laws that subordinate one concept to another. The force of these problems, combined with Frege's penetrating reactions in Grundlagen regarding the expression of such simple arithmetical truths as that 1 + 1 + 1 = 3, yields, in the mature logic, a radically different conception according to which both object names and concept words function both to express senses and to designate objective entities, objects and concepts, respectively. From the perspective afforded by this mature logic, Frege had, in the early logic, conated, on the one hand, the notion of Bedeutung, the objective, with that of an object, and on the other, the notion of Sinn, cognitive significance, with that of a concept. But Frege's Grundlagen reactions on the formula language of arithmetic were not only a moment in the dawning realizations that came to fruition in the writings of the early 1890s. The understanding Frege achieves in Grundlagen of the way that language functions to express computational content provides a direct and essentially complete analog of the way a formula language of thought functions to express what Frege, in the early logic, characterizes as Begriffiger Inhalt, that is, everything necessary for a correct inference and judgment, since, as he came to see, among what is necessary for a correct inference is the acknowledged truth of the premises. To grasp the content expressed by an expression in the formula language of arithmetic requires, we suggested, RST, the capacity to form and to recognize properly constructed expressions as opposed to those that are not well formed, second, the capacity correctly to assign numbers designated by expressions in the language to concepts in light of the objects that fall under them, and third, the capacity correctly to 152 Put in the language. Grasp of the thought expressed by a sentence in the formula language of pure thought, analogously, requires, on our view, RST, the capacity to form and to recognize well-formed sentences in the language, second, the capacity correctly to judge of sentences in the language that they, or their negations, express true thoughts, and third, the capacity correctly to draw inferences in the language. All and only these three capacities are required in order for a thinker to understand a properly logical language, to be capable of grasping the thoughts expressed by sentences in the language. Because grasp of the Sinn of an expression requires knowing the rules that govern judgments and inferences in the language, where judgment and inference necessarily involve in turn the notion of Bedeutung, the notion of Sinn is not, on our view, intelligible independent of the notion of Bedeutung. Nevertheless, locally, we have seen, there can be sentences that express thoughts though they designate no truth values. There could be notion were there not also the striving for truth, but it is also the case, on Frege's account as it is here understood, that one cannot fully understand the striving for truth without recognizing the possibility that, as Frege puts it, one has wandered into the realm of Shen. Judgment, on this view, essentially involves both an active moment, the moment of assent, and also a moment with respect to which one is entirely passive, the moment of truth. If either is lacking, the active moment in stage assertion, for example, the passive moment in the case of a Bedoelungsloos thought, there is an appearance of judgment but no judgment, properly speaking. Relative to the striving for truth, Bedoelungsloos thoughts are only mock thoughts. Not only are they not revelatory of things as they are not even revelatory of things as they could be. As we might think of it, they provide no window on the world at all. On Frege's account as here developed, it is only through thoughts expressed by sentences in a sufficiently advanced scientific language that one perceives anything at all. All our knowledge is essentially mediated by an inherently historical, learned public language. It follows that anything we think we know could in principle be called into question, that although we can have knowledge, we cannot have certainty, an unquestionable ground to which we might retreat when all else fails. This is furthermore true even in the case of our knowledge of the laws of logic, even in the case of our knowledge of a law such as that of identity, A equals A, which seems to be transparently self-evident. Frege indicates just this possibility in the THIRD-WORLDISM, this impose. 153. Civility of our rejecting the law in question hinders us not at all in supposing beings who do reject it. Where it hinders us is in supposing that these beings are right in so doing. It hinders us in having doubts whether we or they are right. We cannot ourselves the least reason to doubt the law of identity, it seems to us to be as manifestly true as any truth could be. But whereas we ourselves can no grounds for doubt, we can imagine beings who do have such grounds, even who reject this law. Because we cannot ourselves, now, in our particular historical moment, any grounds for doubt, we cannot imagine that they are right. But, Frege claims, we can imagine them. His point, then, seems to be that though we cannot doubt the law of identity, we can imagine someone, sometime, coming up with a reason to call that law into question. Certainly at various points in our intellectual history we have come to doubt what had before seemed true, even self-evidently true, for example, that a greater number cannot be subtracted from a lesser, that any number is greater than or less than or equal to 0, or that continuity entails differentiability. Frege's point is that our knowledge of the laws of logic is no different. Even the law of identity could, in principle, be reasonably called into question, for even this law is known only through the medium of a historical, learned public language. Because we grasp this truth by way of the thought expressed by A equals A, where this thought in turn is determined by the place of the sentence in the language as a whole, the possibility that we are mistaken cannot be foreclosed. Logic, on this view, is a science like any other, and no more than in any other science is it simply given what the basic logical concepts are or how best to conceive them. We can make mistakes, even in logic, and we do for the same reason we make mistakes in any science, namely, that we fail adequately to grasp the concepts constitutive of the domain of that science. On Frege's mature view as we have understood it here, nothing, not even the most basic truth of logic, is utterly transparent to reason, as he had claimed in Grundlagen 105. Our conceptions of things, the medium through which they are grasped by us, can become transparent to us in a fully axiomatized system, but such conceptions must be distinguished in principle from the concepts we seek to grasp by their means. We can make mistakes. In Grundgesetze Frege attained, so he thought, the goal of a system, the ideal of a strictly scientific method. In Grundgesetze everything on which proofs are based is brought to light, and because it is, if anyone should anything defective, he must be able to state pre. 154. Precisely where, according to him, the error lies, in the basic laws, in the definitions, in the rules, or in the application of the rules at a particular point. Of course, someone, Russell, did something defective, and he found it at just the place Frege had suggested one might, in basic law v concerning courses of values. As Russell's paradox shows, something is amiss in our conception of a course of values. Either the boundary of this concept is not where it has been taken to be, or there is no boundary, no concept at all, where we had been looking for one. Frege came to think that it is the latter that is the case, that the concept word course of values and expressions in Begriffsschrift of the form AF used to designate courses of values are meaningless, and that all sentences containing such expressions are neither true nor false. We need, Nally, to understand why. 155. 5. Courses of values and basic law v. We must set up a warning sign visible from afar. Let no one imagine that he can transform a concept into an object. Letter to Honigswald, 1925. A central insight of Frege's logic as understood here is that thoughts, the contents of sentences as they are involved in judgment and inference, must be variously analyzable into function and argument. Frege did at RST think that sentential content in this sense could be given by truth conditions, by what is the case if a sentence is true, but by the early 1890s he had seen that what a Begriffsschrift sentence expresses is not truth conditions but instead sin, an inferentially articulated thought through which a truth value, either the true or the false, is designated. At the same time Frege made another, less happy move. He introduced the notion of an extension, more exactly, that of a course of values or value range, and the law that mutually subordinate concepts share a course of values in common. As Russell's paradox shows, this law is not true. The notion of an extension or course of values, Frege eventually came to think, is Asian. An account of why Frege's logicism required law v, and of why law v must be rejected, is the essential last step in the study of Frege's logic. 5.1 Frege's Grundlagendefinition of number. The aim of Frege's logicism was to show that arithmetic is merely derived logic, that there are no peculiarly arithmetical modes of inference, no concepts of arithmetic that are not definable in purely logical terms. The concept number, in particular, was to be shown to be strictly logical. In Grundlagen the task is conceived in explicitly Kantian terms. What is to be demonstrated is that Kant's thesis that without sensibility no object would be given to us, although perhaps true of actual objects, is not true of numbers. 156. That in arithmetic we are not concerned with objects which we come to know as something alien from without through the medium of the senses, but with objects given directly to our reason. The demonstration is in 3 stages. First, the tempting but ultimately misguided idea of defining a number by its conditions of application, for instance, the number 0 as belonging to a concept if the proposition that it does not fall under that concept is true universally, whatever a may be is sketched and it's critical or revealed. The proposed definition, although it sets out adequate circumstances of application of a number, does not include the consequences of its application, that is, what follows from a number's belonging to a concept. In particular, it does not allow one to infer that, if the number A belongs to the concept F and the number B belongs to the same concept, then necessarily A equals B. What is deemed in the RST definition are not the numbers 0, 1, and so on, but instead the phrases the number 0 belongs to, the number 1 belongs to, and so on. Because, as seems obvious to Frege, numbers are self-subsistent objects that can be recognized as the same again, the strategy must be rejected. The lesson of the RST Grundlagendefinition is that number words are to be understood as standing for self-subsistent objects. The second definition aims, then, to X the sense of the sentence the number belonging to the concept F equals the number belonging to the concept G. Appealing to Hume's principle that when two numbers are so combined as that the one has always an unit answering to every unit of the other, we pronounce them equal, the sense of our sentence is to be the same as the sense of the sentence the concept F is equal to the concept G, where two concepts are equal in this technical sense if and only if the objects that fall under them can be put in a one-to-one correlation. Frege's example in Grundlagen of the strategy is the transformation of the sentence A/B into an identity, the direction of A equals the direction of B. Because Frege introduces object names for courses of values in essentially the same way in Grundgesetze, it is critical that we have an account of just how this strategy is supposed to work. The general strategy is to carve up the content in a new way different from the original way, that is, to analyze a given sentence in a new way. Consider, to begin with, a different case. Say, the English sentence 2 is a fourth root of 16. This sentence would seem to be about the number 2 and to ascribe to that object the property of being a fourth root of 16. Contained in the predicate is a fourth root of 6. 157. Teen is an object name for the number 16 and, less obviously, an object name for the number 4. In virtue of that fact, the sentences 16 is a fourth power of 2 and 4 is a logarithm base 2 of 16 can be taken to present the same sense as that presented in the RST of our three sentences, but in two different ways. Each of the three sentences so read presents one and the same sense under an analysis into function and argument, a different one in each case. In a perspicuous formula language of arithmetic, all these sentences receive the same expression. 2 4 equals 16 expresses the computational content that is common to our three sentences of English. It presents an arithmetical thought and can be variously analyzed. Consider now the sentence work A is same authored with work B, where two written works stand in the same authored relation just in case they have one and the same author. This relation is clearly symmetrical, transitive, and reexhive. The same authored relation sorts written works into equivalence classes, each of which contains all and only the written works that have the same author. This relationship is also obviously grounded in another relation that each of the works that are same authored bear to some other object, namely, the person who is their author. The relation same authored holds between two works A and B in virtue of the fact that there is a person C such that A was written by C and B was written by C. In the sentence A is same authored with B, reference to this person is buried in the relation expression much as reference to the number 4 is buried in the predicate is a fourth root of 16. But just as we did before, we can bring out this reference to C by carving up the content in a way different from the way it is carved up in A is same authored with B to yield the sentence the author of A equals the author of B. That is, just as 2 is a fourth root of 16 expresses a sense that can be variously analyzed, so A is same authored with B expresses a sense that can be variously analyzed, for instance, also as the author of A equals the author of B. The strategy is clearly legitimate for this case and more generally for cases in which the relation in question is not only reexhive, symmetrical, and transitive, but also grounded in another relation that the relevant objects bear to some third object. Where R is an equivalence relation and there is an object C and a relation R** such that arb if A are C and B are C, the sentence arb can be carved up in a new way to yield the sentence the one that is R** to A equals the one that is R** to B. Where two objects merely share a property, for instance, the property of 158 being a certain color, the legitimacy of the strategy is less obvious. If an object A is some color and the object B is the same color, then we can say that A is same colored with B. Same colored is an equivalence relation, but we would not ordinarily say that that relationship is grounded in another relation that A and B both bear to some third object C. Two objects that are same colored are not same colored in virtue of there being some color, some object, to which they are both related. Colors are not objects, self-subsistent entities that can be or fail to be identical to other objects, they are properties of objects. Because they are properties rather than objects, the strategy of the second definition would seem not to apply to this case. Yet Frege clearly does seem to think that the strategy applies even in a case such as that of being same-colored. Instead of the segments are identical in length, we can say the length of the segments is identical or the same, and instead of the surfaces are identical in color, the color of the surfaces is identical. There are two possibilities. Either Frege thinks that an equivalence relation alone is sufficient for the strategy of the second definition to be applied, Or he thinks that even in these sorts of cases there is an object that grounds the equivalence relation. The latter seems to be Frege's view. First, he does not think that objects can be created at will. Even the mathematician cannot create things at will, any more than the geographer can. He too can only discover what is there and give it a name. We cannot, then, simply postulate that there is something, that is, some object, to which all and only the objects standing in an equivalence relation are related. We can only discover such an object and give it a name. For the strategy of the second definition to apply to a sentence arb, there must be an object C and a relation R** such that A are C and B are C. All the strategy of the second definition can do is to provide a means of recognizing this object. It cannot create it. If mathematicians cannot create things at will but only discover what is there and give it a name, then Frege, if he is to apply the strategy of the second definition to the case of parallel lines, must have independent grounds for thinking that there exists an object to which two parallel lines are related. And so he does. Taking the concept direction as the concept point at infinity that parallel lines share, Frege shows in his dissertation that points at infinity are objects, properly speaking, by producing them by projecting the plane on a sphere from a point on the sphere which is neither the nearest nor the furthest. Such a projection yields us in 159 tuitions of such points, puts them before our eyes. As the sort of beings we are discover Euclidean space and only as a result of a process of intellectual activity discover the points at infinity of projective space. In the order of knowing, then, in the historical and psychological order, directions conceived as points at infinity are essentially derived. In the order of being, however, they are perfectly self-subsistent entities. We only come to discover points at infinity through our understanding of parallel lines, but they are not themselves logically dependent on the concept parallel. In this case, then, just as in the case of being same-authored, we can know already that there is an object to which both the lines A and B are related. Because there is such an object, it is legitimate to transform the sentence relating them into an identity of objects. The direction of A equals the direction of B. Both in his critique of formalist theories of arithmetic and in his directions example, Frege provides grounds for our taking the strategy of the second definition to apply only in cases in which there is independent reason to think that there is something, an object, to which the relevant objects are related. The case of same-colored objects is more difficult, for surely in this case there is no third thing that two objects are related to in virtue of being same-colored. In fact, for a time, Frege thinks there is. Not only can we analyze the sentence O is read as involving the function xi is read for argument O, or as involving the second-level function phi is true of O for argument xi is read, but we can also analyze it as involving the RST-level relation xi falls under zeta for the arguments O and the concept read, where both O and the concept read have the logical status of objects, that is, of complete or saturated self-subsistent entities. The concept read does not designate the same entity as psi is read does though, as the two expressions suggest, the two entities that are designated are related to one another but it does designate an entity, and as its name suggests, that entity is an object, complete and self-subsistent. The point is made in on concept and object. The concept as such cannot play this part, in view of its predicative nature, it must RST be converted into an object, or, speaking more precisely, represented by an object. We designate this object by prefixing the words the concept, e.g. the concept man is not empty. Here the RST3 words are to be regarded as a proper name, which 160 can no more be used predicatively than Berlin or Vesuvius. The sentence the concept man is realized, Frege thinks, has the same logical structure as the sentence Julius Caesar is realized. The latter sentence is false because the assertion that something is realized, can only truly make of such objects as stand in quite special relations to concepts. But it does express a sense, just as the sentence the concept man is realized does. Both are about self-subsistent objects, in the one case the man Julius Caesar, in the other the concept man. Much as an identity A equals B, though it is most naturally analyzed as involving a relation and two objects, can also be analyzed as involving an object and a function, psi equals B, so, Frege thought for a time, a simple predication, phi, though it is most naturally analyzed as involving an object A and a function f psi, can also be analyzed as involving a RST-level relation and two objects. The concept f is not identical to f psi. One could not, for instance, take the concept f as the argument for the second-level function phi. That would be nonsense. Nevertheless, Frege suggests, the sentence phi can, on the relevant analysis, reveal an object, namely, the concept f, just as, on another analysis, it reveals a concept, f psi. Hence, in whatever equivalence relation two objects might stand, one to another, in virtue of their sharing a property, the content of a sentence that ascribes that relation to those objects can be differently analyzed so as to yield a strict identity. Now we apply the point to the case of equal concepts, stipulating that the number of f equals the number of g is to have the same sense as the sentence the concept f is equal to the concept g, where two concepts are equal in this technical sense just if the objects that fall under them can be correlated one-to-one. In this way we discover the number that is assigned to the concept f and give it a name, or rather, we could count as having done so were we able to assume already the concept number. Frege rejects his second definition on the grounds that it does not settle all identities but only those of the form the number belonging to the concept f equals the number belonging to the concept g. If we already had the concept number, the definition would be adequate, because if we already had the concept number, then we could. 161 Lay it down that if for some object O is not a number, then the thought expressed by the sentence O is identical to the number of f's is to be denied. But the logicist cannot take the concept number for granted. That number is a purely logical concept must be proved, and it cannot be proved simultaneously with a definition of the numbers via Hume's principle. 2. We must try another way. Frege's RST definition fails because it does not yield names for numbers. The second definition fails because its adequacy presupposes the notion of number. What is needed, then, is a definition of the numbers conceived as self-subsistent objects that avoids any reliance on the concept number. Frege's third-Grundlagen definition will, he thinks, serve, the number which belongs to the concept f is the extension of the concept equal to the concept f. 3. We are to understand numbers as extensions of second-level concepts, though, Frege notes, the definition could also be written in a way that makes no reference to extensions. For extension of the concept we could write simply concept. Because, as Frege goes on to show, both Hume's principle and a definition of the concept number can be derived on the basis of this definition, the definition is adequate. It also can seem to come out of nowhere. To see that it does not, to see that Frege's third definition is the natural culmination of the discussion so far, we need to set it against the background of Kant. Frege's task in Grundlagen is to show that numbers, self-subsistent objects, can be given directly to reason. It must be shown, through logical concepts alone, that there are numbers having the arithmetical properties numbers are known to have. The task is to x the sense of expressions, object names, of the form the number belonging to the concept f, that is, to set out not only the circumstances but also the consequences of the use of such expressions in judgments, and to do so without appeal to the concept number. 2 hurdles must be overcome. The RST is the general point, due to Kant, that concepts, even in their singular use in finite descriptions, cannot function logically as singular representations of objects for the simple reason that objects are thoroughly determinate and concepts are inherently determinable. Even if we have a concept that we apply immediately to individuals, there can still be specific differences in regard to it, which we either do not note, or which we disregard. For it follows, Kant thinks, that there can be thoroughly determinate cognitions only as intuitions, but not as concepts, in regard to the latter, logical. 162. determination can never be regarded as completed. Because a finite description determines an object by way of marks that are in principle common to many, such a description, although it may happen to be true of one and only one object, is unlike an object name in that it could as well be true of others, or of nothing at all. As Kripke would put the point, finite descriptions, unlike object names, are not rigid designators. 5. On the Kantian view, one can use a concept word with the finite article as a kind of referring expression, that is, use it as a means of referring to a particular object that one has in mind, but the expression itself does not amount to, that is, function logically as, an intuition. Frege disagrees, and he does so because he distinguishes, though in Grundlagen only implicitly, between the inferentially articulated sense of an expression and that which it designates. Given this distinction, the fact that a finite description such as the last great philosopher of antiquity would designate not Aristotle but instead someone else in a different possible situation cannot be used to show that such a description functions in a way that is logically different from the way an object name such as Aristotle functions. 4. On Frege's mature view, the name Aristotle is no more a mere label than the numeral 3 of the Arabic notation is a mere label. Both object names express senses. Similarly, the description the last great philosopher of antiquity is no more a mere description than the expression the sum of 2 and 3 is. Both expressions designate objects. Provided one understands the logical functioning of the language as Frege does, in terms of the logical distinction of Sinn and Bedeutung, there is in principle no difficulty with using a finite description to X the sense, and thereby the reference, of an object name. If we already had the concept number, we could deem the numbers by way of definitions of the form the number belonging to the concept f, the number 0, for instance, as the number belonging to the concept not self-identical. This is, furthermore, the most natural way to think of a finite description, as of the form the k that is f, where k is the governing sortal that x is the kind of thing that is being introduced and f the uniquely identifying description of the particular k that is wanted. Frege's problem is that he cannot, for the purposes of logicism, assume the concept number as given. That concept must be derived from purely logical notions, that is, shown to be strictly logical. Frege needs another way. It is provided by his newly discovered notion of a second-level concept introduced already in Grundlagen 53. 163. Kant argues that even in their singular use in finite descriptions, concepts do not function logically as singular representations of objects because objects are thoroughly determinate, whereas concepts are inherently determinable. The concept house that Jack built, for instance, can be made more determinate by conjoining the concept stone to yield stone house that Jack built, or by conjoining the concept built with Jane to yield house that Jack built with Jane. The process is, as Kant says, endless. In regard to the latter, logical determination can never be regarded as completed. 6. One can always add another predicate to yield a more determinate concept. One can approach the limit of a thoroughly determinate cognition through concepts, one cannot achieve it. More exactly, one cannot achieve it if one pursues Kant's strategy of conjoining concepts. The alternative, Frege's strategy, is to appeal to a second-level concept under which fall all and only the RST-level concepts through which the object in question can be given. The strategy is a good one because, as Frege says in obvious reference to Kant, the concept has the power of collecting together far superior to the unifying power of synthetic apperception. Although a thinker could not collect together all the requisite concepts to yield a fully determinate concept of an individual, a concept can. So, instead of trying to deem a number by using a description of the form the number of f's, where number is functioning as the governing sortal, we deem a number in terms of the second-level concept equal to f under which fall all and only the RST-level concepts to which some one number is assigned, thereby achieving a kind of all-sided determination of that number, a definition within which is contained all the ways it can be given. Obviously, then, the definition X is all identities, it solves the Julius Caesar problem. We can furthermore simply identify the number with this second-level concept. Frege seems to have thought at this point, because any sentence that contains a concept word for the second-level concept phi is equal to the concept f can yield an object name, the object name the concept equal to the concept f, on a different analysis. Because the move might seem to a reader to be paradoxical, given that concepts are not objects, Frege suggests that the same effect can be achieved by appeal to the extension of the concept equal to the concept f. A central task of Grundlagen is to show, if only in outline, how through logic alone numbers are given to reason. Frege approaches this goal in 164 stages, each of which is to help us see why the next is needed. At the RST, we are given the necessary and sufficient conditions for assigning a number to a concept, but because this does not adequately x the consequences of assigning a number to a concept, the RST definition is rejected. What is needed, we are now to see, is a definition of the number itself. The second stage is set by Hume's principle together with the idea, fundamental to Frege's conception of a properly logical language, that a sentence can be analyzed into function and argument in various ways. The number of fs can be deemed as the number of gs by way of a different analysis of the content expressed by the concept f is equal to the concept g. This strategy, we have argued, requires that there be independent grounds for thinking that the relevant object exists. The content of a sentence arb, where R is an equivalence relation, can be differently analyzed to yield the sentence the f equals the f only in the case in which there is a third object C and a relation R** such that if arb then A are C and B are C. Yet, Frege thinks, the strategy can be applied even in the case in which, so it would seem, there is no such object, for instance, in the case of two objects that are the same color. He does so, we have seen, because he thinks, for a time, that corresponding to any concept such as xi is red there is an object, the concept red. Because, on that view, any equivalence relation is grounded in a relation to some third thing, the strategy can be applied to Hume's principle to yield the second Grundlagen definition of number. But this definition too is quickly rejected. Even it does not give the definition that is wanted because it does not x the truth values of all identities, though it would if the logicist program were to be abandoned and the concept number accepted as a primitive notion in arithmetic. Because the logicist cannot accept the concept number as primitive, the proposed definition is not, properly speaking, a definition of a number at all. The most natural form of a definition of an object through concepts is by way of a definite description of the form the k that is f, where k is the governing sortal and f a uniquely identifying mark of the k that is wanted. But as Frege sees, this is not the only form such a definition can take. If one conjoined all the ways an object could be given, thereby achieving something very much like a Leibnizian individual concept, an all-sided determination of the object then appeal to a sortal could be dispensed with. This, it has been suggested, is Frege's strategy in the third definition. Appealing to a second-level concept under which all the relevant RST-level concepts fall, thereby joining all the ways the deemed object can be. 165. Given, the third Grundlagen definition uniquely identifies the number that is wanted. The number of fs is the concept equal to f. 5.2 A further difficulty. Frege claims in Grundlagen that he no decisive importance even to bringing in the extensions of concepts at all in his definition of number. The number of fs, he suggests, could be deemed simply as the concept equal to f. In Grundgesetze we are told that we just cannot get on without them. Numbers, Frege had come by 1893 to think, can be apprehended only as extensions, more exactly, courses of values, of concepts. 7. The notion of a course of values must, then, be admitted in logic, though, as Frege notes already in the introduction to Grundgesetze, a reasonable person might legitimately question its admission. A dispute can arise, so far as I can see, only with regard to my basic law concerning courses of values, which logicians perhaps have not yet expressly enunciated, and yet is what people have in mind, for example, where they speak of extensions of concepts. I hold that it is a law of pure logic. In any event, the place is pointed out where the decision must be made. 8. Basic law V was not immediately evident in the way that a basic law of logic ought to be, and yet, Frege came to think, there was no other way to formulate logically adequate definitions of the numbers. Only with difficulty, he writes to Jourdain in 1910, did I resolve to introduce classes, because the matter did not appear to me quite secure, and rightly so, as it turned out. But, as he goes on, there seemed no other way. By this I was constrained to overcome my resistance and to admit the passage from concepts to their extents. And, after I had made this resolution, I made a more extended use of classes than was necessary, because by that many simplifications could be reached. I confess that by acting thus, I fell into the error of letting go too easily my initial doubts in reliance on the fact that extents of concepts have for a long time been spoken of in logic. In a letter to Honigswald, written in the last months of his life, Frege writes that he found the expression the extension of f very convenient, that while I sometimes had slight doubts during the execution of the work, I paid no attention to them. The notion of an extension. 166 was logically suspect, and yet it seemed to Frege overwhelmingly likely that arithmetic is merely derived logic. The trouble was that the means by which to show that it is had come to seem to require appeal to extensions. To understand the nature of this difficulty, we need to understand both Frege's reservations about extensions and how those reservations were overcome. Although every object is some kind of thing or other, whether essentially or not, the notion of an object is not logically dependent on the notion of a function. The two notions are rather correlative, neither fully intelligible without the other. But, Frege suggests in function and concept, the notion of a function is fully intelligible without the notion of an extension, whereas the converse is not the case. Function, in the sense of the word employed here, is the logically prior notion. The reason the notion of an extension is not intelligible except in terms of the logically prior notion of a function is revealed by comparison with the notion of a manifold, that is, an aggregate or collection of objects. First, whereas one can talk of parts and wholes in the case of a manifold, for instance, that one manifold is a part of another, no distinction can be drawn between membership in a manifold and the inclusion of one manifold in another. Parts of wholes that are manifolds are at the same time parts of the wholes themselves. There are, then, no proper elements in a manifold. The collection of books can be divided ad infinitum. The books can be regarded as a collection of pages, of parts of pages, of burrs, of molecules, of atoms, and so on. Furthermore, because a manifold just is a collection of objects, there can be no empty manifold. A class, in the sense in which we have so far used the word, consists of objects. It is an aggregate, a collective unity, of them. If so, it must vanish when these objects vanish. Extensions, we will see, are quite different from such manifolds. Collections of objects are entities whose parts are held together by some relation or interaction. Such relations may be spatial, temporal, physical, psychical, legal, even intervals of pitch. Collections of objects can be held together by customs, institutions, and laws. An extension, by contrast, is a logical unity held together by a concept. A whole, a system, is held together by relations, and these are essential to it. An army is destroyed if what? 167 holds it together is dissolved, even if the individual soldiers remain alive. On the other hand, it makes no difference to a class what the relations are in which the objects that are members of it stand to one another. Secondly, if we are given a whole, it is not yet determined what we are to envisage as its parts. As parts of a regiment I can regard the battalions, the companies, or the individual soldiers, and as parts of a sand pile, the grains of sand or the silicon and oxygen atoms. On the other hand, if we are given a class, it is determined what objects are members of it, For wholes or systems we have the proposition that a part of a part is part of the whole. This proposition does not hold for classes as regards the objects that are members of them. The extension of a concept is constituted in being, not by the individuals, but by the concept itself, i.e. by what is said of an object when it is brought under a concept. There is then no objection to our talking about a class of objects that are BS even when there are no BS. Moreover, all empty concepts now have the same extension. An extension cannot be divided ad infinitum, and it can be empty. An extension, then, cannot be identified with a collection of things or manifold. It is not a physical object but a logical one. Any object, and any collection of objects, can be arrived at in different ways, can be thought of in different ways, and can be divided into parts in different ways. An extension, though it can, we will see, be arrived at in different ways and can be thought of in different ways, cannot in the same way be divided into parts in different ways. An extension is not, then, merely a collection of objects. It is a logical object grounded in a concept that determines the principle of inclusion in it. That is why there can be an empty extension though there is no collection of zero objects. What is less clear is why, if an extension has its being in a concept, there is only one extension where two concepts are mutually subordinate rather than two. As Russell puts the worry in a letter to Frege of July 24, 1902. In general, if one connects ranges of values closely with concepts, as you do, it seems doubtful whether two concepts with the same extension have the same range of values or only equivalent ranges of values. It hard to see what a class really is if it does not consist of objects but is nevertheless supposed to be the same for two concepts with the 168 same extension. Yet I admit that the reason you adduce against the extensional view seems to be irrefutable. Every day I understand less and less what is really meant by the extension of a concept. The puzzle is resolved by Frege's mature extensionalist conception of concepts according to which mutually subordinate concepts are really one and the same concept thought under different aspects. Concepts differ only insofar as their extensions are different. Concepts cannot themselves be identical, strictly speaking, because the relation of equality, by which I understand complete coincidence, identity, can only be thought of as holding for objects, not concepts. Nevertheless, the relation we had in mind above holds between the concept phi and the concept chi, if every object that falls under phi also falls under chi, and conversely. In such cases it is not the meaning, Bedeutung, that is different, but only the sense. That is why extensions can be thought of in different ways, arrived at in different ways, despite the fact that they cannot be divided into parts in different ways. If two concept words express different senses although they designate one and the same concept, then names for the extension of that concept formed from those two concept words will also differ in sense although they designate one and the same extension. If extensions are objects that have their being in concepts, then they are not properly objects at all. They are not self-subsistent. At the same time, however, Frege was becoming increasingly dissatisfied with the idea that a concept can itself be transformed into a kind of object so that an object that is connected with it in accordance with a rule be substituted for it. By 1893 that idea had been dropped altogether. The thought that a sentence phi can be analyzed as involving a relation, zeta, for two objects as arguments, namely, the concept f and a, had been a mistake. The relevant relation is unequal, taking as arguments not two objects but instead an object and a concept. In phi psi occupies and renders recognizable the place of the object argument and phi that of the function argument. There is a relationship of objects in the vicinity, but, Frege now holds, it must involve an explicit transformation of a concept word into a name for a course of values. A sentence such as phi, we are told, means the same as a mathematical intersection symbol AF. 169. Courses of values are objects, concepts are not. Frege explains the point in a 1906 discussion of Skirny's die logischan paradoxiender Mengenlehre. Language brands a concept as an object, since the only way it can tie the designation for a concept into its grammatical structure is as a proper name. But in so doing, strictly speaking, it falsies matters. In the same way, the word concept itself is, taken strictly, already defective, since the phrase is a concept requires a proper name as grammatical subject, and so, strictly speaking, it requires something contradictory, since no proper name can designate a concept, or perhaps better still, something nonsensical. The point is made again in the 1906 to Logic, in 1914 in Logic in Mathematics, in 1919 in the Notes for Ludwig Darmstädter, and nally in the essay Sources of Knowledge written in the last year of Frege's life. Natural language, in collusion with Frege's insight into the way sentences are variously analyzable into function and argument, had misled Frege into thinking that corresponding to any concept, for instance, that designated by psi, there is an object f, that is, the concept f. But there is no such object. Concepts are inherently unsaturated. But if there are no objects that are concepts, a number cannot be deemed by appeal to such an object. Numbers must, then, be extensions of concepts. But are extensions really objects? Frege's reactions on the differences between a manifold or collection of objects and an extension suggest that they are not. Extensions have their being in concepts, they are not self-subsistent. Yet, we have seen, the strategy of the second definition requires that the equivalence relation in question be grounded in another relation that the relevant objects bear to some third thing. The strategy cannot create the relevant object but only discover and name it. It requires, then, that we have some independent grounds for thinking that there are such objects as the strategy reveals. What is the logicist to do? The strategy of the second definition, and of basic law V, is to transform a sentence of the form arb, where R is reexive, symmetric, and transitive, into an identity of the form the F equals the F. It is legitimate, we have suggested, only if it is known that there is an object C and a relation R** such that A are C and B are C. Frege, then, must show that there is something, that is, some object, to which both concepts are related in the case in which they are mutually subordinate. He must produce the object. 170. That is related in common to two concepts that are mutually subordinate, because if he does not, his account falls into the error of formalist theories, the error of creating things at will. But Frege has good reason to think that an extension is not, properly speaking, an object at all, that it is not a self-subsistent entity but instead something that has its being in a concept. How, then, does Frege let go his doubts? He does so in essentially the way we let go our doubts about directions, by producing the relevant object in an intuition, by putting it before our eyes. As Frege argues in Function and Concept, although a function is not merely a set of ordered n-tuples of points but is instead a law of correlation determining that set, a function can nonetheless be intuitively represented as a curve in Cartesian coordinates. If we regard the argument as the numerical value of an abscissa, and the corresponding values of the function as the numerical value of the ordinate of a point, we obtain a set of points that presents itself to intuition as a curve. Any point on the curve corresponds to an argument together with the associated value of the function. Thus, example y equals x2 for x yields a parabola. Furthermore, it is clear that where the values of two functions are the same for every argument, they yield the same curve in Cartesian coordinates. The curve we get from y equals x2 for x is the same as the one that arises out of y equals x. Speaking more exactly, it is the same function that is designated in both cases. The expressions x and x2 for x designate one and the same function but differ in sense. But that does not affect the essential point, that there is a curve that arises out of the function. The curve is not a representation of the function itself. It cannot be, because a function is not an object and a curve is a kind of object. Instead, what is intuitively represented in the graph is the values of a function for different objects. Given that such an object can be intuitively represented in this way, we can conclude that there actually is such an object, that is, that it is a self-subsistent entity, like a point at infinity. Because concepts are functions from objects to truth values, they give rise in the same way to objects that are identical one to another just in case the two concepts are mutually subordinate. 171. Frege calls such objects courses of values. Applying the strategy of the second definition, we can, then, transform an equality that holds generally between values of functions into a strict identity of just those objects that are intuitively represented as curves in Cartesian coordinates. We know that an extension is not merely a collection of objects because, RST, collections of objects can be divided into parts in various ways and extensions cannot, and second, there cannot be a collection of zero objects though there can be an empty extension. This was puzzling because it seemed to show that an extension has its being in a concept. If we think instead of the correlation of objects and truth values that a concept determines, the situation is very different. Just as the numbers correlated by a function constitute an object that can be intuitively represented as a curve in Cartesian coordinates, so the objects that are correlated by a concept constitute an object. Obviously we should not expect the parts of this latter to divide into parts. It is given what the arguments are that are correlated with the relevant truth values. Nor should it now seem surprising that there should be something that is an empty extension because that is nothing other than a course of values that has the false correlated with every object as argument. We can, then, let go our initial doubts regarding the self-subsistence of extensions, acknowledge the truth of law V, and get on with the logicist program. Or so, for a short while, it seemed to Frege. 5.3 Russell's paradox. Frege needed basic law V in order to complete the logicist program outlined in Grundlagen. He needed to produce an object as that to which mutually subordinate concepts stand in a relation in order to deem the numbers. Given that arithmetically equivalent functions determine one and the same curve in Cartesian coordinates and that concepts just are functions that take objects as arguments to yield truth values as values, it follows that mutually subordinate concepts determine one and the same value range. We have produced the object that is wanted. But Russell's concept class that does not belong to itself is a logically adequate concept. It has sharp boundaries in Frege's technical sense because it yields either the value true or the value false for every object as argument, tertium non datur. Yet Russell's concept does not determine an extension or course of values. It is, as Dummett argues, a prototypical example of an indefinitely extensible concept, for, once we form a definite conception of a totality W of such classes, it is evident that W cannot, on pain of con. 172 Tradiction, be a member of itself, and thus the totality consisting of all the members of W, together with W itself, is a more extensive totality than W of classes that are not members of themselves. 9 In the case of a concept such as Russell's, a concept that has sharp boundaries in the sense of yielding a value for every object as argument but is indefinitely extensible, there is no course of values by means of which it can be represented in logical space. It is, then, false that having sharp boundaries in Frege's technical sense implies that the relevant course of values exists. Law V is not true. Frege argues in Function and Concept that concepts determine courses of values on the grounds that, RST, concepts are functions taking objects as arguments to yield truth values as values, and second, that functions determine curves in Cartesian coordinates. But we know that concepts do not invariably determine courses of values because Russell's concept does not. Does it follow that concepts are not functions from objects to truth values? Certainly that was not Frege's conclusion. Frege nowhere calls into question his logical notion of a concept as a function that yields either the true or the false for every object as argument. It would seem to follow, then, that it is false that functions determine curves in Cartesian coordinates. If it could be shown on independent grounds that this claim is false, that would be enough to establish that the error was indeed to assume that all logically permissible concepts determine courses of values. The thought that arithmetically equivalent functions determine one and the same curve in Cartesian coordinates is certainly intuitive, and it is well illustrated by Frege's example of the function y equals x2 for x equals x, which determines a parabola. Nevertheless, it is not generally true that functions determine such curves. Some functions do not determine any curves at all in Cartesian coordinates. One such function is the Cook curve, which Friedman has characterized thus. We start with a horizontal line segment of which we divide into three equal parts by points C and D. On the middle segment CD we construct an equilateral triangle set and erase the open segment CD. We repeat the same construction on each of the segments AC, CE, ED, DB, NALI. We continue this process indefinitely on each remaining segment. The resulting curve is continuous, but at no point is there a welding tangent. No night segment of the Cook curve can be drawn by the continuous motion of a pencil. We must think of each point as laid down independently, as it were, yet nevertheless in a continuous order. 10. 173. Though the Cook function is continuous, it is nowhere differentiable. It follows that we cannot draw such a curve, cannot represent the function intuitively as a curve in Cartesian coordinates. There is simply no such curve, and we know that there is no such curve because its representation involves continuing indefinitely a process of construction on segments. In just the same way the representation of the class that is the extension of the concept class that does not belong to itself involves continuing indefinitely a process of construction on classes. There is no curve that is the Cook curve, and there is no class that is the class of classes that do not belong to themselves. Mathematicians long assumed that continuity entails differentiability, and they did so, at least in part, because continuity was understood intuitively, in terms of the idea of continuous motion. Functions such as the Cook curve show that this intuitive character is a mere appearance, an irrelevant accretion to the concept of continuity that must be stripped off it if we are to grasp the concept in its pure form. Similarly, we assume that every logically permissible concept, that is, every concept with sharp boundaries in Frege's technical sense, determines a course of values, and we do so, in part, because the idea of sharp boundaries is conceived intuitively as involving the idea of something literally like a bounded space. Russell's concept class that does not belong to itself shows that this intuitive character is a mere appearance, an irrelevant accretion to the concept. It must be stripped off if we are to grasp the concept of a concept in its pure form. Frege's law v, according to which it can be inferred from the mutual subordination of two concepts that they share something in common, namely, an extension or course of values, is not true. Though some concepts do determine courses of values, there is nothing in the very idea of a concept that requires that concepts determine courses of values. All that logic requires of a concept is that it yield a truth value, either the true or the false, for every object as argument. 174. ADCB. F. E. 5.4 A Final Reckoning. Frege always had doubts about the logician's notion of an extension, for, as he saw, an extension is essentially different from a collection or manifold of objects. It is a logical object that has its being in a concept that exes a principle of inclusion in the extension. Because an extension so conceived is not self-subsistent, it is not an object, properly speaking, at all. Yet, as Frege came to see, his logicist program of deriving the truths of arithmetic from logic alone required that there be some such objects. If Frege's life's work was to be completed, he had somehow to end sufficient reason to let go his initial doubts. He had to articulate a conception of an extension that was manifestly a conception of a self-subsistent object. Frege's notion of a course of values modeled upon that of a curve in Cartesian coordinates was, he thought, just the conception that was needed. Although an extension conceived as the set of objects falling under a concept is not self-subsistent but has its being in that concept, an extension conceived as a correlation of objects and truth values, that is, as a kind of curve in logical space, is a self-subsistent object. Because any logically permissible concept has sharp boundaries in the sense of yielding a truth value for every object as argument, it seemed reasonable to conclude that corresponding to every concept there is such a curve. Frege had discovered, so he thought, a logically permissible conception of an extension on which to found his logicist program. In the Grundgesetze, we have seen, Frege claims that a dispute can arise, so far as I can see, only with regard to my basic law concerning courses of values. It is clear, nonetheless, that he does not think that any substantive objection to it can be made. No one, he contently claims in the conclusion of the, will be able to demonstrate that his principles lead to manifestly false conclusions. When Russell demonstrated exactly that, Frege was, he says, surprised, beyond words and, I should almost like to say, left, thunderstruck. For a time Frege continued to think that a logically permissible conception of an extension might yet be found. Eventually he came to see that the hope was forlorn. The paradoxes of set theory have dealt the death blow to set theory itself. The notion of an extension is Asian. No concept is designated thereby. Law v is bedeutungslos. In Russell's original formulation of it in his letter of June 16, 1902, the paradox arises because one allows a function to serve as an argument for a function at the same level as the original function. But, as Frege notes in 175, his reply of June 22, 1902, a RST-level function, requires an object as argument and, cannot therefore have itself as argument. In Frege's logic the paradox can be formulated only in light of basic law v, which enables a concept to be transformed into an object that can then serve as an argument for the original function. In the 1879 logic Frege does not allow functions to serve as arguments for functions at the same level, though he does not explicitly outlaw this either, and he does not have any mechanism for transforming a function into an object. There is no trace of law v in the early Begriffsschrift, and this is to be expected, given Frege's early dissatisfaction with the notion of an extension. Furthermore, Frege has already in the notation of his logic implicitly marked the distinction of RST and second-level functions. Frege's concavity notation with German letters enables him to form concept words for second-level concepts that are manifestly different in form from concept words for RST-level concepts. Again, Frege does not explicitly note the distinction between RST and second-level concepts in Begriffsschrift, but it is marked already in his notation and is respected in his inferential practice. By 1893, we have seen, Frege came explicitly to recognize the distinction between lower and higher level concepts and began self-consciously to understand the role his concavity notation plays in the formation of concept words for second-level concepts. At the same time, he introduced law v, but its introduction, we have seen, was wholly driven by the demands of his logicist program. It was also apparently legitimate by the fact that any arithmetical function can be represented as a curve in Cartesian coordinates. This fact, we have seen, is no fact at all, it is not true. Basic law v is similarly untrue. It does not follow from the concept that any concept determines a course of values. Some concepts, Russell's, for example, do not determine a course of values. Law v, and with it Frege's logicist program, must be jettisoned. 11 Because that leaves untouched both the distinction between RST and second-level concepts and the demand that only a lower-level function can serve as an argument for a higher-level function, Russell's paradox cannot be formulated. Basic law v, as well as everything that in any way depends on it, must be banished from logic, but, just as Frege claims, logic itself, at least in its principal parts, those dealt with in the 1879 Begriffsschrift, remains intact. In my fashion of regarding concepts as functions, we can treat the principal parts of logic without speaking of classes, as I have done in my Begriffsschrift, and that difficulty does not then come. 176. Into consideration. Basic law V is needed for Frege's logicism. It is not needed, either explicitly or implicitly, in his logic. As here understood, Frege's logic is founded on a distinctive conception of a law as a principle that governs inference. Laws, on this conception, have the form of rules according to which to reason as they contrast with premises from which to reason. Sentences of Begriffsschrift that express such laws take the form of generalized conditionals, or genuine hypotheticals, where such sentences are to be understood as relating concepts one to another. It follows, as Frege comes explicitly to see in the mature logic, that concepts must be something in their own right, something objective, albeit unsaturated or incomplete. Just as objects can, concepts, as Frege regards them, can stand in relations and can serve as arguments for concepts. No recourse to the objects that fall under the relevant concepts is needed to understand logically general sentences of Begriffsschrift. As Frege's mature understanding of the quite different roles played by his Latin italic letters and his concavity with German letters makes abundantly clear, though a generality of the form f is true just in case the concept f psi yields the value true for every object as argument, the thought expressed by the sentence does not in any way involve reference to a totality of objects. The thought involves only the senses of concept words. Relative to one analysis, for instance, it ascribes the second-level concept phi to the concept f psi. Relative to another, it ascribes the third-level concept beta to the argument phi, and so on. On no analysis does it yield an expression that designates an object or a collection or totality of objects. Just as Frege says, the difficulties which are bound up with the use of classes vanish if we only deal with objects, concepts, and relations, and this is possible in the fundamental part of logic. More exactly, this is possible in the fundamental part of Frege's logic. 177. Epilogue. What pig-headedness! This way academics have of behaving reminds me of nothing so much as that of an ox confronted by a new gate. It gapes, it bellows, it tries to squeeze by sideways, but going through it that might be dangerous. Introduction to Logic, 1906. Frege's logic is distinctive in giving pride of place to the content of the word true. This does not mean, however, that sentential meaning is given by truth conditions in his logic. In Frege's logic, at least as it has been read here, that notion of meaning is to be split into the thought expressed by a sentence and the truth value designated. The reason it must be so split goes to the very heart of Frege's logic. Thoughts must be variously analyzable into function and argument. Judgment and inference, that is, the acknowledgement of the truth of a thought either directly, on its own merits, or on the basis of other judgments, can be adequately understood in no other way. Frege's two-dimensional notation puts this insight before our eyes. Rather than directly saying something about something, a sentence of Begriffsschrift presents, in a two-dimensional array, a thought that can be variously analyzed into function and argument, and only relative to such an analysis into function and argument does it ascribe a concept to an object. Even in the simplest cases more than one analysis is possible. As Frege clearly saw, no linear notation can adequately express thoughts so conceived. Nor is it only Frege's strange two-dimensional notation that is provided a properly logical justification on our reading. The judgment stroke, which has no place in a quantificational logic, is essential to Frege's logic as it is understood here because conclusions can be drawn in that logic only from premises that are, and are acknowledged to be, true, where this stipulation is required in turn because in Frege's logic generality is understood rst and foremost in terms of the notion of an inference license, something according to which to reason rather than something from which to reason. Generalized conditionals of Begriffsschrift count as, or have the status of. 178. Laws governing inferences. In this, Frege's logic as here construed is diametrically opposed to a quantificational logic, whereas the quanticational logician begins directly with truth and aims to construct truth conditions adequate to capture inference potential. Frege begins instead with inference potential. What follows if a sentence is true, and only relative to an analysis aims to specify truth conditions. Frege's use of two different sorts of letters with and without the concavity is also logically justified on our reading. It is justified by the fact that the two sorts of letters play logically different roles, German letters together with the concavity to enable the formation of higher-level concept words and Latin italic letters directly to raise everything up a level. From consideration of properties and relations of objects, the introduction of the literal notation enables consideration of properties and relations of concepts. Then again, given the relevant second-level concept words, the use of the literal notation enables the passage from consideration of properties and relations of RST-level concepts to consideration of properties and relations of second-level concepts. It is at this third level that the concern of the science of logic as Frege comes to understand it is apparent. The concern of logic, as Frege understands logic, is the properties and relations of those second-level concepts that are definable in strictly logical terms. Already in Part 3 of Begriffsschrift Frege shows this concern, only much later does he come to full, self-conscious awareness of it as the concern of logic. Logic, on this view, is a science, and as in any science, its body of truths is fully realized only in an adequate axiomatization. Having given up the uncritical assumption that Frege's logic is a quanticational logic, we were also able to render intelligible all the major developments in Frege's views, both those culminating in the distinction between Sinn and Bedeutung that constitute, on our reading, an extraordinary intellectual achievement, and Frege's misbegotten law v. On our account, Frege's mature logic is, just as Frege himself conceives it, the full owering of the seeds RST planted in the 1879 notation. Taken together, Frege's two-dimensional notation, with its Greek, Latin, and German letters, and his mature understanding of the logical functioning of that language in terms of the logical notions of Sinn and Bedeutung afford us the RST glimpse of a world hitherto unimaginable. As a system of signs, Frege's notation is completely unambiguous. The 179. Only question is whether it is, as standardly assumed, a notation of a logic we already have, albeit remarkably ill-conceived, or whether, as has been assumed here, it is a remarkably well-conceived notation of a logic about which we know nothing. Should we start with quanticational logic and aim to squeeze Frege's work into that mold much as, on Frege's view, Peano aimed to squeeze each formula onto one line? Or should we start instead with Frege's writings, letting quanticational logic fall where it may? The former path is well trodden. The latter might teach us something we do not already know. 180.